testing. Down to 8 days, whatever. And I plan to be done with I'll be on to whatever the ECMA 262 and yeah. So 8 days. It's just not erasing. Erase. It is. This marker's, it's dead. It's a dead marker. This is gonna be like not as long as the other streams. I'll get Siri reading the ECMA 262 whatever. Then I'll turn on the computer. And blah blah blah.
Introduction. This ECMA standard defines the ECMAScript 2024 language. It is the 15th edition of the ECMAScript language specification. Since publication of the first edition in 1997, ECMAScript has grown to be one of the world's most widely used general-purpose programming languages. It is best known as the language embedded in web browsers but has also been widely adopted for server and embedded applications. ECMAScript is based on several originating technologies, the most well-known being JavaScript, Netscape, and JScript, Microsoft. The language was invented by Brendan Eich at Netscape and first appeared in that company's Navigator 2.0 browser. It has appeared in all subsequent browsers from Netscape and in all browsers from Microsoft starting with Internet Explorer 3.0. The development of the ECMAScript language specification started in November 1996. The first edition of this ECMA standard was adopted by the ECMA General Assembly of June 1997. That ECMA standard was submitted to ISO IEC JTC1 for adoption under the fast track procedure and approved as International Standard ISO IEC 16262 in April 1998. The ECMA General Assembly of June 1998 approved the second edition of ECMA 262 to keep it fully aligned with ISO IEC 16262. Changes between the first and the second edition are editorial in nature. The third edition of the standard introduced powerful regular expressions, better string handling, new control statements, try-catch exception handling, tighter definition of errors, formatting for numeric output and minor changes in anticipation of future language growth. The third edition of the ECMAScript standard was adopted by the ECMA General Assembly of December 1999 and published as ISO IEC 16262, 2002 in June 2002. After publication of the third edition, ECMAScript achieved massive adoption in conjunction with the World Wide Web, where it has become the programming language that is supported by essentially all web browsers. Significant work was done to develop a fourth edition of ECMAScript. However, that work was not completed and not published as the fourth edition of ECMAScript, but some of it was incorporated into the development of the sixth edition. The fifth edition of ECMAScript, published as ECMA 262 5th edition, codified de facto interpretations of the language specification that had become common among browser implementations and added support for new features that had emerged since the publication of the third edition. Such features include accessor properties, reflective creation and inspection of objects, program control of property attributes, additional array manipulation functions, support for the JSON object encoding format, and a strict mode that provides enhanced error checking and program security. The fifth edition was adopted by the ECMA General Assembly of December 2009. The fifth edition was submitted to ISO IEC JTC1 for adoption under the fast track procedure, and approved as international standard ISO IEC 16262, 2011. Edition 5.1 of the ECMA and is the same text as ISO IEC 16262.
Really, is the mic not working? Oh my god.
Was adopted by the ECMA General Assembly of June.
Testing.
Development of the 2009 as
Testing.
prepared for publication. However, this was preceded by significant experimentation and language enhancement design efforts dating to the publication of the third edition in 1999. In a very
Could I get like 1 day where something just works? Just 1 day.
year effort.
I want 1 day where something works.
Support for large applications.
Why is the mic not working?
For use of ECMAScript as a compilation target for other languages. Some of its major enhancements included modules, class declarations, lexical block scoping, iterators and generators, promises for asynchronous programming, destructuring patterns, and proper tail calls. The ECMAScript library of built-ins was expanded to support additional data abstraction.
It's gonna take a minute.
The binary numeric values, as well as additional support for Unicode supplementary characters in strings and regular expressions. The built-ins were also made extensive.
Oh, Windows. It switched the default input device. Now it's working.
Language and library
And this computer's not booting.
by the General Assembly of June 2015. ECMAScript 2016 was the first ECMAScript edition released under ECMA TC39's new yearly release cadence and open development process. A plain text source document was built from the ECMAScript 2015 source document to serve as the base for further development entirely on GitHub. Over the year of this standard's development, hundreds of pull requests and issues were filed representing thousands of bug fixes, editorial fixes and other ECMA International 2024 Volt improvements. Additionally, numerous software tools were developed to aid in this effort, including ECMARkup, ECMARkdown, and Grammarkdown. ES 2016 also included support for a new exponentiation operator and adds a new method to array prototype called includes. ECMAScript 2017 introduced async functions, shared memory, and atomics, along with smaller language and library enhancements, bug fixes, and editorial updates. Async functions improve the asynchronous programming experience by providing syntax for promise-returning functions. Shared memory and atomics introduce a new memory model that allows multi-agent programs to communicate using atomic operations that ensure
This Dell, the motherboard, it's whack. It's a whack computer.
values.
Oh, there it goes.
Get own property descriptors. ECMAScript 2018 introduced support for asynchronous iteration via the async iterator protocol and async generators. It also included 4 new regular expression features: the dot or flag, named capture groups, Unicode property escapes, and look behind assertions. Lastly, it included object rest and spread properties. ECMAScript 2019 introduced a few new built-in functions: flat and flat map on array prototype for flattening arrays, Object from entries for directly turning the return value of object entries into a new object. And trim start and trim end on string prototype as better named alternatives to the widely implemented but non-standard string prototype trim left and trim right built-ins. In addition, it included a few minor updates to syntax and semantics. Updated syntax included optional catch binding parameters and allowing U plus 2028 line separator and U plus 2029 paragraph separator in string literals to align with JSON. Other updates include...
I'm gonna try to like open up all the tabs, turn off the radio, and focus or something.
Put and clarifying function prototype.
I don't know. I have to update my to-do notes and actually do what's in my notes. I think I'm gonna like hold off on converting the JavaScript files for later or whatever, and then
A syntax to asynchronously
I'm gonna just work on the address arithmetic in the program. I don't know, I'll get to it.
precision integers, promise all settled, a new promise combinator that does not short circuit, global this, a universal way to access the global this value, dedicated exporters NS from modular syntax for us within modules, increased standardization of for an enumeration order, import meter, a host populated object available in modules that may contain contextual information about the module, as well as adding 2 new syntax features to improve working with nullish values, undefined or null, nullish coalescing, a value selection operator, and optional chaining, a property access and function invocation operator that short circuits if the value to access invoke is nullish. ECMAScript 2021, the 12th edition, introduced the replace all method for strings, promise any, a promise combinator that short circuits when an input value is fulfilled, aggregate error, a new error type to represent multiple errors at once, logical assignment operators equals, and equals, weak ref, for referring to a target object without preserving it from garbage collection, and finalization registry, to manage registration and registration of cleanup operations performed when target objects are garbage collected, separators for numeric literals, 1000, and array prototype sort was made more precise, reducing the amount of cases that result in an implementation. Defined sort order, ECMAScript 2022, the 13th edition, introduced top-level await, allowing the keyword to be used at the top level of modules, new class elements, public and private instance fields, public and private static fields, private instance methods and accessors, and private static methods and accessors, static blocks inside classes, to perform per class evaluation initialization, the X and OBJ syntax, to test for presence of private fields on objects, regular expression match indices via the D flag, which provides start and end indices for matched substrings, the cause property on error objects, which can be used to record a causation chain in errors, the at method for strings, arrays, and typed arrays, which allows relative indexing, and object his own. A convenient alternative to object prototype his own property, ECMAScript 2023, the 14th edition, introduced the to sorted, to reversed, with find last, and find last index methods on array prototype and typed array prototype, as well as the to spliced method on array prototype. Added support for comments at the beginning of files to better facilitate executable ECMAScript files, and allowed the use of most symbols as keys in weak collections. V. Copyright sign, ECMA International 2024, ECMAScript 2024, the 15th edition, added facilities for resizing and transferring array buffers and shared array buffers, added a new regex PV flag for creating regexps with more advanced features for working with sets of strings, and introduced the promise with resolve as convenience method for constructing promises, the object group by and map group by methods for aggregating data, the atomics wait async method for asynchronously waiting for a change to shared memory, and the string prototype as well for
This computer is so slow.
strings contain only well-formed
And it's copied.
representing many organizations have made very significant contributions.
So pick up from wherever I was at yesterday.
Prior editions. In addition, a vibrant community has emerged.
And I'm not gonna get to where I want to get today. I don't have time.
Has reviewed numerous drafts, filed.
But I'll make some amount of incremental progress towards the goal.
The worldwide developer community about ECMA.
Oh, this is so much work.
Identify and acknowledge every person and organization who has contributed to this effort. Alan Worth's Brock, ECMA 262, Project Editor, 6th edition.
I should have just wrote this whole program in 64-bit in the first place.
7th through 10th editions. Jordan Harband, ECMA 262, Project Editor, 10th through 12th editions. Shuyugwo, ECMA 262, Project Editor, 12th through 15th editions.
This computer is so laggy.
Project Editor, 12th through 15th editions. Kevin Gibbons, ECMA 262, Project Editor, 12th through 15th editions.
I closed Visual Studio and it's still just as laggy. So I guess it's today it's just gonna be laggy.
.es/ECMARTIS62/ is the most accurate and up-to-date ECMAScript specification. It contains the content of the most recent yearly snapshot plus any finished proposals. https://jither.
I don't know why I said I guess. I know it's gonna be laggy because this is a bad start.
Those that have reached stage 4 in the proposal process. https://tc39.es/process document, and thus are implemented in several
I think a couple windows are missing.
snapshot was taken.
So I have to figure out whatever I had open and open them again.
Specification.
I'll be back.
Help of the ECMAScript community. There are a number of ways to contribute to the development of this specification. GitHub repository. https://github.com/tc39/ECMARTIS62. Issues. All issues. https://github.com/tc39/ECMARTIS62/issues. File a new issue. https://github.com/tc39/ECMA262/issues new. Pull requests. All pull requests. https://github.com/tc39/ECMARTIS62/pulls. Create a new pull request. https://github.com/tc39/ECMARTIS62/pulls/new. Test suite. Test 262. https://github.com/tc39/test262. Editors. Shuyugwo at Shu. https://twitter.com/_Shu. Michael Ficara at smooshmap. https://twitter.com/smooshmap. Kevin Gibbons at backcoating. https://twitter.com/backcoating. Community. Discourse. https://es.discourse.group. https://es.discourse.group. Chat. Matrix. https://github.com/how-we-work/blob/head/matrix-guide.md. Mailing list archives. https://isdiscus.org/ refer to the Carlophane for more information on how this document is created. 8. Copyright sign. ECMA International 2024. Copyright Notice 2024 ECMA International. This document may be copied, published and distributed to others, and certain derivative works of it may be prepared, copied, published, and distributed, in whole or in part. provided that the above copyright notice and this copyright license and disclaimer are included on all such copies and derivative works. The only derivative works that are permissible under this copyright license and disclaimer are I. Works which incorporate all or portion of this document for the purpose of providing commentary or explanation, such as an annotated version of the document. 2. Works which incorporate all or portion of this document for the purpose of incorporating features that provide accessibility. 3. Translations of this document into languages other than English and into different formats. And 5. Works by making use of this specification in standard conformant products by implementing, for example by copy and paste wholly or partly, the functionality therein. However, the content of this document itself may not be modified in any way, including by removing the copyright notice or references to ECMA International, except as required to translate it into languages other than English or into a different format. The official version of an ECMA International document is the English language version on the ECMA International website. In the event of discrepancies between a translated version and the official version shall govern. The limited permissions granted above are perpetual and will not be revoked by ECMA International or its successors or assigns. This document and the information contained herein is provided on an as-is basis, and ECMA International disclaims all warranties, express or implied, including but not limited to any warranty that the use of the information herein will not infringe any ownership rights or any implied warranties of merchantability or fitness for a particular purpose. ECMA International 2024-9 ECMAScript Registered Sign 2024 Language Specification Scope. This standard defines the ECMAScript 2024 General Purpose Programming Language to conformance. A conforming implementation of ECMAScript must provide and support all the types, values, objects, properties, functions, and program syntax and semantics described in this specification. A conforming implementation of ECMAScript must interpret source text input in conformance with the latest version of the Unicode standard and ISO IEC 10646. A conforming implementation of ECMAScript that provides an application programming interface API, that's up. Ports programs that need to adapt to the linguistic and cultural conventions used by different human languages and countries must implement the interface defined by the most recent edition of ECMA 402 that is compatible with this specification. A conforming implementation of ECMAScript may provide additional types, values, objects, properties, and functions beyond those described in this
I have a list of all the HTML and JavaScript files, whatever,
for objects that are described in this
that are I have to get back to.
ECMAScript may support program and regular expression syntax,
But it's like 2-3 separate notes, so I'm gonna like make one final note
support program syntax
and list them all in a row, and then
1, 2, 7
I'll get back to them later.
of ECMAScript.
I'm gonna like replace the keyword, and then I'll put like an alert at the top
17.1
and make like a infinite loop, so it'll be like alert, alert, alert.
implementation defined.
And then later on when I get to that file, I'll be like, oh shit, I have to like update this thing.
Implement or not implement.
So I'm gonna put off those problems until later, so I can deal with the current thing I'm trying to do,
Implemented.
which is find all the address arithmetic and update it from 4-byte addressing to 8-byte for 64-bit.
They're also marked as normative.
So it'll run on a 64-bit computer as a 64-bit executable with more RAM and stuff, because the 32-bit mode that I had built
Considered part of the core ECMAScript
and running as whatever originally I paged to the hard drive
writing new ECMAScript code.
as an exercise to write my own paging and stuff.
ECMA International 2.
And even with paging to files, there's a huge overhead when opening a file. on Windows, Linux, whatever,
Clause heading. Example clause.
I had to like implement caching and stuff
Documents are indispensable.
and keep a certain number of files open at a time.
The addition cited apply.
Because if you have like 10,000 files open, it lags down the computer.
Amendments applies. IEEE 754.
So I had to write a code to like find out when there's diminishing returns on the number of files opened, and then
Flash versions.
figure out how many files to keep open at a time on the computers it's running.
Universal multiple octet coded character set.
And then
1. 2005.
it has to like close those files, open those files, basically do what the operating system is supposed to be doing efficiently, but it doesn't.
Or successor.
So I don't need any of that for the 64-bit build,
PI specification.
because 64-bit computers are magical.
TTPS :
They're just magical.
ECMA-
So I'll just leave it at that. So I don't need any of that other stuff because I'm gonna rely on 64-bit
ECMA.
computing, technically speaking, whatever. But
/ www.
these computers are not 64-bit.
/ pub.
Anyways, whatever the operating system can't do efficiently, that's not my problem. I'm just writing the program I'm trying to get done and stuff.
ECMAScript is an object-oriented programming language.
So I'm gonna convert this whole program to 64-bit and then turn off certain things that I had for 32-bit.
Computationally self-sufficient, indeed.
I'm gonna trust the operating system, and when I run into issues, then I'll deal with it.
ECMAScript program will provide not only the
So I'm gonna go off blind assumption
also certain environment-specific
that everything will work when I convert this thing to 64-bit, and
certain properties that can be accessed.
Windows is gonna be able to like efficiently handle everything like paging stuff in 64 mode.
Be used as a general-purpose programming
I don't know.
language that is
So, well, really, I'm like nitpicking because really, the performance I expect is like really high. It's gonna meet standards, whatever, but I don't know. I'm just being technical.
of objects and facility.
So I'm gonna like find all those files that are like, I'll deal with them later, I'll tag them,
Professional program.
have them alert, and then I'll deal with them when I have to open them,
ECMAScript was
because they generate parts of the program.
providing a
And if I just leave the program as it is for now,
computation is
I'm approaching this program from like the outside in.
capabilities for
I don't want to figure out the inner workings right now. I just want to get it running.
apart from any particular
So I need to tag every single file with a defined guard,
for the full spectrum of programming type.
and tag it with something that says like
Usage of ECMAScript has expanded, so have the features and facilities it provides.
alert on entry, I don't know.
General purpose programming language.
And then every time I'll run the compiler, and then it'll hit every file, throw a warning. I can go to the file, turn off the warning, through each file, whatever.
Text areas.
And then eventually, it'll build, because I'll go through all the files, I'll turn it off.
Host environment.
And then I will know what files are being used for the build mode.
Agent image load.
And that will search only those files
And
for the current build mode, and find any address arithmetic and update it
images.
from 32-bit to 64-bit.
For a main program.
I have toggles or whatever, conditional preprocessor, build mode, whatever stuff. So
Side and server-side scripting together. It is possible to
I need to
server while providing a customized user interface for a web-based application. Each web browser and server that supports ECMAScript.
there's a lot of different like options to build it, whatever, because I have like different levels of caching. I tried a bunch of different stuff,
A script into hosting.
but I'm going to convert only the code that's like running for whatever state that I left the program in,
The source outside of this specific
because I think I left it in a state where like everything's enabled.
kinds of deferrals.
But as I like turn off my custom paging, file management, and like some other things,
Defined or implementation.
other files will be included to replace that module that was in use. And then those files, I'll need to update those to 64-bit addressing.
External source without
So like, I'm gonna tag all the files, only the ones in use I'll update, and then I'll get it running at 64-bit, and then I will toggle the build options for it,
external source while recommending
and then as I change the toggles, I'll reset the headers or whatever,
encouraged to strive.
so it throws a warning on every file entry, and I'll just trace through every build mode
Approximated.
and update from 32-bit to 64-bit addressing.
They define other implementation
And then this way, the program is always in a running state,
to the set of all implement.
because when you write programs, well, what I learned is that if you leave a program in a non-functional state, even if it's not optimal, if it's not running,
EPS. HTML spec.
it's like way more difficult to like get it running later on,
Specifications.
because you might leave it for 2 or 3 years or a month or two, or even a couple days and forget where you left off, and you're like, where the hell was I? And then it doesn't even run.
It must return either a normal
So I want to like avoid that as much as possible,
as its definition to
and converting parts of the program at a time makes it feel like I'm making progress quicker,
provide definition.
even though realistically I'm making the same amount of progress either way. If I
For all host defined.
update the whole thing in one go, or if I update it in little pieces at a time.
Allow obtaining input and providing out.
But updating it little pieces at a time means if something gets screwed up, the whole thing's not screwed up, and at least it's
Quality is host defined.
it's always in a running state.
Implementation defined. Both hosts and implement.
So that's my mindset. I don't know.
Specification types. Abstract.
Now I need to like find those nodes,
Intrinsic symbol.
open those files, tag them with an alert,
Is an informal
and I'll have chatbot
parts of the language.
output a script to search the directory and print all the files,
Basic language and host for set.
because I don't want to write any code today. I just want to like tag the files with the header.
ECMAScript. An object is a
That's probably all I'm gonna be able to get done today.
determine how each property can be used.
But then I'll be able to run the compiler, catch each file that's used, only the files in use,
Code to assign a different
update those to 64-bit arithmetic,
primitive values.
and then when it runs, and then it's like 64-bit.
Find null.
But it's not yet, because I have to turn off the paging and turn off several other things.
And a function is a callable object.
And then when I do that, I'm gonna have to go through again and turn on those headers and catch only the files in use.
Roundo. The definition of ECMAScript entity.
And then once I get what I need for the 64-bit build,
The runtime
and it's running whatever, then I'll leave it.
boolean
And then any like files for like other build modes and stuff,
anib boolean numeric
they can run as a 32-bit. I don't have to update those to 64-bit.
xp object
I'm trying to like pick and choose, cherry pick only what I need.
whose l
Because in the end, I'm gonna make a parser to pick out only the code that's used. So like the final file that
an object array buffer
is used for the release, it's gonna look nothing. There won't even be a folder directory. I'll have it output a single mega file
script also
where everything's just there and like whatever.
script operators include various
So like this is all just like organizational and trying to logically sort things out so we can get done as fast as possible,
binary bitwise operators
because programming takes so long, so much time to do.
data. Large ECMAScript programs are supported by modules with
I think that's it.
sequences of statements and declaration
So I'm like, this is day 8, whatever.
to be provided by other
I don't think I'm gonna get done in 8 days. I'm like 2 days behind from what I planned with replacing.
syntax. ECMAScript syntax is relaxed
So I'm just gonna make a new notes file
language. For example, a very
and get going whatever.
nor types associated with property
And I'm hoping chatbot is gonna give me something useful.
4 calls to them, comma 3
It probably won't. So I'm gonna have to do some kind of coding.
a script object
But I'm gonna manually open these files and paste the header to then find out what's running and tag them.
including via a literal notation or via constructors which
Because or I'll make a program, I don't know. I don't trust making a program though. I think chatbot is gonna give me like a shitty output, and the amount of effort it would take to like, I just want to get done now. I'll just do everything by hand. I don't care, basically.
copyright sign ECMA International 2000
So I'm gonna do that. Get some water, turn on a fan, and get going.
rather than an object. Every object created by a constructor has an implicit reference, called the object's prototype, to the value of its constructor's prototype property. Further
And then the JavaScript standards, whatever, the ECMA 262.
on, this is
Oh, it's not gonna be any fun.
that references to the property of that.
I have to add like 4 more types to my engine.
In other words,
It's not gonna be easy.
examine for such a property if that object contains
I'm gonna have to like change the internal structure. It's gonna like affect a whole bunch of stuff.
examined next, and so on. Figure 1, object
Because running a 32-bit program in 64-bit computer,
implicit prototype
you get the bigger cache line and stuff, and
E CFP
I had data structures that just fit in the cache line, but now it's gonna be split halfway because 64-bit takes twice the memory.
in a class-based
So I'm going to I don't think it'll be a big performance hit, but it might be 5, 10, 12%.
in ECMAScript
But then a 32-bit program runs slower in 64-bit on Windows anyways, so in the end it might actually end up being faster because since they slow down the 32-bit programs, there will be less
by using new expressions.
hindering the 64-bit. So even though 64-bit doesn't fit as good in the cache lines and stuff,
2. The dashed line
it will still probably end up being faster than 32-bit.
O For example,
and I'll have more than 4 gigs of memory and I don't have to page the stuff.
itself, named P1 and P2,
So I'm going to do that, and yeah.
CF2, CF3, CF4, or CF5. The property named CFP1 and CFP is shared by CF1, CF2, CF3, CF4, and CF5, but not by CF, as are any properties found in CFP's implicit prototype chain that are not named Q1, Q2, or CFP1. Notice that there is no implicit prototype link between CF and CFP. Unlike most class-based object languages, properties can be added to objects dynamically by assigning values to them. That is, constructors are not required to name or assign values to all or any of the constructed object's properties. In the above diagram, one could add a new shared property for CF1, CF2, CF3, CF4, and CF5 by assigning a new value to the property in CFP. Although ECMAScript objects are not inherently class-based, it is often convenient to define class-like abstractions based upon a common pattern of constructor functions.
It takes 2 minutes to compile each time. I'll be back. This is compiler. Visual Studio compilers. It sucks.
Language includes syntactic class definitions that permit programmers to concisely define objects that conform to the same class-like abstraction pattern used by the built-in objects. ECMA International 2024 5.4.3 to the strict variant of ECMAScript. The ECMAScript language recognizes the possibility that some users of the language may wish to restrict their usage of some features available in the language. They might do so in the interests of security, to avoid what they consider to be error-prone features, to get enhanced error checking, or for other reasons of their choosing. In support of this possibility, ECMAScript defines a strict variant of the language. The strict variant of the language excludes some specific syntactic and semantic features of the regular ECMAScript language and modifies the detailed semantics of some features. The strict variant also specifies additional error conditions that must be reported by throwing error exceptions in situations that are not specified as errors by the non-strict form of the language. The strict variant of ECMAScript is commonly referred to as the strict mode of the language. Strict mode selection and use of the strict mode syntax and semantics of ECMAScript is explicitly made at the level of individual ECMAScript source text units as described in 1.1.2.2. Because strict mode is selected at the level of a syntactic source text unit, strict mode only imposes restrictions that have local effect within such a source text unit. Strict mode does not restrict or modify any aspect of the ECMAScript semantics that must operate consistently across multiple source text units. A complete ECMAScript program may be composed of both strict mode and non-strict mode ECMAScript source text units. In this case, strict mode only applies when actually executing code that is defined within a strict mode source text unit. In order to conform to this specification, an ECMAScript implementation must implement both the full unrestricted ECMAScript language and the strict variant of the ECMAScript languages defined by the specification. In addition, an implementation must support the combination of unrestricted and strict mode source text units into a single composite program. Point 4 Terms and definitions. For the purposes of this document, the following terms and definitions apply. 4.1 Implementation approximated. An implementation approximated facility is defined in whole or in part by an external source but has a recommended ideal behavior in this specification. 4.2 Implementation defined. An implementation defined facility is defined in whole or in part by an external source to this specification. 4.3 Host defined. Same as implementation defined. Note editorially. See clause 4.2, 4.4 Type. Set of data values as defined in clause 6.4.5 Primitive value. Member of one of the types undefined. Null, boolean, number, big int, symbol, or string as defined in clause 6. Note a primitive value is a datum that is represented directly at the lowest level of the language implementation. Copyright sign, ECMA International 2024 4.4 6. Object. Member of the type object. Note an object is a collection of properties and has a single prototype object. The prototype may be null 7 constructor, function object that creates and initializes objects, 4.8 prototype, object that provides shared properties for other objects, 4.9 ordinary object, object that has the default behavior for the essential internal methods that must be supported by all objects, 4.10 exotic object, object that does not have the default behavior for one or more of the essential internal methods. Note any object that is not an ordinary object is an exotic object. The 4th of April 2011 standard object, object whose semantics are defined by the specification, 4.12 built-in object, object specified and supplied by an ECMAScript implementation, 4.13 undefined value, primitive value used when a variable has not been assigned a value. Note the value of a constructor's prototype property is a prototype object that is used to implement inheritance and shared properties. Note when a constructor creates an object, that object implicitly references the constructor's prototype property for the purpose of resolving property references. The constructor's prototype property can be referenced by the program expression constructor prototype, and properties added to an object's prototype are shared, through inheritance, by all objects sharing the prototype. Alternatively, a new object may be created with an explicitly specified prototype by using the object create built-in function. Note standard built-in objects are defined in this specification. An ECMAScript implementation may specify and supply additional kinds of built-in objects. ECMA International 2024-7. The 4th of April 2014 undefined type. Type whose sole value is the undefined value, 4.15 null value. Primitive value that represents the intentional absence of any object value, 4.16 null type. Type whose sole value is the null value, 4.17 Boolean value. Member of the Boolean type. Note there are only two Boolean values, true and false, 4.18 Boolean type, type consisting of the primitive values true and false. The 4th of April 2019 Boolean object, member of the object type that is an instance of the standard built-in Boolean constructor, 4.20 string value, primitive value that is a finite ordered sequence of 0 or more 16-bit unsigned integer values, 4.21 string type, set of all possible string values, 4.22 string object, member of the object type that is an instance of the standard built-in string constructor. A Boolean object is created by using the Boolean constructor in a new expression, supplying a note Boolean value as an argument. The resulting object has an internal slot whose value is the Boolean value. A Boolean object can be coerced to a Boolean value. Note a string value is a member of the string type. Each integer value in the sequence usually represents a single 16-bit unit of UTF-16 text. However, ECMAScript does not place any restrictions or requirements on the values except that they must be 16-bit unsigned integers. A string object is created by using the string constructor in a new expression, supplying a string note value as an argument. The resulting object has an internal slot whose value is the string value. Capital A string object can be coerced to a string value by calling the string constructor as a function, 221111. Copyright sign, ECMA International 2024. The 4th of April 2023 number value, primitive value corresponding to a double precision 64-bit binary format, i.e. E7542019. Value. Note a number value is a member of the number type and is a direct representation of a number, 4.24 number type, set of all possible number values including the special not a number, nan, value, positive infinity, and negative infinity, 4.25 number object, member of the object type that is an instance of the standard built-in number constructor, 4.26 infinity, number value that is the positive infinite number value, 4.27 nan, number value that is an i.e. EE7542019, not a number value. The 4th of April 2028 begint value, primitive value corresponding to an arbitrary precision integer value. The 4th of April 2029 begint type, set of all possible begint values, 4.30 begint object, member of the object type that is an instance of the standard built-in begint constructor. The 4th of April 1931 symbol value, primitive value that represents a unique Non-string object property key, the 4th of April 1932. Symbol type, set of all possible symbol values, 4.33. Symbol object, member of the object type that is an instance of the standard built-in symbol constructor. A number object is created by using the number constructor in a new expression, supplying a note number value as an argument. The resulting object has an internal slot whose value is the number value. A number object can be coerced to a number value by calling the number constructor as a function to 1, 1, 1, 1. ECMA International 2024-9. The 4th of April 1934. Function, member of the object type that may be invoked as a subroutine, 4.35. Built-in function, built-in object that is a function, 4.36. Built-in constructor, built-in function that is a constructor, 4.37. Property, part of an object that associates a key, either a string value or a symbol value, and a value, 4.38. Method, function that is the value of a property, 4.39. Built-in method, method that is a built-in function, 4.40. Attribute, internal value that defines some characteristic of a property, 4.41. Own property, property that is directly contained by its object. Note, in addition to its properties, a function contains executable code and state that determine how it behaves when invoked. A function's code may or may not be written in ECMAScript. Examples of built-in functions include parse, int, and mathexp. A host or implementation may, note, provide additional built-in functions that are not described in this specification. Examples of built-in constructors include object and function. A host or implementation may, note, provide additional built-in constructors that are not described in this specification. Note, depending upon the form of the property, the value may be represented either directly as a data value, a primitive value, an object, or a function object, or indirectly by a pair of accessor functions. Note, when a function is called as a method of an object, the object I is passed to the function as its this value. Note, standard built-in methods are defined in this specification. A host or implementation may provide additional built-in methods that are not described in this specification. 0. Copyright sign, ECMA International 2024. The 4th of April 1942. Inherited property, property of an object that is not a known property but is a property either owned or inherited of the object's prototype. 5. Organization of this specification. The remainder of this specification is organized as follows. Clause 5 defines the notational conventions used throughout the specification. Clauses 6 through 10 define the execution environment within which ECMAScript programs operate. Clauses 11 through 17 define the actual ECMAScript programming language, including its syntactic encoding and the execution semantics of all language features. Clauses 18 through 28 define the ECMAScript standard library. They include the definitions of all of the standard objects that are available for use by ECMAScript programs as they execute. Clause 29 describes the memory consistency model of accesses on shared array buffer memory and methods of the atomics object. Notational conventions. 1. Syntactic and lexical grammars. 5. 1. Context-free grammars. A context-free grammar consists of a number of productions. Each production has an abstract symbol called a non-terminal as its left-hand side, and a sequence of 0 or more non-terminal and terminal symbols as its right-hand side. For each grammar, the terminal symbols are drawn from a specified alphabet. A chain production is a production that has exactly one non-terminal symbol on its right-hand side along with 0 or more terminal symbols, starting from a sentence consisting of a single distinguished non-terminal, called the goal symbol. A given context-free grammar specifies a language, namely, the, perhaps infinite, set of possible sequences of terminal symbols that can result from repeatedly replacing any non-terminal in the sequence with the right-hand side of a production for which the non-terminal is the left-hand side. 1.2 The lexical and regexp grammars. A lexical grammar for ECMAScript is given in clause 12. This grammar has as its terminal symbols Unicode code points that conform to the rules for source character defined in 11.1. It defines a set of productions, starting from the goal symbol input element of, input element template tail, input element regexp, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, or input element #bang or regexp that describe how sequences of such code points are translated into a sequence of input elements. Input elements other than white space and comments form the terminal symbols for the syntactic grammar for ECMAScript and are called ECMAScript tokens. These tokens are the reserved words, identifiers, literals, and punctuators of the ECMAScript language. Moreover, line terminators, although not considered to be tokens, also become part of the stream of input elements and guide the process of automatic semicolon insertion. 12.10. Simple white space and single line comments are discarded and do not appear in the stream of input elements for the syntactic grammar. A multi-line comment, that is, a comment of the form comma regardless of whether it spans more than one line, is likewise simply discarded if it contains no line terminator. But if a multi-line comment contains one or more line terminators, then it is replaced by a single line terminator, which becomes part of the stream of input elements for the syntactic grammar. ECMA International 2024-11. A regexp grammar for ECMAScript is given in 2.2.2.1. This grammar also has as its terminal symbols the code points as defined by source character. It defines a set of productions, starting from the goal symbol pattern, that describe how sequences of code points are translated into regular expression patterns. Productions of the lexical and regexp grammars are distinguished by having two colons, a separating punctuation. The lexical and regexp grammars share some productions. 1.3 The numeric string grammar. A numeric string grammar appears in 7.1.4.1. It has as its terminal symbols source character, and is used for translating strings into numeric values starting from the goal symbol string numeric literal, which is similar to but distinct from the lexical grammar for numeric literals. Productions of the numeric string grammar are distinguished by having three colons, as punctuation, and are never used for parsing source text. 1.4 The syntactic grammar. The syntactic grammar for ECMAScript is given in clauses 13 through 16. This grammar has ECMAScript tokens defined by the lexical grammar as its terminal symbols. 5.1.2. It defines a set of productions, starting from two alternative goal symbols script and module, that describe how sequences of tokens form syntactically correct independent components of ECMAScript programs. When a stream of code points is to be parsed as an ECMAScript script or module, it is first converted to a stream of input elements by repeated application of the lexical grammar. This stream of input elements is then parsed by a single application of the syntactic grammar. The input stream is syntactically in error if the tokens in the stream of input elements cannot be parsed as a single instance of the goal non-terminal, script or module, with no tokens left over. When a parse is successful, it constructs a parse tree, a rooted tree structure in which each node is a parse node. Each parse node is an instance of a symbol in the grammar. It represents a span of the source text that can be derived from that symbol. The root node of the parse tree, representing the whole of the source text, is an instance of the parser's goal symbol. When a parse node is an instance of a non-terminal, it is also an instance of some production that has that non-terminal as its left-hand side. Moreover, it has 0 or more children, one for each symbol on the product. Iron's right-hand side. Each child is a parse node that is an instance of the corresponding symbol. New parse nodes are instantiated for each invocation of the parser and never reused between parsers even of identical source text. Parse nodes are considered the same parse node if and only if they represent the same span of source text, are instances of the same grammar symbol, and resulted from the same parser invocation. Note 1. Parsing the same string multiple times will lead to different parse nodes. For example, consider let str equals 1 plus 1 eval, str eval, str. Each call to eval converts the value of str into ECMAScript source text and performs an independent parse that creates its own separate tree of parse nodes. The trees are distinct even though each parse operates upon a source text that was derived from the same string value. Note 2. Parse nodes are specification artifacts, and implementations are not required to use an analogous data structure. Productions of the syntactic grammar are distinguished by having just one colon as punctuation. 2. Copyright sign. ECMA International 2024. The syntactic grammar as presented in clauses 13 through 16 is not a complete account of which token sequences are accepted as a correct ECMAScript or module. Certain additional token sequences are also accepted, namely, those that would be described by the grammar if only semicolons were added to the sequence in certain places, such as before line terminator characters. Furthermore, certain token sequences that are described by the grammar are not considered acceptable if a line terminator character appears in certain awkward places. In certain cases, in order to avoid ambiguities, the syntactic grammar uses generalized productions that permit token sequences that do not form a valid ECMAScript or module. For example, this technique is used for object literals and object destructuring patterns. In such cases, a more restrictive supplemental grammar is provided that further restricts the acceptable token sequences. Typically, an early error rule will then state that, in certain contexts, P must cover an N, where P is a parse node, an instance of the generalized production, and N is a non-terminal from the supplemental grammar. This means the sequence of tokens originally matched by P is parsed again using N as the goal symbol. If N takes grammatical parameters, then they are set to the same values used when P was originally parsed. If the sequence of tokens can be parsed as a single instance of N, with no tokens left over, then we refer to that instance of N, a parse node, unique for a given P, as the N that is covered by P. All early error rules for N and its derived productions also apply to the N that is covered by P. Otherwise, if the parse fails, it is an early syntax error. 1.5 Grammar notation 5. 1. 5. 1 Terminal symbols. In the ECMAScript grammars, some terminal symbols are shown in fixed width font. SA to appear in a source text exactly as written. All terminal symbol code points specified in this way are to be understood as the appropriate Unicode code points from the basic Latin block, as opposed to any similar-looking code points from other Unicode ranges. A code point in a terminal symbol cannot be expressed by a Unicode escape sequence in grammars whose terminal symbols are individual Unicode code points, that is, the lexical, regexp, and numeric string grammars, a contiguous run of multiple fixed width code points appearing in a production is a simple shorthand for the same sequence of code points, written as standalone terminal symbols. For example, the production hex integer literal 0x hex digits is a shorthand for hex integer literal 0x hex digits. In contrast, in the syntactic grammar, a contiguous run of fixed width code points is a single terminal symbol. Terminal symbols come in two other forms. In the lexical and regexp grammars, Unicode code points without a conventional printed representation are instead shown in the form ABBREV, where ABBREV is an mnemonic for the code point or set of code points. These forms are defined in Unicode format control characters, white space, and line terminators. In the syntactic grammar, certain terminal symbols, for example identifier name and regular expression literal, are shown in italics, as they refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024 13. 5. 1. 5. 2 non-terminal symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntactic definition while statement while expression statement states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition argument list, assignment expression, argument list, assignment expression, states that an argument list may represent either a single assignment expression or an argument list, followed by a comma, followed by an assignment expression. This definition of argument list is recursive, that is, it is defined in terms of itself. The result is that an argument list may contain any positive number of arguments, separated by commas, where each argument expression is an assignment expression. Such recursive definitions of non-terminals are common, 1, 5, 3 optional symbols. The subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative C, containing the optional symbol, actually specifies two right-hand sides, one that omits the optional element and one that includes it. This means that variable declaration binding identifier initializer opt is a convenient abbreviation for variable declaration binding identifier initializer, and that for statement for lexical declaration is a convenient abbreviation for statement for lexical declaration which in turn is an abbreviation for expression statement, expression statement, expression statement, expression statement, expression statement, for ECMA International 2024 for statement for lexical declaration. So, in this example, the non-terminal for statement actually has 4 alternative right-hand sides, 5, 1, 5. For grammatical parameters, a production may be parameterized by a subscripted annotation of the form parameters, which may appear as a suffix to the non-terminal symbol defined by the production. Parameters may be either a single name or a comma-separated list of names. A parameterized production is shorthand for a set of productions defining all combinations of the parameter names, preceded by an underscore, appended to the parameterized non-terminal symbol. This means that statement list, return statement, expression statement is a convenient abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, statement list in, return statement, expression statement, statement list return in, return statement, expression statement. Multiple parameters produce a combinatory number of productions, not all of which are necessarily referenced in a complete grammar. References to non-terminals on the right-hand side of a production can also be parameterized. For example, statement list, return statement, expression statement, plus in ECMA International 2024-15 is equivalent to saying statement list, return statement, expression statement in, and expression statement in is equivalent to statement list, return statement, expression statement. A non-terminal reference may have both a parameter list and an opt suffix. For example, variable declaration binding identifier initializer plus in opt is an abbreviation for variable declaration binding identifier initializer in. Prefixing a parameter name with on a right-hand side non-terminal reference makes that parameter value dependent upon the occurrence of the parameter name on the reference to the current production's left-hand side symbol. For example, variable declaration in binding identifier initializer in is an abbreviation for variable declaration binding identifier initializer, variable declaration in, binding identifier initializer in. If a right-hand side alternative is prefixed with plus parameter, that alternative is only available if the named parameter was used in referencing the production's non-terminal symbol. If a right-hand side alternative is prefixed with parameter, that alternative is only available if the named parameter was not used in referencing the production's non-terminal symbol. This means that statement list, return statement, expression statement is an abbreviation for statement list, expression statement. 6. ECMA International 2024 statement list, return statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return, expression statement, comma 1, 5, 5 1 of, when the words 1 of follow the colon, s, in a grammar definition, they signify that each of the terminal symbols on the following line or lines is an alternative definition. For example, the lexical grammar for ECMAScript contains the production, non-zero digit, 1 of 123,456,789, which is merely a convenient abbreviation for non-zero digit. 1, 3, 4, 5, 6, 7, 8, 9, 1, 5, 6, empty. If the phrase empty appears as the right-hand side of a production, it indicates that the production's right-hand side contains no terminals or non-terminals. 1, 5, 7 look ahead restrictions. If the phrase look ahead equals sec appears in the right-hand side of a production, it indicates that the production may only be used if the token sequence sec is a prefix of the immediately following input token sequence. Similarly, look ahead set, where set is a finite non-empty set of token sequences, indicates that the production may only be used if some element of set is a prefix of the immediately following token sequence. For convenience, the set can also be written as a non-terminal, in which case it represents the set of all token sequences to which that ECMA International 2024-17 non-terminal could expand. It is considered an editorial error if the non-terminal could expand to infinitely many distinct token sequences. These conditions may be negated. Look ahead sec indicates that the containing production may only be used if sec is not a prefix of the immediately following input token sequence, and look ahead set indicates that the production may only be used if no element of set is a prefix of the immediately following token sequence. As an example, given the definitions, decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, decimal digits, decimal digit, decimal digits, decimal digit. The definition, look ahead example, n, look ahead, 1, 3, 5, 7, 9, decimal digits, decimal digit. Low look ahead decimal digit matches either the letter n followed by one or more decimal digits, the first of which is even, or a decimal digit not followed by another decimal digit. Note that when these phrases are used in the syntactic grammar, it may not be possible to unambiguously identify the immediately following token sequence because determining later tokens requires knowing which lexical goal symbol to use at later positions. As such, when these are used in the syntactic grammar, it is considered an editorial error for a token sequence sec to appear in a look ahead restriction, including as part of a set of sequences. If the choices of lexical goal symbols to use could change whether or not sec would be a prefix of the resulting token sequence, 1, 5, 8, no line terminator here. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position. For example, the production throw statement, throw, no line terminator here, expression, indicates that the production may not be used if a line terminator occurs in the script between the throw token and the expression, unless the presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the script, 1, 5, 9 but not. The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word means that the non-terminal identifier may be replaced by any sequence of code points that could replace identifier name provided that the same sequence of code points could not replace reserved word. 8. Copyright sign, ECMA International 2024, 5, 1, 5, 1, 0 descriptive phrases. Finally, a few non-terminal symbols are described by a descriptive phrase and sans serif type in cases where it would be impractical to list all the alternatives. Source character, any Unicode code point to algorithm conventions. The specification often uses a numbered list to specify steps in an algorithm. These algorithms are used to precisely specify the required semantics of ECMAScript language constructs. The algorithms are not intended to imply the use of any specific implementation technique. In practice, there may be more efficient algorithms available to implement a given feature. Algorithms may be explicitly parameterized with an ordered, comma-separated sequence of alias names which may be used within the algorithm steps to reference the argument passed in that position. Optional parameters are denoted with surrounding brackets, name, and are no different from required parameters within algorithm steps. A rest parameter may appear at the end of a parameter list, denoted with leading ellipsis, name. The rest parameter captures all of the arguments provided following the required and optional parameters into a list. If there are no such additional arguments, that list is empty. Algorithm steps may be subdivided into sequential substeps. Substeps are indented and may themselves be further divided into indented substeps. Outline numbering conventions are used to identify substeps, with the first level of substeps labeled with lowercase alphabetic characters and the second level of substeps labeled with lowercase Roman numerals. If more than 3 levels are required, these rules repeat with the 4th level using numeric labels. For example, top level step A substep B substep, I substep, substep, A substep, I substep. A step or substep may be written as an if predicate that conditions its substeps. In this case, the substeps are only applied if the predicate is true. If a step or substep begins with the word else, it is a predicate that is the negation of the preceding if predicate step at the same level. A step may specify the iterative application of its substeps. A step that begins with assert asserts an invariant condition of its algorithm. Such assertions are used to make explicit algorithmic invariants that would otherwise be implicit. Such assertions add no additional semantic requirements and hence need not be checked by an implementation. They are used simply to clarify algorithms. Algorithm steps may declare named aliases for any value using the form let x be some value. These aliases are reference-like in that both x and some value refer to the same underlying data and modifications to either are visible to both. Algorithm steps that want to avoid this reference-like behavior should explicitly make a copy of the right-hand side. Let x be a copy of some value creates a shallow copy of some value. Once declared, an alias may be referenced in any subsequent steps and must not be referenced from steps prior to the alias's declaration. Aliases may be modified using the form set x to some other value, 2.1 abstract operations. In order to facilitate that use in multiple parts of this specification, some algorithms, called abstract operations, are named and written in parameterized functional form so that they may be referenced by name from within other algorithms. Abstract operations are typically referenced using a functional application style such ECMA International 2024-19 as operation name, arg1, arg2. Some abstract operations are treated as polymorphically dispatched methods of class-like specification abstractions. Such method-like abstract operations are typically referenced using a method application style such as some value operation name, arg1, arg2, 2.2 syntax-directed operations. A syntax-directed operation is a named operation whose definition consists of algorithms, each of which is associated with one or more productions from one of the ECMAScript grammars. A production that has multiple alternative definitions will typically have a distinct algorithm for each alternative. When an algorithm is associated with a grammar production, it may reference the terminal and non-terminal symbols of the production alternative as if they were parameters of the algorithm. When used in this manner, non-terminal symbols refer to the actual alternative definition that is matched when parsing the source text. The source text matched by a grammar production or parse node derived from it is the portion of the source text that starts at the beginning of the first terminal that participated in the match and ends at the end of the last terminal that participated in the match. When an algorithm is associated with a production alternative, the alternative is typically shown without any grammar annotations. Such annotations should only affect the syntactic recognition of the alternative and have no effect on the associated semantics for the alternative. Syntax-directed operations are invoked with a parse node and, optionally, other parameters by using the conventions on steps 1, 3, And 4 in the following algorithm. Let status be syntax-directed operation of some non-terminal. Let some parse node be the parse of some source text. Perform syntax-directed operation of some parse node. Perform syntax-directed operation of some parse node with argument value. Unless explicitly specified otherwise, all chain productions have an implicit definition for every operation that might be applied to that production's left-hand side non-terminal. The implicit definition simply reapplies the same.
I'm gonna do Control F and find all the leftover files that I didn't replace unsigned in or signed in inside of. They should only be JavaScript files
An operation does.
or HTML files.
In that case, the evaluation.
I'm gonna find them. I have a list of them, but I'll just compare to the list after. Make a new list. Make a new to-do list at like the root of the drive I'm working on. I need to put my logic bomb back into the program and do that, but make a list of those files, a new list, and then I'll update those files to use the new keyword. So then when I do Control F on the whole project, there should be nothing in the project except for the one place that it's defined as unsigned in whatever to define the keyword. Only one place will exist in the whole whatever. And then I can tag all the files with define guard to check if I updated it to 64-bit. And then I'll go through, I'll hit build whatever, and then every file that pops up, file by file, I'll just keep clicking build. Whenever it completes the build and no more files pop up as this needs to be updated to 64-bit, I'll be good and I'll know exactly which files need only to be updated to 64-bit for now. And then this whole thing will be running in a working state. So I can later on, when I turn on different options, different build modes for the whole thing, whatever. Because the release is going to be like, I don't need certain things, but it's in 64-bit. I'll be able to like deal with those files later, and I don't know, that's about it.
Directed operations that are prefixed by indicate that return.
So I'm gonna make that new list of files. I'll double check against my current notes. Make sure everything like is spelled out so I can check it later. Oh, I gotta put like a warning at the top when I open it as a reminder, like I need to update this file. It's problematic, whatever. Because only the files that are left are the ones that like I don't want to deal with right now. I don't have to deal with technically, because as long as I don't change the cache size I have set up for like inline caching and stuff, as long as those parameters don't change, I don't have to regenerate the files that generate those files. So everything can kind of like just stay as it is. And then I'll get it running whatever as it is, whatever, trying to do like the least amount of like modifying it as possible. And then I'll dig into like internally changing the program when I have to like go through the ECMA or EMA, whatever the heck they are, standards.
Normal completion.
Yeah, ECMA, whatever. 262, something like that. I have to adjust some things internally to support this, which is why I'm doing this update, whatever. And once you get to this, there's like 804 pages, whatever. So I'm planning on 2 months to be done with, yeah, 2 months. I don't know, yeah. It's okay. Might take a little bit longer than that. I don't know. I have to get into it. That's being optimistic, like highly optimistic. But after I get everything updated, I'll go through this whole standard. I'll need it like 100% satisfy every single line of whatever, and then as I meet the standard, I'll literally be programming here on this computer. I'll turn off this pixelization thing program, and then I'll like actually like show like the code running, whatever. So like if I'm like working on whatever part of the standard,
associated with specific grammar productions.
if this is like some spec, whatever, here, I'll be able to like highlight and be like, okay, blah 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 blah, and then I'll go over to this computer, whatever, and be like, I'll just run it, whatever, and be like, check, it meets the standard.
Specification makes reference.
I'll go down like the next line, whatever. I'll work on this part of the standard. Go over here, whatever.
Default numeric type.
I'll be like, oh look, check, it meets the standard. So I'm gonna go through that standard parameter, guideline, whatever. I don't know. Doesn't matter what it's called. I'll check every box, whatever. When this whole thing is done, it's done. And I'll have a 100% world's fastest JavaScript engine. It's way faster than every current JavaScript implementation. And they'll be like ready for release or whatever. So I'm gonna get to this hopefully in like 8 days. Maybe a couple more days are needed, but hopefully 8 days. So I'm gonna like shut up and get all these like problematic files and tag them, bag them, mark them, label them, note them, back stuff up, and after that I'm gonna open up chatbot, have it make a little program for me so I can like list all the files in the directory, and I'm gonna tag all the programs with the header. I'll run the compiler, update only the files in use 64-bit. I'll get it running. After that, I'll toggle the build mode options. Files are gonna pop up. They need to be like updated to 64-bit. I'll update those at that point, and then at that point, I'm good to go through this standard. So I explained the whole thing like 2 or 3 times now. I made the same point 2 or 3 times. So I don't know, that's what you're supposed to do to like make a point and like make it stick, is to like keep saying it over and over and over and over. I'm tired of talking in a circle. So I'm gonna stop talking now and do exactly what I just said and not repeat myself again. So I'm gonna get to it.
1, 6, 1. A conversion from an integer x to a big int is denoted as the big int value for x or z, x. A conversion from a number or big int x to a mathematical value is denoted as the mathematical value of x, or r, x. The mathematical value of +0 and -0 is the mathematical value 0. The mathematical value of non-finite values is not defined. The extended mathematical value of x is the mathematical value of x for finite values, and is plus and, for plus and, respectively. It is not defined for NaN, ECMA International 2024-23. The mathematical function abs, x, produces the absolute value of x, which is x of x, 0 and otherwise is x itself. The mathematical function min, x1, x2, xn, produces the mathematically smallest of x1 through xn. The mathematical function max, x1, x2, xn, produces the mathematically largest of x1 through xn. The domain and range of these mathematical functions are the extended mathematical values. The notation x model, y must be finite and non-zero, computes a value k of the same sign as y, or 0, such that abs, k, abs, y, and x, k equals qy for some integer q. The phrase the result of clamping x between lower and upper, where x is an extended mathematical value and lower and upper mathematical values such that lower upper produces lower if x, lower produces upper if x, upper, and otherwise produces x. The mathematical function floor, x, produces the largest integer, closest to plus, that is not larger than x. Note floor, x equals x, x modulo 1. The mathematical function truncate, x, removes the fractional part of x by rounding towards 0, producing floor, x, if x, 0 and otherwise producing floor, x. Mathematical functions min, max, abs, floor, and truncate are not defined for numbers and big ints, and any usage of those methods that have non-mathematical value arguments would be an editorial error in this specification. An interval from lower bound A to upper bound B is a possibly infinite, possibly empty set of numeric values of the same numeric type. Each bound will be described as either inclusive or exclusive, but not both. There are 4 kinds of intervals, as follows. An interval from A, inclusive, to B, inclusive, also called an inclusive interval from A to B, includes all values x of the same numeric type such that A xb, and no others. An interval from A, inclusive, to B, exclusive, includes all values x of the same numeric type such that A xb, and no others. An interval from A, exclusive, to B, inclusive, includes all values x of the same numeric type such that A xb, and no others. An interval from A, exclusive, to B, exclusive, includes all values x of the same numeric type such that A, x, b, and no others. For example, the interval from 1, inclusive, to 2, exclusive, consists of all mathematical values between 1 and 2, including 1 and not including 2. For the purpose of defining intervals, -0, +0. So, for example, an inclusive interval with a lower bound of +0 includes +0 but not -0. NaN is never included in an interval. 2.6 value notation. In this specification, ECMAScript language values are displayed in bold. Examples include null, true, or hello. These are distinguished from ECMAScript source texts such as function prototype apply all at n equals 42, 2.7 identity. In this specification, both specification values and ECMAScript language values are compared for equality. When comparing for equality, values fall into one of 2 categories. Values without identity are equal to other values without identity if all of their innate characteristics are the same. Characteristics such as the magnitude of an integer or the length of a sequence. Values without identity may be manifest without prior reference by fully describing their characteristics. In contrast, each value with identity is unique and therefore only equal to itself. Values with identity are like values without identity but with an additional unguessable, unchangeable, universally unique characteristic called identity. References to existing values with identity cannot be manifest simply by describing them, as the identity itself is indescribable. Instead, references to these values must be explicitly passed from one place to another. Some values with identity are mutable and therefore can have their characteristics except their 24. Copyright sign, ECMA International 2024. Identity, changed in place, causing all holders of the value to observe the new characteristics. A value without identity is never equal to a value with identity. From the perspective of this specification, the word is used to compare two values for equality, as in if bool is true, then, and the word contains is used to search for a value inside lists using equality comparisons, as in if list contains a record R such that R. From the perspective of the ECMAScript language, language values are compared for equality using the same value abstract operation in the abstract operations it transitively calls. The algorithms of these comparison abstract operations determine language identity of ECMAScript language values. For specification values, examples of values without specification identity include, but are not limited to, mathematical values and extended mathematical values, ECMAScript source text, surrogate pairs, directive prologues, etc., UTF, 16 code units, Unicode code points, enums, abstract operations, including syntax-directed operations, host hooks, etc., and ordered pairs. Examples of specification values with specification identity include, but are not limited to, any kind of records, including property descriptors, private elements, etc., parse nodes, lists, sets and relations, abstract closures, data blocks, private names, execution contexts and execution context stacks, agent signifiers, and waiter list records. Specification identity agrees with language identity for all ECMAScript language values except symbol values produced by symbol 4. The ECMAScript language values without specification identity and without language identity are undefined, null, booleans, strings, numbers, and bigins. The ECMAScript language values with specification identity and language identity are symbols not produced by symbol for and objects. Symbol values produced by symbol for have specification identity, but not language identity. ECMAScript data types and values. Algorithms within this specification manipulate values each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. Within this specification, the notation type, X, is used as shorthand for the type of X where type refers to the ECMAScript language and specification types defined in this clause. Point 1 ECMAScript language types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript program using the ECMAScript language. The ECMAScript language types are undefined, null, boolean, string, symbol, number, big int, and object. An ECMAScript language value is a value that is characterized by an ECMAScript language type, 1.1 the undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined, 1.2 the null type. The null type has exactly one value, called null 6, 1. 3 the Boolean type. The Boolean type represents a logical entity having two values, called true and false. ECMA International 2024-25. 6. 1. For the string type. The string type is the set of all ordered sequences of 0 or more 16-bit unsigned integer values, elements, up to a maximum length of 253 elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a UTF-16 code unit value. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at index 0, the next element, if any, at index 1, and so on. The length of a string is the number of elements, that is, 16-bit values within it. The empty string has length 0 and therefore contains no elements. ECMAScript operations that do not interpret string contents apply no further semantics. Operations that do interpret string values treat each element as a single UTF-16 code unit. However, ECMAScript does not restrict the value of or relationships between these code units. So operations that further interpret string contents as sequences of Unicode code points encoded in UTF-16 must account for ill-formed subsequences. Such operations apply special treatment to every code unit with a numeric value in the inclusive interval from 0xD800 to 0xDBFF, defined by the Unicode standard as a leading surrogate, or more formally as a high surrogate code unit. And every code unit with a numeric value in the inclusive interval from 0xDC00 to 0xDFFF, defined as a trailing surrogate, or more formally as a low surrogate code unit. Using the following rules, a code unit that is not a leading surrogate and not a trailing surrogate is interpreted as a code point with the same value. A sequence of two code units, where the first code unit C1 is a leading surrogate and the second code unit C2 a trailing surrogate, is a surrogate pair and is interpreted as a code point with the value C1 0xD800, 0 times 400 plus C2 0xDC00, plus 0 times 10,000, C1 1, 1, 3. A code unit that is a leading surrogate or trailing surrogate, but is not part of a surrogate pair, is interpreted as a code point with the same value. The function string prototype normalize, C22, 1, 3, 1, 5, can be used to explicitly normalize a string value. String prototype local compare, C22, 1, 3, 1, 2, internally normalizes string values, but no other operations implicitly normalize the strings upon which they operate. Operation results in not language and or locale sensitive unless stated otherwise. In this specification, the phrase the string concatenation of A, B, where each argument is a string value, a code unit, or a sequence of code units, denotes the string value whose sequence of code units is the concatenation of the code units. In order of each of the arguments. In order, the phrase the substring of S from inclusive start to exclusive end, where S is a string value or a sequence of code units and inclusive start and exclusive end are integers, denotes the string value consisting of the consecu type code units of S beginning at index inclusive start and ending immediately before index exclusive end, which is the empty string when inclusive start equals exclusive end. If the to suffix is omitted, the length of S is used as the value of exclusive end. The phrase the ASCII word characters denotes the following string value, which consists solely of every letter and number in the Unicode basic Latin block along with U plus 005F. Low line. Abok-defkejekam-nok-krestavwexes abok-defkejekam-nok-krestavwexes 01234567889. For historical reasons, it has significance to various algorithms. 1, 4, 1 string index of string search value from index. The abstract operation string index of takes argument string, a string, search value, a string, and from index, a non-negative integer, and it performs.
I need to for every HTML file, I'm gonna have to make like a little script at the very top, a local script, and then define some constants set to parameters of that HTML file. To see like if I have modified this HTML file to account for 64-bit, 32-bit paging, caching, time scheduling, threading, like whatever. I'm gonna have to make a local script in the top of every HTML file to have that available, and then inside of each HTML file I need to include a common JavaScript file that will be present that I have to tag or like include for every HTML file so that I can do Control F and find all HTML files that are used to generate an output. I could update these files to be like C programs, but it's easier because it's a big blob of text, but it's easier to just keep it in the browser and just open the browser and run it. Making a separate program for like some of the files that generate files is like complete overkill. So I need to very carefully tag every little part of this program, whatever, to preserve its current state, but also make it possible to like strategically find every little part that's needed when needed, and trace through the whole program as I'm working on it. Because right now it's a bunch of little pieces all over the place, and it just gets put together in the final blob. So I need to do like a little bit of organizing stuff. So I got like HTML files, I got to do that for the JavaScript files themselves. I have to put a check at the top of them to say like a define guard check, just a normal check. It's easier than when I'm going to do the JavaScript files or the HTML files. The JavaScript files are easier to whatever. I just got to put like a simple check so that those will be checked too, kind of like the .c and the .h files for the C program. Those they just need a define guard check, and then I can build it, find out specifically which files are used to make the build, whatever, and I'll update only those, and then I can use that same approach that I just talked about for different build modes as I toggle things on and off to pick whatever like the only support I need to make the 64-bit release or whatever. And I'll go through the standards. So I'm gonna find the problematic files first, and right now I guess I'm gonna move the to-do notes I just made to like a new to-do file. I'm gonna just replace anything where unsigned or signed in shows up, and then I'm gonna, I don't know, I gotta approach this very carefully because I don't want to backtrack ever. I hate backtracking and pulling up a backup. I just want to make 0 mistakes, and I want to like get this over with as soon as possible, hopefully in like 7 more days. I don't have as much time today to do this, so I want to try to like, as I get through whatever, I'm just gonna get like unsigned and signed in out replaced first, and then I'll look at my notes, and whatever's left I'm gonna try to like cherry pick the next like simple task I can do, because I wanna, whatever time I have left before I get off whatever, I want to be able to like finish whatever I was working on, so like I don't have to like leave things in a half finished state and then come back to it later, dig in, I have to like refigure stuff out. So I'm gonna do Control F I'll do that right now, whatever. Like Control F, Control Shift F, technically, whatever. Unsigned in. Search. Oh, there should have been more files than that. Man, I think I already updated. I didn't update the signed in. Okay. So, I already replaced unsigned in the HTML files, but the signed in, I didn't replace that yet because there's overlap. The problematic files happen to have signed in and unsigned, so whatever. But these files then, I have to make note of them. Now we'll update them right now. To make a new notes file. And I'm not gonna touch these files if I don't have to until I have to, because there's like, they're really complicated. When I click build, there's a like parameters, sizes, offsets, and I have checks to make sure the output matches what the build is. So if it doesn't, it'll throw a warning. So I can't just easily update them without having to like check the actual program and what it outputs to compare the two to actually update it. So I'm gonna tag these files, make note of them, and then I will put the new signed in keyword in for these JavaScript HTML files. Luckily there's only like 6. I think there might be 9. I gotta check. I'm gonna compare my notes, figure out which files were possible issues, because a couple of them, whatever, I'm gonna do this. I'm trying to think ahead, get the whole picture or whatever. So I'm gonna do this, and I'll be done with this, and then I'll go through my notes and I'll pick out whatever's easiest to do next. This is like really, really simple. The only way that I'd break something is if something was a string and it depended on the length. If I change it from unsigned in to my new keyword, and the new keyword's a different length, it can mess up the string. If I had predefined the length of the string somewhere, because some of this stuff, the compiler will not give you a compile time length of certain types at compile time. So I used JavaScript, or I have some C programs that generate output that I have them loop through whatever, and they save the string length or whatever to like a runtime literal to make up for what the compiler doesn't do, because I use whatever. That's the only time that replacing the type name could really break anything, or if unsigned int, like, or signed in, happens to be part or touching another letter, and then I mangle the name, and it's like a garbage name. So I can like safely put this keyword in place, knowing nothing will break. I did find a couple of places where unsigned in was inside of a string, but I adjusted length and I checked it, and it's really only for debug, so it won't affect the actual runtime, build, release, whatever. So luckily I'm good there, but the addressing, or if I change any of the parameters of the build, like the memory size and stuff, the structures and stuff, that's all really complicated. So like if any of that changes, which it will at some point later on when I actually get to this documentation, I have to update stuff to meet the standard. Then these problematic files, whatever, that I have, these 9 or 5 of them that I just searched for, and I put in this list over here. Then I'm gonna have to deal with these because they will, these files, whatever, they just found, and then I put in this list. You can't really even see it, whatever. But then I'll have to actually deal with rebuilding these files. Right now, they don't make the correct output, so I have to dig in and adjust them, because one of them, it just outputs gibberish, whereas testing a bunch of stuff on it, and when I turn it off, it just doesn't build. So I have to like dig into whatever. That's why you always, or why I always try to leave a program always in a running state, because that program, that code, that HTML file, it wasn't in a running state. So now it's been like 7 years. I opened it up and it doesn't run. So I have to spend time, tick, 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 time keeps ticking. I'm gonna have to spend my time getting this fucking file to like run again. But in the first place, if I left it in a running state right now, I wouldn't have to be dealing with this, but I didn't. So that's why I always try to leave programs in a running state, because I'm actually capable of learning new tricks. Like, I can learn. Like, you wouldn't believe how many stupid people in this world, I swear to God. Anyways, I'm gonna make note of this stuff, find and replace, and I guess I'll like open my mouth again and talk about whatever I'm gonna do. This is so boring. When I get to like the address arithmetic, that's not boring. It's complicated. So then I'm gonna say, this is so complicated. So I'm still gonna complain. I can try to complain less, but internally I'm gonna be like screaming because this isn't fun. But I can pretend that it's fun. So I'm gonna have a good old time here, finding and replacing, making a new note file, and figuring out what I should do next based on how long I'm gonna be on for right now to get as much done as possible and stuff. So I'm gonna shut up now and then open my mouth later.
Return. Otherwise.
And I forgot something, and I don't know. Whatever comes to mind, I'll just I can't. It's gone. I had it and disappeared. Yeah, I don't know. So I'm gonna do whatever it's doing.
0 be else. If exponent is an odd integral number, return. Otherwise, return plus, assert. Base is finite and is neither plus 0 nor minus 0. If exponent is plus, then if abs r base 1, return plus, b if abs r base equals 1, return nan, c if abs r base 1, return plus 0, 0. If exponent is, then if abs r base 1, return plus 0, b if abs r base equals 1, return nan, c if abs r base 1, return plus 1. Assert. Exponent is finite and is neither plus 0 nor minus 0. 2. If base minus 0 and exponent is not an integral number, return nan. 3. Return an implementation approximated number value representing the result of raising r base to the r exponent power, the result of base exponent when base is 1 or minus 1 and exponent is plus or when base note is 1 and exponent is nan, differs from IE E754-2019. The first edition of ECMAScript specified a result of nan for this operation, whereas later revisions of IE E754 specified one. The historical ECMAScript behavior is preserved for compatibility reasons. 2. ECMA International 2024 6 1 6 1 for number multiply x y. The abstract operation number multiply takes arguments x, a number, and y, a number, and returns a number. It performs multiplication according to the rules of IE E754-2019 binary double precision arithmetic, producing the product of x and y. It performs the following steps when called: ifx, ifxa, b, c, ifa, b, c, ifxa, b, ifa is nan or y is nan. Return nan is either plus or. Then, if y is either plus 0 or minus 0, return nan. If y plus 0, return x. Return x is either plus or. Then, if x is either plus 0 or minus 0, return nan. If x plus 0, return y. Return y is minus 0. Then, if y is minus 0 or y minus 0, return plus 0. Else, return minus 0 is minus 0. Then, if x minus 0, return plus 0. Else, return minus 0. B. Return r x r y. Note finite precision multiplication is commutative, but not always associative. 6 1 6 1 5 number divide x y. The abstract operation number divide takes arguments x, a number, and y, a number, and returns a number. It performs division according to the rules of IE E754-2019 binary double precision arithmetic, producing the quotient of x and y where x is the dividend and y is the divisor. It performs the following steps when called: ifx, ifxa, b, c, ifa, ifa, a, ifxa, b, c, ifa, ifa is nan or y is nan. Return nan is either plus or. Then, if y is either plus or, return nan. If y is plus 0 or y plus 0, return x. Return x is plus. Then, if x is plus 0 or x plus 0, return plus 0. Otherwise, return minus 0 is. Then, if x is plus 0 or x plus 0, return minus 0. Otherwise, return plus 0 is either plus 0 or minus 0. Then, if y is either plus 0 or minus 0, return nan. If y plus 0, return x. Return x is plus 0. Then, if x plus 0, return plus. Otherwise, return is minus 0. Then, if x plus 0, return. Otherwise, return plus a. Return r x r y. ECMA International 2024 33 6 1 6 1 6 number remainder n d. The abstract operation number remainder takes arguments n, a a number, and E, a number, and returns a number. It yields the remainder from an implied division of its operands where n is the dividend and d is the divisor. It performs the following steps when called. If n is nan or d is nan, return nan. If n is either plus or, return nan. If d is either plus or, return n. If d is either plus 0 or minus 0, return nan. If n is either plus 0 or minus 0, return n. Assert n and d are finite and non-zero. Let quotient be r, n, r, d. Let q be truncate, quotient. Let r be r, n, r, d, q. 0. If r equals 0 and n minus 0, return minus 0. 1. Return r. Note 2. The result of a floating point remainder operation as computed by the percent operator is not the same as the remainder operation defined by IEEE 754-2019. The IEEE 754-2019 remainder operation computes the remainder from a rounding division, not a truncating division, and so its behavior is not analogous to that of the usual integer remainder operator. Instead, the ECMAScript language defines percent on floating point operations to behave in a manner analogous to that of the Java integer remainder operator. This may be compared with the C library function fmod, 1, 6, 1, 7 number, add, x, y. The abstract operation number, add takes arguments x, a number, and y, a number, and returns a number. It performs addition according to the rules of IEEE 754-2019, binary double precision arithmetic, producing the sum of its arguments. It performs the following steps when called. If x is nan or y is nan, return nan. If x is plus and y is, return nan. If x is and y is plus, return nan. If x is either plus or, return x. If y is either plus or, return y. Assert x and y are both finite. If x is minus 0 and y is minus 0, return minus 0. Return r, x plus r, y. Note finite precision addition is commutative, but not always associative. 6, 1, 6, 1, 8 number. Subtract t, x, y. The abstract operation number, subtract takes arguments x, a number, and y, a number, and returns a number. It performs subtraction, producing the difference of its operands. X is the minuend and y is the subtrahend. It performs the following steps when called. Return number, add, x, number, unary minus, y. 34. ECMA International 2024. Note 1 in C and C++. The remainder operator accepts only integral operands. In ECMAScript, it also accepts floating point operands. Note, it is always the case that x, y produces the same result as x plus y. 6, 1, 6, 1, 9 number. Left shift, x, y. The abstract operation number, left shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Little numby, to int 32. X, let renum to int 32. Y, let shift count br, renum, modulo 32. Return the result of left shifting num by shift count bits. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1, 0 number. Signed right shift, x, y. The abstract operation number, signed right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Little numby, to int 32. X, let renum to int 32. Y, let shift count br, renum, modulo 32. Return the result of performing a sign extending right shift of num by shift count bits. The most significant bit is propagated. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1, 1 number, and signed right shift, x, y. The abstract operation number, and signed right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Little numby, to int 32. X, let run B. Tune 32. Y, let shift count BR. Run modulo 32. Return the result of performing a 0 filling right shift of num by shift count bits. Vacated bits are filled with 0. The mathematical value of the result is exactly representable as a 32-bit unsigned bit string, 1, 6, 1, 1, 2 number, less than, x, y. The abstract operation number, less than takes arguments x, a number, and y, a number, and returns a boolean or undefined. It performs the following steps when called. If x is nan, return undefined. If y is nan, return undefined. If x is y, return false. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. If x is plus, return false. If y is plus, return true. If y is, return false. If x is, return true. 0. Assert x and y are finite. 1. If r, x, r, y, return true. Otherwise, return false, 1, 6, 1, 1, 3 number, equal, x, y. The abstract operation number, equal takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan, return false. If y is nan, return false. ECMA International 2024 35. 3. If x is y, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. Return false, 1, 6, 1, 1, 4 number, same value, x, y. The abstract operation number, same value takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. If x is y, return true. Return false, 1, 6, 1, 1, 5 number, same value 0, x, y. The abstract operation number, same value 0 takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. If x is y, return true. Return false, 1, 6, 1, 1, 6 number bitwise op, x, y. The abstract operation number bitwise op takes arguments op, and, or, x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be to int 32, x, let num be to int 32, y, let bits be the 32-bit 2's complement bit string representing r, num, let rebits be the 32-bit 2's complement bit string representing r, num. If op is and, then, a let result be the result of applying the bitwise and operation to bits and rebits. Else if op is, then, a let result be the result of applying the bitwise exclusive or, XOR, operation to bits and rebits. Else, assert, op is, be let result be the result of applying the bitwise inclusive or operation to bits and rebits. Return the number value for the integer represented by the 32-bit 2's complement bit string result, 1, 6, 1, 1, 7 number, bitwise and, x, y. The abstract operation number, bitwise and takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, and, x, y, 1, 6, 1, 1, 8 number, bitwise or, x, y. The abstract operation number, bitwise or takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, x, y, 6, ECMA International 2024, 6, 1, 6, 1, 1, 9 number, bitwise or, x, y. The abstract operation number, bitwise or takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, x, y, 1, 6, 1, 2, 0 number, to string, x, radix, the abstract operation number, to string takes arguments x, a number, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a number using radix are taken from the first R code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ab is in order. The representation of numbers with magnitude greater than or equal to 1 never includes leading zeros. It performs the following steps when called. If x is nan, return nan. If x is either plus 0 or minus 0, return 0. If x minus 0, return the string concatenation of a number, to string, x, radix. If x is plus, return infinity. Let n, k, and s be integers such that k1, radix 1s, radix, s radix, k, is x, and k is as small as possible. Note that k is the number of digits in the representation of s using radix, that s is not divisible by radix, and that the least significant digit of s is not necessarily uniquely determined by these criteria. If radix 10 or n is in the inclusive interval from -5 to 21, then if nk, then I return the string concatenation of the code units of the k digits of the representation of s using radix, n, k occurrences of the code unit 0 times 0030, digit 0, b else if n, 0, then I return the string concatenation of the code units of the most significant n digits of the representation of s using radix. The code unit 0 times 002e, full stop. The code units of the remaining k, n digits of the representation of s using radix. See else. I assert n02. Return the string concatenation of the code unit 0 times 0030, digit 0. The code unit 0 times 002e, full stop. N occurrences of the code unit 0 times 0030, digit 0. The code units of the k digits of the representation of s using radix. Note, in this case, the input will be represented using scientific e notation, such as 1.2e plus 3. Assert radix is 10. If n, 0, then a let exponent sign be the code unit 0 times 002d, hyphen minus 0, else a let exponent sign be the code unit 0 times 002b plus sign 11. If k equals 1, then I return the string concatenation of the code unit of the single digit of s, the code unit 0 times 0065, Latin small letter e, exponent sign, the code units of the decimal representation of abs, n1, 2. Return the string concatenation of the code unit of the most significant digit of the decimal representation of s, the code unit 0 times 002e, full stop. The code units of the remaining k1 digits of the decimal representation of s, the code unit 0 times 0065, Latin small letter e, exponent sign, the code units of the decimal representation of abs, N1, ECMA International 2024-37. Note 1. The following observations may be useful as guidelines for implementations, but are not part of the normative requirements of this standard. If x is any number value other than -0, then to number, to string, x, is x. The least significant digit of s is not always uniquely determined by the requirements listed in Step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of Step 5 be used as a guideline. Let n, k, and s be integers such that k1, radix 1s, radix, s radix, k, is x, and k is as small as possible. If there are multiple possibilities for s, choose the value of s for which s, radix, k is closest in value to r, x. If there are two such possible values of s, choose the one that is even. Note that k is the number of digits in the representation of s using radix and that s is not divisible by radix. Note 3. Implementers of ECMAScript may find useful the paper and code written by David M. Gay for binary to decimal conversion of floating point numbers. Gay, David M. correctly rounded binary decimal and decimal binary conversions. Numerical analysis. Manuscript 9010. AT&T Bell Laboratories, Murray Hill, New Jersey, the 30th of November, 1990. Available as http://ampbell.com/refs/abstracts.html rounding. Associated code available as http://netlib.sandia.gov/fp/dtour.c and as http://netlib.sandia.gov/fp/g_fmt.c and may also be found at the various netlib mirror sites. 1. 6. To the big int type. The big int type represents an integer value. The value may be any size and is not limited to a particular bit width. Generally, when not otherwise noted, operations are designed to return exact mathematically based answers. For binary operations, big ints act as 2's complement binary strings, with negative numbers treated as having bits set infinitely to the left. 1, 6, 2, 1 big int, unary minus, x. The abstract operation big int, unary minus takes argument x, a big int, and returns a big int. It performs the following steps when called. If x is 0z, return 0z. Return x, 1, 6, 2, 2 big int, bitwise not, x. The abstract operation big int, bitwise not takes argument x, a big int, and returns a big int. It returns the ones complement of x. It performs the following steps when called. Return x1z. 8. ECMA International 2024. 6. 1. 6. 2. 3 big int. Exponentiate. Base. Exponent. The abstract operation big int. Exponentiate takes arguments base, a big int, and exponent, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If exponent 0z, throw a range error exception. If base is 0z and exponent is 0z, return 1z. Return base raised to the power exponent, 1, 6, 2, 4 big int, multiply, x, y. The abstract operation big int, multiply takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return xy, 1, 6, 2, 5 big int, divide, x, y. The abstract operation big int, divide takes arguments x, a big int, and y, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If y is 0z, throw a range error exception. Let quotient be r, x, r, y. Return z, truncate, quotient, 1, 6, 2, 6 big int, remainder, n, d. The abstract operation big int, remainder takes arguments n, a big int, and dd, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If t is 0z, throw a range error exception. If n is 0z, return 0z. Let quotient be r, n, r, d. Let q be z, truncate, quotient, return n, dq. Note the sign of the result is the sign of the dividend, 1, 6, 2, 7 big int, add, x, y. The abstract operation big int, add takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return x plus y, 1, 6, 2, 8 big int, subtract, x, y. The abstract operation big int, subtract takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return x, y. Note even if the result has a much larger bit width than the input, the exact mathematical answer is given. Copyright sign, ECMA International 2024 39 6 1 6 2 9 begint, left shift, x, y. The abstract operation begint, left shift takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. If y, 0 z, then a return z, floor, r, x, to r, y, return x to z, comma 1, 6, 2, 1 0 begint, signed right shift, x, y. The abstract operation begint, signed right shift takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. 1. Return begint, left shift, x, y, comma 1, 6, 2, 1 1 begint, and signed right shift, x, y. The abstract operation begint, and signed right shift takes arguments x, a begint, and y, a begint, and returns a throw completion. It performs the following steps when called. 1. Throw type error exception, comma 1, 6, 2, 1 2 begint, less than, x, y. The abstract operation begint, less than takes arguments x, a begint, and y, a begint, and returns a boolean. It performs the following steps when called. If r, x, r, y, return true, otherwise return false, comma 1, 6, 2, 1 3 begint, equal, x, y. The abstract operation begint, equal takes arguments x, a begint, and y, a begint, and returns a boolean. It performs the following steps when called. If r, x, equals r, y, return true, otherwise return false, comma 1, 6, 2, 1 4 binary and x, y. The abstract operation binary and takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 1, return 1, else, return 0, comma 1, 6, 2, 1 5 binary, or x, y. The abstract operation binary or takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. 1, 2. If x equals 1 or y equals 1, return 1. Else, return 0. 0. ECMA International 2024. Note semantics here should be equivalent to a bitwise shift, treating the begint as an infinite length string of binary 2's complement digits. 6, 1, 6, 2, 1 6 binaries or x, y. The abstract operation binaries or takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 0, return 1. Else if x equals 0 and y equals 1, return 1. Else, return 0, comma 1, 6, 2, 1 7 begint bitwise op, x, y. The abstract operation begint bitwise op takes arguments op, and, or, x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. Set x to r, x, set y to r, y. Let result be 0, let shift be 0. Repeat until x equals 0 or x equals -1, and y equals 0 or y equals -1. Let x digit be x modulo 2, b let y digit be y modulo 2. See if op is and, then I set result to result plus 2 shift binary and x digit, y digit d. Else if op is, then I set result to result plus 2 shift binary or x digit, y digit e. Else I assert op is 2. Set result to result plus 2 shift binaries or x digit, y digit. F set shift to shift plus 1. G set x to x, x digit 2.
H. Sentido. I. Ilícit. 2.
If op is and, then a let tmp be binary and x modulo 2, y modulo 2. Else if op is, then a let tmp be binary, or x modulo 2, y modulo 2. Else a assert op is b let tmp be binaries, or x modulo 2, y modulo 2. If tmp 0, then a set result to result to shift. B note, this extends the sign 0. Return the big int value for result, comma 1, 6, 2, 1, 8 big int, bitwise and x, y. The abstract operation big int, bitwise and takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, and x, y, comma 1, 6, 2, 1, 9 big int, bitwise, or x, y. The abstract operation big int, bitwise or takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, x, y. ECMA International 2024 41, 6, 1, 6, 2, 20 big int, bitwise or x, y. The abstract operation big int, bitwise or takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, x, y, comma 1, 6, 2, 2, 1 big int, to string, x, radix. The abstract operation big int, to string takes arguments x, a big int, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a big int using radix are taken from the first R code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is in order. The representation of big ints other than 0z never includes leading zeros. It performs the following steps when called. If x, 0z, return the string concatenation of an big int, to string, x, radix. Return the string value consisting of the representation of x using radix, comma 1.7 the object type. Each instance of the object type, also referred to simply as an object, represents a collection of properties. Each property is either a data property or an accessor property. A data property associates a key value with an ECMAScript language value and a set of Boolean attributes. An accessor property associates a key value with one or two accessor functions and a set of Boolean attributes. The accessor functions are used to store or retrieve an ECMAScript language value that is associated with the property. The properties of an object are uniquely identified using property keys. A property key is either a string or a symbol. All strings and symbols, including the empty string, are valid as property keys. A property name is a property key that is a string. An integer index is a property name n such that canonical numeric index string n returns an integral number in the inclusive interval from +0 to 253 1. An array index is an integer index n such that canonical numeric index string n returns an integral number in the inclusive interval from +0 to 232 2. Property keys are used to access properties and their values. There are two kinds of access for properties, get and set, corresponding to value retrieval and assignment, respectively. The properties accessible via get and set access includes both own properties that are a direct part of an object and inherited properties which are provided by another associated object via a property inheritance relationship. Inherited properties may be either own or inherited properties of the associated object. Each own property of an object must each have a key value that is distinct from the key values of the other own properties of that object. All objects are logically collections of properties, but there are multiple forms of objects that differ in their semantics for accessing and manipulating their properties. Please see 6, 1, 7, 2 for definitions of the multiple forms of objects. In addition, some objects are callable. These are referred to as functions or function objects and are described further below. All functions in ECMAScript are members of the object type, 1, 7, 1 property attributes. Attributes are used in this specification to define and explain the state of object properties as described in Table 3. Unless specified explicitly, the initial value of each attribute is its default value. Note every non-negative safe integer has a corresponding integer index. Every 32-bit unsigned integer except 232 1 has a corresponding array index. -0 is neither an integer index nor an array index. 2. Copyright sign. ECMA International 2024. Table 3. Attributes of an object property. Attribute name. Types of property for which it is present. Value domain. Default value. Description. Value. Data property. An ECMAScript language value. Undefined. The value retrieved by a get access of the property. Writable. Data property. A boolean. False. If false. Attempts by ECMAScript code to change the property's attribute using get access a property, an object or undefined. Undefined. If the value is an object, it must be a function object. The function's internal method, table 5, is called with an empty arguments list to retrieve the property value each time a get access of the property is performed. Set access a property, an object or undefined. Undefined. If the value is an object, it must be a function object. The function's internal method, table 5, is called with an arguments list containing the assigned value as its sole argument each time a set access of the property is performed. The effect of a property's internal method, enumerable, data property, or accessor property, a boolean, false. If true, the property will be enumerated by a for an enumeration. C1 4, 7, 5. Otherwise, the property is said to be non-enumerable, configurable, data property, or accessor property, a boolean, false. If false, attempts to delete the property, change it from a data property to an accessor property or from an accessor property to a data property, or make any changes to its attributes, other than replacing an existing or setting to false, will fail. 6, 1, 7, 2 object internal methods and internal slots. The actual semantics of objects in ECMAScript are specified via algorithms called internal methods. Each object in an ECMAScript engine is associated with a set of internal methods that defines its runtime behavior. These internal methods are not part of the ECMAScript language. They are defined by the specification purely for expository purposes. However, each object within an implementation of ECMAScript must behave as specified by the internal methods associated with it. The exact manner in which this is accomplished is determined by the implementation. Internal method names are polymorphic. This means that different object values may perform different algorithms when a common internal method name is invoked upon them. That actual object upon which an internal method is invoked is the target of the invocation. If, at runtime, the implementation of an algorithm attempts to use an internal method of an object that the object does not support, a type error exception is thrown. Internal slots correspond to internal state that is associated with objects and used by various ECMAScript specification algorithms. Internal slots are not object properties and they are not inherited. Depending upon the specific ECMA International 2024-43 internal slot specification, such state may consist of values of any ECMAScript language type or of specific ECMAScript specification type values. Unless explicitly specified otherwise, internal slots are allocated as part of the process of creating an object and may not be dynamically added to an object. Unless specified otherwise, the initial value of an internal slot is the value undefined. Various algorithms within this specification create objects that have internal slots. However, the ECMAScript language provides no direct way to associate internal slots with an object. All objects have an internal slot named, which is a list of private elements. This list represents the values of the private fields, methods, and accessors for the object. Initially, it is an empty list. Internal methods and internal slots are identified within this specification using names enclosed in double square brackets. Table 4 summarizes the essential internal methods used by this specification that are applicable to all objects created or manipulated by ECMAScript code. Every object must have algorithms for all of the essential internal methods. However, all objects do not necessarily use the same algorithms for those methods. An ordinary object is an object that satisfies all of the following criteria for the internal methods listed in Table 4. The object uses those defined in 10.1. If the object has an internal method, it uses either the one defined in 1.0, 2, 1 or the one defined in 0, 3, 1. If the object has an internal method, it uses either the one defined in 1.0, 2, 2 or the one defined in 0, 3, 2. An exotic object is an object that is not an ordinary object. This specification recognizes different kinds of exotic objects by those objects' internal methods. An object that is behaviorally equivalent to a particular kind of exotic object, such as an array exotic object or a bound function exotic object, but does not have the same collection of internal methods specified for that kind, is not recognized as that kind of exotic object. The signature column of Table 4 and other similar tables describes the invocation pattern for each internal method. The invocation pattern always includes a parenthesized list of descriptive parameter names. If a parameter name is the same as an ECMAScript type name, then the name describes the required type of the parameter value. If an internal method explicitly returns a value, its parameter list is followed by the symbol and the type name of the returned value. The type names used in signatures refer to the types defined in Clause 6, augmented by the following additional names. Any means the value may be any ECMAScript language type. In addition to its parameters, an internal method always has access to the object that is the target of a method invocation. An internal method implicitly returns a completion record, either a normal completion that wraps a value of the return type shown in its invocation pattern, or a throw completion. Table 4. Essential internal methods. Internal method, signature, description, get prototype of object null. Determine the object that provides inherited properties for this object. A null value indicates that there are no inherited properties. Set prototype of object null. Boolean, associate this object with another object that provides inherited properties. Passing null indicates that there are no inherited properties. Returns true indicating that the operation was completed. Successfully or false indicating that the operation was not successful. Is extensible. Boolean, determine whether it is permitted to add additional properties to this object. 44. ECMA International 2024. Table 4. Essential internal methods. Continued. Internal method, signature, description, prevent extensions. Boolean, control whether new properties may be added to this object. Returns true if the operation was successful or false if the operation was unsuccessful. Get own property, property key, undefined property descriptor. Return a property descriptor for the own property of this object whose key is property key, or undefined if no such property exists. Define own property, property key, property descriptor. Boolean, create or alter the own property, whose key is property key, to have the state described by property descriptor. Return true if that property was successfully created, updated, or false if the property could not be created or updated. Has property, property key, Boolean, return a Boolean value indicating whether this object already has either an own or inherited property whose key is property key. Get, property key, receiver, any, return the value of the property whose key is property key from this object. If any ECMAScript code must be executed to retrieve the property value, receiver is used as this value when evaluating the code. Set, property key, value, receiver, Boolean, set the value of the property whose key is property key to value. If any ECMAScript code must be executed to set the property value, receiver is used as this value when evaluating the code. Returns true if the property value is set or false if it could not be set. Delete, property key, Boolean, remove the own property whose key is property key from this object. Return false if the property was not deleted and is still present. Return true if the property was deleted or is not present. Own property keys. List of property keys. Return a list whose elements are all of the own property keys for the object. Table 5 summarizes additional essential internal methods that are supported by objects that may be called as functions. A function object is an object that supports the internal method. A constructor is an object that supports the internal method. Every object that supports must support, that is, every constructor must be a function object. Therefore, a constructor may also be referred to as a constructor function or constructor function object. ECMA International 2024-45. Table 5. Additional essential internal methods of function objects. Internal method, signature, description, call, any, a list of any, executes code associated with this object. Invoked via a function call expression. The arguments to the internal method are this value and a list whose elements are the arguments passed to the function by a call expression. Objects that implement this internal method are callable. Construct a list of any object creates an object. invoked via the new operator or a supercall. The first argument of the internal method is a list whose elements are the arguments of the constructor invocation or the supercall. The second argument is the object to which the new operator was initially applied. Objects that implement this internal method are called constructors. A function object is not necessarily a constructor, and such non-constructor function objects do not have an internal method. The semantics of the essential internal methods for ordinary objects and standard exotic objects are specified in clause 10. If any specified use of an internal method of an exotic object is not supported by an implementation, that usage must throw a type error exception when attempted. 1. 7. 3. Invariants of the essential internal methods. The internal methods of objects of an ECMAScript engine must conform to the list of invariants specified below. Ordinary ECMAScript objects as well as all standard exotic objects in this specification maintain these invariants. ECMAScript proxy objects maintain these invariants by means of runtime checks on the result of traps invoked on the object. Any implementation provided exotic objects must also maintain these invariants for those objects. Violation of these invariants may cause ECMAScript code to have unpredictable behavior and create security issues. However, violation of these invariants must never compromise the memory safety of an implementation. An implementation must not allow these invariants to be circumvented in any manner, such as by providing alternative interfaces that implement the functionality of the essential internal methods without enforcing their invariants. Definitions. The target of an internal method is the object upon which the internal method is called. A target is non-extensible if it has been observed to return false from its internal method, or true from its internal method. A non-existent property is a property that does not exist as an own property on a non-extensible target. All references to same value are according to the definition of the same value algorithm. Return value. The value returned by any internal method must be a completion record with either 46 ECMA International 2024 bullet type equals normal equals empty and equals a value of the normal return type shown below for that internal method, or type equals throw equals empty and equals any ECMAScript language value. Note 1. An internal method must not return a continue completion, a break completion, or a return completion. The normal return type is either object or null. If target is non-extensible and returns a value v, then a ny future calls to get prototype of should return the same value as v. Set prototype of v. The normal return type is Boolean. If target is non-extensible, must return false, unless v is the same value as the target's observed value is extensible. The normal return type is Boolean. If returns false, all future calls to on the target must return false. Prevent extensions. The normal return type is Boolean. If returns true, all future calls to on the target must return false and the target is now considered non-extensible. Get own property. P. The normal return type is either property descriptor or undefined. If the type of the return value is property descriptor, the return value must be a fully populated property descriptor. If P is described as a non-configurable, non-writable own data property, all future calls to P must return property descriptor whose is same value as P's attribute. If P's attributes other than and may change over time, or if the property might be deleted, then P's attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the target is non-extensible and P is non-existent, then all future calls to P on the target must describe P as non-existent. That is, P must return undefined. Define own property. P desk. The normal return type is Boolean. Must return false if P has previously been observed as a non-configurable own property of the target, unless either P is a writable data property. A non-configurable writable data property can be changed into a non-configurable non-writable data property. All attributes of desk are the same value as P's attributes. Note to an object's prototype change should have finite length. That is, starting from any object, recursively applying the internal method to its result should eventually lead to the value null. However, this requirement is not enforceable as an object-level invariant if the prototype chain includes any exotic objects that do not use the ordinary object definition of Such a circular prototype chain may result in infinite loops when accessing object properties. Note 3 is a consequence of the third invariant. If a property is described as a data property and it may return different values over time, then either or both of the and attributes must be true even if no mechanism to change the value is exposed via the other essential internal methods. ECMA International 2024-47, P, desc, must return false if target is non-extensible and P is a non-existent own property. That is, a non-extensible target object cannot be extended with new properties. Has property P, the normal return type is Boolean if P was previously observed as a non-configurable own data or access a property of the target. Has property must return true. The normal return type is any ECMAScript language type if P was previously observed as a non-configurable, non-writable own data property of the target with value v. Then, if P was previously observed as a non-configurable own access a property of the target whose attribute is undefined, the P, v, receiver, the normal return type is Boolean if P was previously observed as a non-configurable, non-writable own data property of the target, then must return false unless v is the same value as P's attribute. If P was previously observed as a non-configurable own access a property of the target whose attribute is undefined, the P, the normal return type is Boolean if P was previously observed as a non-configurable own data or access a property of the target, must return false. The normal return type is list. The returned list must not contain any duplicate entries. The type of each element of the returned list is either string or symbol. The returned list must contain at least the keys of all non-configurable own properties that have previously been observed. If the target is non-extensible, the returned list must contain only the keys of all own properties of the target that are observable using call. The normal return type is any ECMAScript language type. 8. ECMA International 2024. Bullet. The normal return type is object. The target must also have internal method. 6. 1. 7. For well-known intrinsic objects. Well-known intrinsics are built-in objects that are explicitly referenced by the algorithms of this specification and which usually have realm-specific identities. Unless otherwise specified, each intrinsic object actually corresponds to a set of similar objects, one per realm. Within this specification, a reference such as %name means the intrinsic object associated with the current realm, corresponding to the name. A reference such as %name may be %means, as if the B property of the value of the A property of the intrinsic object %name was accessed prior to any ECMAScript code being evaluated. Determination of the current realm and its intrinsics is described in 9.4. The well-known intrinsics are listed in Table 6. Table 6. Well-known intrinsic objects. Intrinsic name, global name, ECMAScript language association, aggregate error %, aggregate error, the aggregate error constructor, 20571, array %, array, the array constructor, 2311, array buffer %, array buffer, the array buffer constructor, 2514, array iterator prototype %, the prototype of array iterator objects, 2315, async from sync iterator prototype %, the prototype of async from sync iterator objects, 2714, async function %, the constructor of async function objects, 2771, async generator function %, the constructor of async iterator objects, 2741, async iterator prototype %, an object that all standard built-in async iterator objects indirectly inherit from atomics %, atomics, the atomics object, 25.4, big int %, big int, the big int constructor, 2121, big int 64 array %, big int 64 array, the big int 64 array constructor, 23.2, big int 64 array %, big int 64 array, the big int 64 array constructor, 23.2, boolean %, boolean, the boolean constructor, 2031, data view %, data view, the data view constructor, 2532, date %, date, the date constructor, 2142, decodery %, decodery, the decodery function, 1926, 1. Decode URI component %. Decode URI component. The decode URI component function. 1926. Encode URI %. Encode URI. The encode URI function. 1926. Encode URI component %. Encode URI component. The encode URI component function. 1926. Error %. Error. The error constructor. 2051. Copyright sign. ECMA International 2024. 9. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript Language Association. Eval %. Eval. The eval function. 1921. Eval error %. Eval error. The eval error constructor. 2055. Finalization registry %. Finalization registry. The finalization registry constructor. 2621. Float 32 array %. Float 32 array. The float 32 array constructor. 23.2. Float 64 array %. Float 64 array. The float 64 array constructor. 23.2. For an iterator prototype %. The prototype of for an iterator objects. 14751. Function %. Function. The function constructor. 2021. Generator function %. The constructor of generators. 2731. Indate array %. Indate array. The indate array constructor. 23.2. Int 16 array %. Int 16 array. The int 16 array constructor. 23.2. Int 32 array %. Int 32 array. The int 32 array constructor. 23.2 is finite %. Is finite. The is finite function. 1922 is nan %. Is nan. The is nan function. 1923. Iterator prototype %. An object that all standard built-in iterator objects indirectly inherit from. JSON %. JSON. The JSON object. 25.5. Map %. Map. The map constructor. 2411. Map iterator prototype %. The prototype of map iterator objects. 2415. Math %. Math. The math object. 21.3. Number %. Number. The number constructor. 2111. Object %. Object. The object constructor. 2011. Parse float %. Parse float. The parse float function. 1924. Parse int %. Parse int. The parse int function. 1925. Promise %. Promise. The promise constructor. 2723. Proxy %. Proxy. The proxy constructor. 2821. Range error %. Range error. The range error constructor. 2055. Reference error %. Reference error. The reference error constructor. 20553. Reflect %. Reflect. The reflect object. 28.1. regexp %. Regexp. The regexp constructor. 22240. ECMA International 2024. The set constructor. 2 4 2 1. Set iterator prototype %. The prototype of set iterator objects. 2 4 2 5. Shared array buffer %. Shared array buffer. The shared array buffer constructor. 2 5 2 3. String %. String. The string constructor. 2 2 1 1. String iterator prototype %. The prototype of string iterator objects. 2 2 1 5. Symbol %. Symbol. The symbol constructor. 2 0 4 1. Syntax error %. Syntax error. The syntax error constructor. 2 0 5 5 4. Throw type error %. A function object that unconditionally throws a new instance of %type error %. Typed array %. The superclass of all typed array constructors. 2 3 2 1. Type error %. Type error. The type error constructor. 2 0 5 5 5. Undate array %. Undate array. The undate array constructor. 23.2. Undate clamped array %. Undate clamped array. The undate clamped array constructor. 23.2. Unt16 array %. Unt16 array. The unt16 array constructor. 23.2. Unt32 array %. Unt32 array. The unt32 array constructor. 23.2. URI error %. URI error. The URI error constructor. 2 0 5 5 6. Weak map %. Weak map. The weak map constructor. 2 4 3 1. Weak ref %. Weak ref. The weak ref constructor. 2 6 1 1. Weak set %. Weak set. The weak set constructor. 2 4 4 1. Note additional entries in table 97. 6.2. ECMAScript specification types. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types include reference, list, completion record, property descriptor, environment record, abstract closure, and data block. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. ECMA International 2024 51 6 2 1. The enum specification type. Enums are values which are internal to the specification and not directly observable from ECMAScript code. Enums are denoted using a sans serif typeface. For instance, a completion records field takes on values like normal, return, or throw. Enums have no characteristics other than their name. The name of an enum serves no purpose other than to distinguish it from other enums, and implies nothing about its usage or meaning in context. 2.2. The list and record specification types. The list type is used to explain the evaluation of argument lists. C1338 in new expressions, in function calls, and in other algorithms where a simple ordered list of values is needed. Values of the list type are simply ordered sequences of list elements containing the individual values. These sequences may be of any length. The elements of a list may be randomly accessed using zero-origin indices. For notational convenience, an array-like syntax can be used to access list elements. For example, arguments 2 is shorthand for are saying the third element of the list arguments. When an algorithm iterates over the elements of a list without specifying an order, the order used is the order of the elements in the list. For notational convenience within this specification, a literal syntax can be used to express a new list value. For example, 1 2 defines a list value that has two elements, each of which is initialized to a specific value. A new empty list can be expressed as, in this specification, the phrase the list concatenation of A, B, where each argument is a possibly empty list, denotes a new list value whose elements are the concatenation of the elements, in order, of each of the arguments. In order, the record type is used to describe data aggregations within the algorithms of this specification. A record type value consists of one or more named fields. The value of each field is an ECMAScript language value or specification value. Field names are always enclosed in double brackets. For example, for notational convenience within this specification, an object literal-like syntax can be used to express a record value. For example, 42, false, empty, defines a record value that has 3 fields, each of which is initialized to a specific value. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a record value. For example, if R is the record shown in the previous paragraph, then R is shorthand for the field of R named. Schema for commonly used record field combinations may be named, and that name may be used as a prefix to a literal record value to identify the specific kind of aggregations that is being described. For example, property descriptor 42, false, true, 2.3 the set and relation specification types. The set type is used to explain a collection of unordered elements for use in the memory model. It is distinct from the ECMAScript collection type of the same name. To disambiguate, instances of the ECMAScript collection are consistently referred to as set objects within this specification. Values of the set type are simple collections of elements, where no element appears more than once. Elements may be added to and removed from sets. Sets may be unioned, intersected, or subtracted from each other. The relation type is used to explain constraints on sets. Values of the relation type are sets of ordered pairs of values from its value domain. For example, a relation on events is a set of ordered pairs of events. For a relation R and 2 values are and B in the value domain of R, RB is shorthand for saying the ordered pair, A, B, is a member of R. A relation is least with respect to some conditions when it is the smallest relation that satisfies those conditions. 2. Copyright sign, ECMA International 2024. A strict partial order is a relation value R that satisfies the following. For all A, B, and C in R's domain, it is not the case that a R A, and if a R B and B are C, then a R C. Note 1. The two properties above are called a reflexivity and transitivity, respectively. A strict total order is a relation value R that satisfies the following. For all A, B, and C in R's domain, A is B or a RB or BRA, and it is not the case that a RA, and if a RB and B are C, then a RC. Note 2. The 3 properties above are called totality, irreflexivity, and transitivity, respectively. 2. For the completion record specification type. The completion record specification type is used to explain the runtime propagation of values and control flows such as the behavior of statements, break, continue, return and throw, that perform non-local transfers of control. Completion records have the fields defined in Table 7. Table 7. Completion record fields. Field name, value, meaning, type, normal, break, continue, return, or throw, the type of completion that occurred, value, any value except a completion record, the value that was produced, target, a string or empty, the target label for directed control transfers. The following shorthand terms are sometimes used to refer to completion records. Normal completion refers to any completion record with a value of normal. Break completion refers to any completion record with a value of break. Continue completion refers to any completion record with a value of continue. Return completion refers to any completion record with a value of return. Throw completion refers to any completion record with a value of throw. Abrupt completion refers to any completion record with a value other than normal. A normal completion containing some type of value refers to a normal completion that has a value of that type in its field. Callable objects that are defined in this specification only return a normal completion or a throw completion. Returning any other kind of completion record is considered an editorial error. Implementation-defined callable objects must return either a normal completion or a throw completion. ECMA International 2024 53. 6, 2, 4, 1 normal completion. Value. The abstract operation normal completion takes argument value any value except a completion record, and returns a normal completion. It performs the following steps when called. Return completion record, normal, value, empty, 2, 4, 2 throw completion, value. The abstract operation throw completion takes argument value, an ECMAScript language value, and returns a throw completion. It performs the following steps when called. Return completion record, throw, value, empty, 2, 4, 3 update empty, completion record, value, capital T, he abstract operation update empty takes arguments completion record, a completion record, and value any value except a completion record, and returns a completion record. It performs the following steps when called. Assert. If completion record is either a return completion or a throw completion, then completion record is not empty. If completion record is not empty, return completion record. Return completion record, value, completion record. 2.5 The reference record specification type. The reference record type is used to explain the behavior of such operators as delete, type off, the assignment operators, the super keyword and other language features. For example, the left-hand operand of an assignment is expected to produce a reference record. A reference record is a resolved name or property binding. Its fields are defined by Table 8. Table 8. Reference record fields. Field name, value, meaning, base, an ECMAScript language value, an environment record, or unresolvable, the value or environment record which holds the binding. Of unresolvable indicates that the binding could not be resolved. Reference name, a string, a symbol, or a private name, the name of the binding. Always a string if value is an environment record. Strict, a boolean, true if the reference record originated in strict mode code. False otherwise. This value, an ECMAScript language value or empty. If not empty, the reference record represents a property binding that was expressed using the super keyword. It is called a super reference record and its value will never be an environment record. In that case, the field holds this value at the time the reference record was created. The following abstract operations are used in this specification to operate upon reference records. 4. Copyright sign, ECMA International 2024. 6. 2. 5. 1 is property reference, v. The abstract operation is property reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return false. If v is an environment record, return false. Otherwise return true. 2. 5. 2 is unresolvable reference, v. The abstract operation is unresolvable reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return true. Otherwise return false. 6. 2. 5. 3 is super reference, v. The abstract operation is super reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is not empty, return true. Otherwise return false. 6. 2. 5. 4 is private reference, v. The abstract operation is private reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is a private name, return true. Otherwise return false. 6. 2. 5. 5 get value, v. The abstract operation get value takes argument v, a reference record or an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If v is not a reference record, return v. If is unresolvable reference, v, is true. Throw a reference error exception. If is property reference, v, is true. Then, a let base obj be. To object, v, b if is private reference, v, is true. Then, I return. Private get, base obj, v, c return base obj, get this value, v, else, a let base be v, b assert. Base is an environment record. C return base get binding value, v, v, C9.1. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. ECMA International 2024 55. 6. 2. 5. 6 put value, v, w. The abstract operation put value takes arguments v, a reference record or an ECMAScript language value, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If v is not a reference record, throw a reference error exception. If is unresolvable reference, v is true. Then, if v is true, throw a reference error exception. B let global obj be get global object. C perform set global obj v w false. D return unused. If as property reference v is true, then a let base obj be to object v b. If as private reference v is true, then I return private set base obj v w. C let succeeded be base obj w. Get this value v. D if succeeded is false and v is true, throw a type error exception. E return unused. Else a let base be v. B assert base is an environment record. C return base set mutable binding v w v. C 9.1, 2, 5, 7 get this value v. The abstract operation get this value takes argument v, a reference record, and returns an ECMAScript language value. It performs the following steps when called. Assert is property reference v is true. If is super reference v is true, return v. Otherwise return v. 2, 5, 8 initialize reference binding v w. The abstract operation initialize reference binding takes arguments v, a reference record, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. Assert is unresolvable reference v is false. Let base be v. Assert base is an environment record. Return base initialize binding v w, 2, 5, 9 make private reference base value private identifier. The abstract operation make private reference takes arguments base value, an ECMAScript language value, and private identifier, a string, and returns a reference record. It performs the following steps when called. Let privy be the running execution context's private environment. Assert privy is not null. Let private name be resolved private identifier privy private identifier. Return the reference record base value private name true. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. 6. ECMA International 2024. This value empty. 6. 2. 6. The property descriptor specification type. The property descriptor type is used to explain the manipulation and reification of object property attributes. A property descriptor is a record with 0 or more fields, where each field's name is an attribute name and its value is a corresponding attribute value as specified in 6, 1, 7, 1. The schema name used within this specification to tag literal descriptions of property descriptor records is property descriptor. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither, in which case it is a generic property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the corresponding fields defined in Table 3. The following abstract operations are used in this specification to operate upon property descriptor values. 6, 2, 6. 1 is accessor descriptor, desk. The abstract operation is accessor descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a, return false. 2, 6. 2 is data descriptor, desk. The abstract operation is data descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a field, return true. If desk has a field, return true. Return false. 2, 6. 3 is generic descriptor, desk. The abstract operation is generic descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If is accessor descriptor, desk, is true, return false. If is data descriptor, desk, is true, return false. Return true, 2, 6, 4 from property descriptor, desk. The abstract operation from property descriptor takes argument desk, a property descriptor or undefined, and returns an object or undefined. It performs the following steps when called. If desk is undefined, return undefined. Let obj be ordinary object create, %object prototype %assert. Obj is an extensible ordinary object with no own properties. If desk has a field, then a perform. Create data property or throw, obj, value, desk. ECMA International 2024 57, 5. If desk has a field, then a perform. Create data property or throw, obj, writable, desk. If desk has a perform. Create data property or throw, obj, get, desk. If desk has a perform. Create data property or throw, obj, set, desk. If desk has an field, then a perform. Create data property or throw, obj, enumerable, desk. If desk has a field, then a perform. Create data property or throw, obj, configurable, desk. 0. Return obj, 2, 6, 5 to property descriptor, obj. The abstract operation to property descriptor takes argument obj, an ECMAScript language value, and returns either a normal completion containing a property descriptor or a throw completion. It performs the following steps when called. If obj is not an object, throw a type error exception. Let desk be a new property descriptor that initially has no fields. Let has enumerable be. Has property, obj, enumerable. If his enumerable is true, then a let enumerable be to boolean. Get, obj, enumerable be set desk to enumerable. Let has configurable be. Has property, obj, configurable. If his configurable is true, then a let configurable be to boolean. Get, obj, configurable be set desk to configurable. Let has value be. Has property, obj, value. If his value is true, then a let value be. Get, obj, value be set desk to value. Let has writable be. Has property, obj, writable. 0. If his writable is true, then a let writable be to boolean. Get, obj, writable be set desk to writable. 1. Let his get be. Has property, obj, get. 2. If his get is true, then a let getter be. Get, obj, get. Be if is callable. Getter is false and getter is not undefined. Throw a type error exception C set desk to 3. Let his set be. Has property, obj, set. 4. If his set is true, then a let setter be. Get, obj.
I have all my notes or whatever, so I'm gonna like find and replace these last problematic HTML JavaScript files. Then I'll pick whatever to do next. There's a couple like whatever things I need to do to like organize things. I don't know, I'll pick whatever to do after I get this done. Need some more water.
8. ECMA International 2024 AB. If desk does not have a field, set desk to like. If desk does not have a field, set desk to like. 3. Else. If desk does not have a to like. B. If desk does not have a to like. If desk does not have an field, set desk to like. If desk does not have a field, set desk to like. Return unused. 2.7 The environment record specification type. The environment record type is used to explain the behavior of name resolution in nested functions and blocks. This type and the operations upon it are defined in 9.1, 2.8. The abstract closure specification type. The abstract closure specification type is used to refer to algorithm steps together with a collection of values. Abstract closures are meter values and are invoked using function application styles such as closure, arg1, arg2. Like abstract operations, invocations perform the algorithm steps described by the abstract closure. In algorithm steps that create an abstract closure, values are captured with the verb capture followed.
So just gotta like make a copy of whatever it did for the unsigned and for the signed in. Oh, and then I have to look for any places where there's just an int without signed or unsigned before it, and I have to make those signed ins. So that'll be fun. I really hope there's no places left where there's just an int, because I won't bother, but yeah, it makes things a little bit more complicated to deal with. Because yeah, it's just whatever.
255. A data block value is created with a fixed number of bytes that each have the initial value 0. For notational convenience within this specification, an array-like syntax can be used to access the individual bytes of a data block value. This notation presents a data block value as a 0 origined integer index sequence of bytes. For example, if db is a 5-byte data block value, then db2 can be used to access its third byte. A data block that resides in memory that can be referenced from multiple agents concurrently is designated a shared data block. A shared data block has an identity for the purposes of equality testing shared data block values. That is address-free. It is tied not to the virtual addresses the block is mapped to in any process, but to the set of locations in memory that the block represents. Two data blocks are equal only if the sets of the locations they contain are equal. Otherwise, they are not equal and the intersection of the sets of locations they contain is empty. Finally, shared data blocks can be distinguished from data blocks. The semantics of shared data blocks is defined using shared data block events by the memory model. Abstract operations below introduce shared data block events and act as the interface between evaluation semantics and the event semantics of the memory model. The events form a candidate execution, on which the memory model acts as a filter. Please consult the memory model for full semantics. Shared data block events are modeled by records defined in the memory model. ECMA International 2024-59. The following abstract operations are used in this specification to operate upon data block values. 6, 2, 9, 1. Create byte data block. Size. The abstract operation create byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a data block or a throw completion. It performs the following steps when called. If size 253.1, throw a range error exception. Let db be a new data block value consisting of size bytes. If it is impossible to create such a data block, throw a range error exception. Set all of the bytes of db to 0. Return db, 2, 9, 2. Create shared byte data block. Size. The abstract operation create shared byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a shared data block or a throw completion. It performs the following steps when called. Let db be a new shared data block value consisting of size bytes. If it is impossible to create such a shared data block, throw a range error exception. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let 0 be 0. For each index I of db, do a append write shared memory. Init. True. db. I. 1, 0. To events record. Return db, 2, 9, 3. Copy data block bytes. To block. To int x. From block. From int x. Count. The abstract operation copy data block bytes takes arguments to block, a data block or a shared data block. To int x. a non-negative integer, from block, a data block or a shared data block, from int x, a non-negative integer, and count, a non-negative integer, and returns unused. It performs the following steps when called: assert, from block into block a distinct values. Let from size be the number of bytes in from block. Assert, from index plus count from size. Let to size be the number of bytes into block. Assert, to index plus count to size. Repeat, while count, 0, 0, ECMA International 2024. A. If from block is a shared data block, then I2, 3i, v, v7. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let bytes be a list whose sole element is a non-deterministically chosen byte value. Note, in implementations, bytes is the result of a non-atomic read instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let read event be read shared memory, unordered, true, from block, from index. 1. Append read event to events record. Append chosen value record. Read event, bytes, to execution. 8. If to block is a shared data block, then append write shared memory, unordered, true, to block. Byte int x, to index. 1. Bytes, to events record 9. Else set to block, to int x, to bytes, 0 be else. I assert, to block is not a shared data block. 2. Set to block, to int x, to from block, from index. C set to index plus 1. D set from index plus 1. E set count to count 1. Return unused. 2.10 The private element specification type. The private element type is a record used in the specification of private class fields, methods, and access source. Although property descriptors are not used for private elements, private fields behave similarly to non-configurable, non-enumerable, writable data properties. Private methods behave similarly to non-configurable, non-enumerable, non-writable data properties, and private accessors behave similarly to non-configurable, non-enumerable accessor properties. Values of the private element type are record values whose fields are defined by Table 9. Such values are referred to as privat elements. Table 9. Private element fields. Field name. Values of the field for which it is present. Value, meaning key, all. A private name. The name of the field, method, or accessor. Kind, all. Field, method, or accessor. The kind of the element. Value, field and method. An ECMAScript language value. The value of the field. Get, accessor. A function object or undefined. The getter for a private accessor. Set, accessor. A function object or undefined. The setter for a private accessor. The 6th of February 2011 The class field definition record specification type. The class field definition type is a record used in the specification of class fields. Values of the class field definition type are record values whose fields are defined by Table 10. Such values are referred to as class field definition records. Table 10. Class field definition record fields. Field name. Value, meaning name, a private name, a string, or a symbol. The name of the field. Initializer. An ECMAScript function object or empty. The initializer of the field, if any. Copyright sign. ECMA International 2024. 1. The 6th of February 2012 Private names. The private name specification type is used to describe a globally unique value, one which differs from any other private name, even if they are otherwise indistinguishable, which represents the key of a private class element field, method, or accessor. Each private name has an associated immutable which is a string value. A private name may be installed on any ECMAScript object with private field add or private method or accessor add, and then read or written using private get and private set. 2.13 The class static block definition record specification type. A class static block definition record is a record value used to encapsulate the executable code for a class static initialization block. Class static block definition records have the fields listed in Table 11. Table 11. Class static block definition record fields. Abstract operations. These operations are not a part of the ECMAScript language. They are defined here solely to aid the specification of the semantics of the ECMAScript language. Other More specialized abstract operations are defined throughout this specification. Point 1. Type conversion. The ECMAScript language implicitly performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion abstract operations. The conversion abstract operations are polymorphic. They can accept a value of any ECMAScript language type. But no other specification types are used with these operations. The big int type has no implicit conversions in the ECMAScript language. Programmers must call big int explicitly to convert values from other types. 1.1 to primitive. Input. Preferred type. The abstract operation to primitive takes argument input, an ECMAScript language value, and optional argument preferred type, string or number, and return ns either a normal completion containing an ECMAScript language value or a throw completion. It converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. It performs the following steps when called. Field name, value, meaning, body function, an ECMAScript function object. The function object to be called during static initialization of a class. 1. If input is an object, then 2. ECMA International 2024 AB. Let exotic to prim B. Get method, input, add at to primitive. If exotic to prim is not undefined, then I have preferred type is not present, then 1. Let int be default. 2. Else if preferred type is string, then 1. Let int be string. 3. Else assert. Preferred type is number. Let hint be number. 5. Let result be. Call. Exotic to prim. Input. Hint v. If result is not an object, return result v. Throw a type error exception. See if preferred type is not present. Let preferred type be number. D. Return. Ordinary to primitive. Input, preferred type 2. Return input, 1. 1. Ordinary to primitive. O. Hint. The abstract operation ordinary to primitive takes arguments O, an object, and hint, string or number, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. If hint is string, then a let method names be to string. Value of else, a let method names be value of to string. For each element name of method names, do a let method be get name be if is callable, method is true, then I let result be call method 2. If result is not an object, return result. Throw a type error exception, 1.2 to boolean. Argument. The abstract operation to boolean takes argument an ECMAScript language value, and returns a boolean. It converts argument to a value of type boolean. It performs the following steps when called. If argument is a boolean, return argument. If argument is one of undefined, null, +0, -0, nan, 0z, or the empty string, return false. Note: this step is replaced in section B. 3, 6, 1. Return true, 1.3 to numeric value. The abstract operation to numeric takes argument value, an ECMAScript language value, and returns either a normal completion containing either a number or a big int, or a throw completion. It returns value converted to a number or a big int. It performs the following steps when called. Let prim value be to primitive value number. If prim value is a big int, return prim value. Return to number, prim value, 1.4 to number. Argument. The abstract operation to number takes argument an ECMAScript language value, and returns either a normal completion containing a number or a throw completion. It converts argument to a value of type number. It performs the following steps when called. If argument is a number, return argument. If argument is either a symbol or a big int, throw a type error exception. If argument is undefined, return nan. When to primitive is called without a hint, then it generally behaves as if the hint were number. Note, however, objects may override this behavior by defining a at to primitive method. Of the objects defined in this specification, only dates, C21, 4, 4, 4, 5, and symbol objects, C20, 4, 3, 5. Override the default to primitive behavior. Dates treat the absence of a hint as if the hint were string. ECMA International 2024-63. 4. If argument is either null or false, return +0. If argument is true, return 1. If argument is a string, return string to number. Argument. Assert. Argument is an object. Let prim value be. To primitive. Argument. Number. Assert. Prim value is not an object. 0. Return. To number. Prim value, 1. 4. 1 to number applied to the string type. The abstract operation string to number specifies how to convert a string value to a number value. Using the following grammar. Syntax. String numeric literal. str white spaciat. str white spaciat. str numeric literal. str white spaciat. str white space. str white space char. str white spaciat. str white space char. White space. Line terminator. str numeric literal. str decimal literal. Non-decimal integer literal. sep. str decimal literal. str unsigned decimal literal. str unsigned decimal literal. str unsigned decimal literal. str unsigned decimal literal. Infinity decimal digits. sep. Decimal digits. sep opt exponent part. sep opt. Decimal digits. sep. Exponent part. sep opt. Decimal digits. sep. Exponent part. sep opt. All grammar symbols not explicitly defined above have the definitions used in the lexical grammar for numeric literals. 1, 2, 9, 3. Note some differences should be noted between the syntax of a string numeric literal and a numeric literal. A string numeric literal may include leading and or trailing white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numeric literal that is decimal may include a plus or to indicate its sign. A string numeric literal that is empty or contains only white spaces converted to +0. Infinity and infinity are recognized as a string numeric literal but not as a numeric literal. A string numeric literal cannot include a big interliteral suffix. A string numeric literal cannot include a numeric literal separator. 4. Copyright sign. ECMA International 2024. 7. 1. 4. 1. 1 string to number. str. The abstract operation string to number takes argument str, a string, and returns a number. It performs the following steps when called. Let text be string to code points. str. Let literal be parse text. Text. String numeric literal. If literal is a list of errors, return none. Return string numeric value of literal, 1, 4, 1. To runtime semantics. String numeric value. The syntax-directed operation string numeric value takes no arguments and returns a number. It is defined piecewise over the following productions. String numeric literal. str white spaciat 1. Return +0. String numeric literal. str white spaciat. str numeric literal. str white spaciat 1. Return string numeric value of str numeric literal. str numeric literal. Non-decimal integer literal 1. Return MV of non-decimal integer literal. str decimal literal. str unsigned decimal literal. Letter B string numeric value of str unsigned decimal literal. If er is +0, return -0. Return A str unsigned decimal literal. Infinity 1. Return plus str unsigned decimal literal. Decimal digits. Decimal digits opt exponent part opt. Letter B MV of the first decimal digits. If the second decimal digits is present, then a let B be MV of the second decimal digits. B let N be the number of code points in the second decimal digits. Else a let 0 be let M 0. If exponent part is present, let E be MV of exponent part. Otherwise, let E be 0. Return round MV result. A plus B 10N, 10E. str unsigned decimal literal. Decimal digits exponent part opt. Let B be MV of decimal digits. If exponent part is present, let E be MV of exponent part. Otherwise, let E be 0. Note the conversion of a string numeric literal to a number value is similar overall to the determination of the numeric value of a numeric literal. See 1, 2, 9, 3. But some of the details are different. ECMA International 2024-65. 3. Let n be the number of code points in decimal digits. Return round mv result. Be 10 n str unsigned decimal literal. Decimal digits exponent part opt. Let a be mv of decimal digits. If exponent part is present, let e be mv of exponent part. Otherwise, let e be 0. Return round mv result. At any, 1, 4, 1, 3 round mv result. N. The abstract operation round mv result takes argument n, a mathematical value, and returns a number. It converts n to a number in an implementation-defined manner. For the purposes of this abstract operation, a digit is significant if it is not 0 or there is a non-zero digit to its left and there is a non-zero digit to its right. For the purposes of this abstract operation, the mathematical value denoted by a representation of a mathematical value is the inverse of the decimal representation of a mathematical value. It performs the following steps when called. If the decimal representation of n has 20 or fewer significant digits, return n. Let option 1 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit. Let option 2 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit and then incrementing it at the 20th position, with carrying as necessary. Let chosen be an implementation-defined choice of either option 1 or option 2. Return chosen, 1 dot.
This is why when finding and replacing whatever, you can't just mass find and replace. I like copy this, whatever.
The value with fractional part truncated, or to plus or, when that number value is infinite. It performs the following steps when called. Let number be. To number, argument. If number is one of nan, plus 0, or minus 0, return 0. If number is plus, return plus. If number is, return truncate, r. Number, 1.6 to int 32. Argument. The abstract operation to int 32 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from minus 230.
So I'm like looking through all the files to update them. Every place where it says signed in, whatever. So I have to replace everywhere with signed in to put in the new keyword. But when I'm looking whatever, there's a couple of these. It's like a comment, whatever. It says pass in as 0, whatever, so it can whatever, enter. So like if I do Control C, Control F to find, and then I click next here. Oh look, it's signed int. But this is like instead of a comment of code, it's not actually a type where I'm trying to tag it. This is literally a sentence right here, where when I do signed in, well, there's a couple of these with the other one. This is why I had to like click through each of them one by fucking one, and then undo, and then find the next, because right here it is. So if like this was like actually code, like signed in Billy Bob equals 2 or something, this is like real code here, where I want to like find signed in this keyword. I'm like searching through to replace and put the new keyword. Like if this is a new word, I'll put AA, whatever. This right here is like the middle of a sentence. it's not actually a signed in. So if I were to replace signed in, like a mass replace, there's a regex you could use, but that does not work all the time, and it's not worth it. I would end up replacing this signed in the middle of the sentence with an AAA, but also where it needs to be replaced with an AAA. And I end up with a bunch of like broken sentences, because when I'm trying to find signed in, if I just like replace every place that's used, it's not always actually where I need to replace it. And then if this was like a string, like the actual code of the program, and I was actually saving like data that I'm using in the program, it would fuck up the whole program, because I have this like random AAA when I'm supposed to have like a sentence here. Of assign intern whatever. I don't know. Text editors, this is dumb. There should be a better way to write programs. I'm done complaining for now. This just sucks. It's a waste of time. Pisses me off. I'm gonna find and replace things manually by fucking hand. It should be possible to make a word globally in all files and just replace one place and have the whole, every single, wherever, file, folder name, file path, text, notepad, editor, HTML, anywhere that exists, have it magically update in real life, like live code, just to the new word. So like, there's no need to manually go through hundreds of files to look for signed int when it could be easily mangled up with other words that are not actually what you were trying to look for and replace when updating the 32-bit to 64-bit or doing any kind of a modification to an existing program. Okay, I'm done. I'm complaining. This sucks though. It really sucks. I hate this.
Not finite or number is either +0 or -0. Return +0. Let int be truncate. Number. Let int 8-bit be int modulo 28. Return int 8-bit, 1.12 to int 8 clamp. Argument. The abstract operation to int 8 clamp takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It clamps and rounds argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps. When called, let number be to number argument. If number is nan, return +0. Let nv be the extended mathematical value of number. Let clamped be the result of clamping nv between 0 and 255. Let f be floor. Clamped. If clamped, f +0.5. Return f. If clamped, f +0.5. Return f +1. If f is even, return f. Otherwise, return f +1. Note: given the above definition of 216, the substitution of 216 for 232 in step 4 is the only difference between 232 and 216. 216 maps -0 to +0. Note: unlike most other ECMAScript integer conversion operations, 2.8 clamp rounds rather than truncates non-integral values. It also uses round half to even tie breaking, which differs from the round half up tie breaking of math round 8. ECMA International 2024, the 7th of January 2013 to big int. Argument. The abstract operation to big int takes argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts the argument to a big int value, or throws if an implicit conversion from number would be required. It performs the following steps when called. Let prim be. To primitive, argument, number, return the value that prim corresponds to in table 12. Table 12. Begin conversions. Argument type, result, undefined. Throw a type error exception, null. Throw a type error exception, boolean. Return 1 n if prim is true and 0 n if prim is false. Big int. Return prim, number. Throw a type error exception, string. Let n be string to big int. Prim, if n is undefined. Throw a syntax error exception. Return n, symbol. Throw a type error exception. The 7th of January 2014 string to big int. str. The abstract operation string to big int takes argument str, a string, and returns a big int or undefined. It performs the following steps when called. Let text be string to code points. str. Let literal be parse text. Text. String integer literal. If literal is a list of errors, return undefined. Let mv be the mv of literal. Assert. mv is an integer. Return z. mv, 1, 4. 1 string integer literal grammar. String to big int uses the following grammar. Syntax. String integer literal. str white spaciat. str white spaciat. str integer literal. str white spaciat. str integer literal. Signed integer. sep non-decimal integer literal. sep ECMA International 2024 69 7 1 1 4 2 runtime semantics. mv, the mv of string integer literal. str white spaciat is 0, the mv of string integer literal. str white spaciat. str integer literal. str white spaciat is the mv of str integer literal, 1.15 to big int 64. Argument. The abstract operation to big int 64 takes argument in ECMAScript language value, and returns either a normal completion containing a big int or a throw completion. It converts the argument to one of 264 big int values in the inclusive interval from z, minus 263, to z, 263 1. It performs the following steps when called. Let n be. To big int, argument. Let int 64-bit br, n, modulo 264. If int 64-bit 263, return z, int 64-bit 264. Otherwise return z, int 64-bit, 1.16 to big int 64. Argument. The abstract operation to big int 64 takes argument in ECMAScript language value, and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from 0z to z, 264 1. It performs the following steps when called. Let n be. To big int, argument. Let int 64-bit br, n, modulo 264. Return z, int 64-bit, 1.17 to string. Argument. The abstract operation to string takes argument in ECMAScript language value, and returns either a normal completion containing a string or a throw completion. It converts the argument to a value of type string. It performs the following steps when called. If argument is a string, return argument. If argument is a symbol, throw a type error exception. If argument is undefined, return undefined. If argument is null, return null. If argument is true, return true. If argument is false, return false. If argument...
Okay, so I updated the entire project. I should I'll do that in a second. But now I do control F, whatever. Need some water. Whatever. There's only 2 matches in the whole file for signed in, because signed in is in the word unsigned int, so I don't have to look for unsigned in, because finding signed in ends up finding anything that is signed int, and I'm done. This is fucking done. So I'm gonna open GarageBand and like make it play a, what's it called, a cymbal or something. Boom. And I'm really bored. So I'm gonna do that. Because it's a tiny step towards a whole lot more of converting program 32-bit to 64-bit. But it feels like some form of progress, though very, very small amount of progress. It's progress, nonetheless. I have so much more to update. Oh my god, it's forever. Like find this stupid instrument. Oh, I need to plug in a keyboard. I'm gonna have to go find a keyboard.
Argument to an integral number suitable for use as the length of an array-like object. It performs the following steps when called. Let len be to an integer or infinity argument. If len 0, return +0, return min len 253 1, 1.21 canonical numeric index string argument. The abstract operation canonical numeric index string takes argument a string and returns a number or undefined. If argument is either -0 or exactly matches the result of toString n for some number value n, it returns the respective number value. Otherwise, it returns undefined. It performs the following steps when called. If argument is -0, return -0. Let n be to number argument. If to string n is argument, return n, return undefined. ECMA International 2024-71. A canonical numeric string is any string value for which the canonical numeric index string abstract operation does not return undefined. 1.22 to int x value. The abstract operation to index takes argument value, an ECMAScript language value, and returns either a normal completion containing a non-negative integer or a throw completion. It converts value to an integer and returns that integer if it is non-negative and corresponds with an integer index. Otherwise, it throws an exception. It performs the following steps when called. Let integer be to an integer or infinity value. If integer is not in the inclusive interval from 0 to 253 1, throw a range error exception. Return integer. Point 2 testing and comparison operations. 2.1 require object coercible argument. The abstract operation require object coercible takes argument an ECMAScript language value and returns either a normal completion containing an ECMAScript language value or a throw completion. It throws an error if argument is a value that cannot be converted to an object using toObject. It is defined by Table 14. Table 14. Require object coercible results. Argument type result undefined. Throw a type error exception. Null. Throw a type error exception. Boolean return argument. Number return argument. String return argument. Symbol return argument. Big int return argument. Object return argument. 7 2 2 is array argument. The abstract operation is array takes argument an ECMAScript language value and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. If argument is an array exotic object, return true. If argument is a proxy exotic object, then a perform. Validate non-revoke proxy argument. B let proxy target be argument. C return is array proxy target. Return false. 2. ECMA International 2024. 7 2 3 is callable argument. The abstract operation is callable takes argument an ECMAScript language value and returns a boolean. It determines if argument is a callable function with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true, return false, comma 2.4 is constructor, argument. The abstract operation is constructor takes argument in ECMAScript language value, and returns a boolean. It determines if argument is a function object with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true, return false, comma 2.5 is extensible. O. The abstract operation is extensible takes argument O, an object, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether additional properties can be added to O. It performs the following steps when called. Return O, comma 2.6 is integral number, argument. The abstract operation is integral number takes argument in ECMAScript language value, and returns a boolean. It determines if argument is a finite integral number value. It performs the following steps when called. If argument is not a number, return false. If argument is not finite, return false. If truncate, argument, argument, return false, return true, comma 2.7 is property key, argument. The abstract operation is property key takes argument in ECMAScript language value, and returns a boolean. It determines if argument is a value that may be used as a property key. It performs the following steps when called. If argument is a string, return true. If argument is a symbol, return true, return false, comma 2.8 is regexp, argument. The abstract operation is regexp takes argument in ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. Let matcher be. Get argument at match. If matcher is not undefined, return to boolean matcher. If argument has an internal slot, return true, return false. ECMA International 2024-73 7 2 9 Static semantics is string well-formed Unicode. String. The abstract operation is string well-formed Unicode takes argument string, a string, and returns a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and determines whether it is a well-formed http://www.unicode.org/glossary/hash well_formed_code_unit_sequence UTF-16 sequence. It performs the following steps when called. Let len be the length of string. Length 0 repeat. While k, len, a let cp be code point at string k b if cp is true. Return false. C set k to k plus cp. Return true, comma 2.10 same value, x, y. The abstract operation same value takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value, x, y3. Return same value non-number, x, y, comma 2.11 same value 0, x, y. The abstract operation same value 0 takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value, ignoring the difference between +0 and -0. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value 0, x, y3. Return same value non-number, x, y. Note same value 0 differs from same value only in that it treats +0 and -0 as equivalent. The 7th of February 2012 same value non-number, x, y. The abstract operation same value non-number takes arguments x, an ECMAScript language value, but not a number, and y, an ECMAScript language value, but not a number, and returns a boolean. It performs the following steps when called.
I got a MIDI keyboard. I think this one works. I need to stop wasting time on stupid shit with the stream and just work.
Equal.
But now that I got the keyboard, I'm gonna, whatever, find the simple sound.
Within the same code units in the same positions.
It's too much effort to plug stuff in and then not do it.
International 2024. Note this algorithm differs from
So, whatever, I don't know, let's freaking open up here.
differentiating +0 from -0, 5. If x is a boolean, then if x and y are both
Like, stop Siri.
10 true.
It's not showing up. Just restart, whatever. Sucks. I gotta find the sound now because I wasted time plugging this in. The MIDI keyboards. It's not working. It's a USB cable. I can't find another one. And this one, like, it only works when it's like shoved in and like held in place, and like when you let go of the cable, just disconnects. So I think it can like play a sound on this thing. I don't have time to find another cable. Gotta like find which one is the simplest or whatever. Like 1 second. I have to stop wasting time. Okay, I found it. That was way too much work. Like, I'll just like turn it up, whatever. So I like finally use this one. Finished replacing all unsigned and signed ins, and it's on to the next thing. That was the wrong one. Dang it. That's what I meant to click. So I finished whatever replacing, and I'm on to the next thing. I thought it'd be louder than that, but I'm gonna just get back to work. That was fun. A whole lot of fun. I should just keep this open. You know what? I'm done fooling around. there's a whole lot of effort to play a symbol sound. It's not even called a symbol, whatever it's called. But I don't know, I'm gonna figure out what to do next. I have a list, so I'm gonna follow that list. At least this big chunk of the program's done.
Field name, value type, meaning, export name, a string or null. The name used to export this binding by this module, module request, a string or null. The string value of the module specifier of the export declaration null if the export declaration does not have a module specifier. Import name, a string, null, all, or all but default. The name under which the desired used for export as NS from mod declarations. All but default is used for export from mod declarations. Local name, a string or null. The name that is used to locally access the exported value from within the importing module null if the exported value is not locally accessible from within the module. Note 2 Table 59 gives examples of the export entry record fields used to represent the syntactic export forms. Table 59. Informative. Export forms mappings to export entry records. Export statement form. Export name. Module request. Import name. Local name. Export varv. V. Null. Null. V. Export default. Function F. Default. Null. Null. F. Export default. Function. Default. Null. Null. Default. Export default. 2. Default. Null. Null. Default. Export. X. X. Null. Null. X. Export. Vias X. X. Null. Null. V. Export. X. From mod X. Mod X. Null. Export. Vias X. From mod X. Mod V. Null. Export from mod null. Mod all but default. Null. Export as NS. From mod NS. Mod all. Null. The following definitions specify the required concrete methods and other abstract operations for source text module records. ECMA International 2024 387 16 2 1 6 1 parse module. Source text. Realm. Host defined. The abstract operation parse module takes arguments source text, ECMAScript source text, realm, a realm record, and host defined anything and returns a source text module record or a non-empty list of syntax error objects. It creates a source text module record based upon the result of parsing source text as a module. It performs the following steps when called. Let body be parse text, source text, module. If body is a list of errors, return body. Let requested modules be the module requests of body. Let import entries be import entries of body. Let imported bound names be imported local names. Import entries. Let indirect export entries be a new empty list. Let local export entries be a new empty list. Let star export entries be a new empty list. Let export entries be export entries of body. 0. For each export entry, record EE of export entries. Do. If EE is null, then if imported bound names does not contain EE, then 1. Append EE to local export entries. 2. Else, let IE be the element of import entries whose is EE. If IE is namespace object, then a note. This is a re-export of an imported module namespace object. Be append EE to local export entries. Else, a note. This is a re-export of a single name. Be append the export entry record, i.e.
Now, I don't know what I want to do next. There's like, everything's like, really complicated.
Realm, empty, empty, cycle root, empty,
I don't want to waste time opening chatbot to like output a script or code to compile to then use, because that's just
star export.
It'll just be a distraction. So I'm gonna just go through all the files one by one and then tag them with a define card check at the top to throw a message if the file hasn't been updated to 64-bit.
It performs the following steps when called.
Then I'll just work through whatever files that pop up is needing to be updated on the go each time.
Text and analyze it.
I've already explained this before. There's a bunch of other tiny little tweaks I want to do.
The point where this specific
to like to trace through what's being used where, so I can internally change the structure of the program later, but that can wait.
Star set.
I need to just get it running first as 64-bit, and all that's left is
the direct binding for this export.
Getting the 32-bit addressing to 64-bit addressing. So I'm gonna do that first. Whisper. Oh, sucks.
Export entry record of module. Do assert it is not null. Be let record. Get exported names. Export star set D for.
I have to make a single JavaScript file to include in every HTML file that will
Return exported names. 6. 2.
so I can
Resolve export.
like
Resolve set. The resolve module record module takes argument export name, a string,
I think I need to make 2 files.
a list of records with fields, a module,
One where I define a 64-bit or 32-bit, like the build mode to pick,
resolve
like a toggle.
binding to the actual
And the other one I'll include that script after
module may be the module represented by the module,
the script before it.
the mother module that is imported by that module.
And then that second file that I put in all the
Export paths. If a
every single JavaScript file,
that is already in resolve set, an import circularity.
I'll finish my sentences when I want to finish my sentences.
And export name is added to resolve set.
And yeah.
Is returned.
But then I can set that, and then for each file I can check if I updated that file to 64-bit or not. So I have to determine how to systematically go through and tag all these HTML files and JavaScript files. So I'm going to do
Resolve set to a new empty list for each record. Are the same module record.
I'll just put like a comment at the very top of every single file I use.
2. Return.
And then I'll put like a dash HTML JavaScript c.h, whatever file type it is.
Export name.
I'll do that first. So every single file will be tagged.
Export. 2.
And then I can sift through and sort out
Of module. Do if same value.
what control flow to use for each specific type of file.
Throw an exception for name.
Because there's different syntaxes, different rules, and different whatever. That's what I'm doing now.
Module.
I'm not even gonna make a to-do note. I'm just gonna do it. Go through every fucking file and tag it.
Imported.
I'm not gonna waste my time making a program to do this, because it'll take the same amount of time to make a program as it would to like just do it.
Export name. Default.
And some of these files are pretty big. And I could use Python, but I hate Python. As bugs, I don't know, whatever.
Import from mod declaration.
I don't want to like run a program, have it resave the file, tag the file, and then it doesn't like output the whole file because the file was too long and there was like a limit. I don't know, I'm not gonna deal. Any issues I want to be caused because I made a mistake, not because I ran a program and it messed up.
Solution is null. Then set stop.
So I'm gonna make a couple comments or whatever, and then so it'll take a bit. Open every single file and tag them. I'll do that right now. This sucks.
Star resolution is namespace. Return ambiguous. If resolution is a string, star resolution is a string, and same value. Resolution star resolution is false. Return ambiguous 0. Return star resolution 6 2 1 6 4. Initialize environment. The initialize environment concrete method of a source text module record module takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. For each export entry recordee of module. Do A assert I is not null. B let resolution be module resolve export. See if resolution is either null or ambiguous. Throw a syntax error exception. D assert Resolution is a resolved binding record. Assert. All named exports from module are resolvable. Let realm be module. Assert. Realm is not undefined. Let env be new module environment. Realm. Set module to env. For each import entry recording of module. Do a let imported module be get imported module. Module. In be if in is namespace object. Then I let namespace be get module namespace. Imported module 2. Perform env create immutable binding. In true 3. Perform env initialize binding. In namespace see else 90 ECMA International 2024 I2. Let resolution be imported module resolve export. In if resolution is either null or ambiguous, throw a syntax error exception. 3. If resolution is namespace, then let namespace be get module namespace. Resolution perform env create immutable binding. In true perform env initialize binding. In namespace I've else perform env create import binding. In resolution let module context be a new ECMAScript code execution context. Set the function of module context to null. 0. Assert module is not undefined. 1. Set the realm of module context to module. 2. Set the script or module of module context to module. 3. Set the variable environment of module context to module. 4. Set the lexical environment of module context to module. 5. Set the private environment of module context to null. 6. Set module to module context. 7. Push module context onto the execution context stack. Module context is now the running execution context. 8. Let code be module. 9. Let var declarations be the var scope declarations of code. 0. Let declared var names be a new empty list. 1. For each element d of var declarations, do a for each element dn of the bound names of d. Do I have declared var names does not contain dn, then perform env create mutable binding. Dn false. Perform env initialize binding. Dn undefined. Append dn to declared var names. 2. Let lex declarations be the lexically scoped declarations of code. 3. Let private env be null. 4. For each element d of lex declarations, do a for each element dn of the bound names of d. Do if is constant declaration of d is true, then perform env create immutable binding. Dn true 2. Else perform env create mutable binding. Dn false. 3. If d is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then let fo be instantiate function object of d with arguments env and private env. Perform env initialize binding. Dn fo. 5. Remove module context from the execution context stack. 6. Return unused. 6. 2. 1. 6. 5. Execute module capability. The execute module concrete method of a source text module record module takes optional argument capability, a promise capability record, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let module context be a new ECMAScript code execution context. Set the function of module context to null. Set the realm of module context to module. Set the script or module of module context to module. Assert module has been linked and declarations in its module environment have been instantiated. Set the variable environment of module context to module. Set the lexical environment of module context to module. Suspend the running execution context. If a module is false, then A assert capability is not present. B push module context onto the execution context stack. Module context is now the running execution context. C let result be completion. Evaluation of module ECMA International 2024 391. Desuspend module context and remove it from the execution context stack. E resume the context that is now on the top of the execution context stack as the running execution context. F if result is an abrupt completion, then I return result 10. Else A assert capability is a promise capability record. B perform a sync block start. Capability module context 1. Return unused. 6. 2. 1. 7 get imported module referrer. Specifier. The abstract operation getImported module takes arguments referrer, a cyclic module record, and specifier, a string, and returns a module record. It performs the following steps when called. Assert. Exactly one element of referrer is a record whose is specifier, since load requested modules has completed successfully on referrer prior to invoking this abstract operation. Let record be the record in referrer whose is specifier. Return record. 6, 2, 1. 8 host load imported module. Referrer. Specifier. Host defined. Payload. The host defined abstract operation host load imported module takes arguments referrer, a script record, a cyclic module record, or a realm record. Specifier, a string, host defined anything, and payload. A graph loading state record or a promise capability record, and returns unused. Note an example of when referrer can be a realm record is in a web browser host. There, if a user clicks on a control given by button type equals button on click equals import, foo mjs, click me, button, there will be no active script or module at the time the import expression runs. More generally, this can happen in any situation where the host pushes execution contexts with null script or module components onto the execution context stack. An implementation of host load imported module must conform to the following requirements. The host environment must perform finished loading imported module, referrer, specifier, payload, result, where result is either a normal completion containing the loaded module record or a throw completion, either synchronously or asynchronously. If this operation is called multiple times with the same referrer, specifier, pair and it performs finish.
So I don't know. I got these whatever. I'm gonna go through every single file. I think there's like
Loading imported module, referrer,
there's only 393 files. I think I took notes out.
Pick value to be passed through to
Some notes files. And I might have to put them back because it might be part of the code, but I'll do that later. For now, there's 393 files. So I'm gonna like
to the same module record instance.
go through and tag each of them. I have no idea how long this will take.
Copyright sign
There's like 4 here, whatever.
16219 finished loading import.
Only the HTML files really have a different form of syntax
Module
or syntax, however pronunciate, whatever.
payload, a graph loading state record or a promise capability record, and result. Either a normal completion containing a module record or a throw completion, and returns unused. It performs the following steps when called. If result is a normal completion, then if referrer contains a record whose is specifier, then I assert.
I'm tagging them with a really long name to decrease the odds of like accidentally naming something with the same name. So I got these, whatever.
Else, perform continue dynamic import, payload, result, return unused,
Whatever the full name is. Yeah.
module, the abstract operation get module,
Goes there, whatever.
module, an instance of a concrete
Get all the HTML files
turns a module namespace object or empty,
and JavaScript files
namespace object rep,
and C files.
lazily creating it the first time it was requested, and storing that in module for
And the CPP for C++.
steps when called.
I might as well just, never mind, I'll just make it a C, doesn't matter.
Let namespace be module if namespace
And then all the header files.
module get
And once all 300 whatever files are done,
C for each element.
I can go through again,
I let resolution be module resolve export. Name 2
search for all the HTML files,
to unambiguous names. Set namespace to module namespace create. Module unambiguous names, return namespace,
and then put in whatever specific syntax, whatever it needs for it to have a define guard and checks
list. Let result
for each of these afterwards.
result is a normal
And I'm not gonna go through like 3 or 4 times, so
module item
I'm gonna have to like go back and forth and whatever files are in the folder, top to bottom. Let's just do this now and stop complaining.
rows. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. ECMA International 2024 393. Note the value of a module item list is the value of the last value producing item in the module item list. Module item. Import declaration. Return empty 16. 2. Import syntax. Import declaration. Import clause from clause. Import module specifier. Import clause. Imported default binding. Namespace import. Named imports. Imported default binding. Namespace import. Imported default binding. Named imports. Imported default binding. Imported binding. Namespace import. As imported binding. Named imports. Imports list. Imports list. From clause. From module specifier. Imports list. Import specifier. Imports list. Import specifier. Import specifier. Imported binding. Module export name is imported binding module specifier. String literal imported binding. Binding identifier. Yield. Plus await. 16. 2. 1 static semantics. Early errors. Module item. Import declaration. It is a syntax error if the bound names of import declaration contains any duplicate entries. 94. Copyright sign. ECMA International 2024 16. 2 static semantics. Import entries. The syntax-directed operation import entries takes no arguments and returns a list of import entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let entries 1 be import entries of module item list. Let entries 2 be import entries of module item. Return the list concatenation of entries 1 and entries 2. Module item. Export declaration. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Let module be the sole element of module requests of from clause. Return import entries for module of import clause with argument module. Import declaration. Import module specifier. 1. Return a new empty list. 6. 2. 3 static semantics. Import entries for module. The syntax-directed operation import entries for module takes argument module, a string, and returns a list of import entry records. It is defined piecewise over the following productions. Import clause. Imported default binding. Namespace import. Let entries 1 be import entries for module of imported default binding with argument module. Let entries 2 be import entries for module of namespace import with argument module. Return the list concatenation of entries 1 and entries 2. Import clause. Imported default binding. Named imports. Let entries 1 be import entries for module of imported default binding with argument module. Let entries 2 be import entries for module of named imports with argument module. Return the list concatenation of entries 1 and entries 2. Imported default binding. Imported binding. Let local name be the sole element of bound names of imported binding. Let default entry be the import entry record. Module. Default. Local name. Local name. Return default entry. Namespace import. As imported binding. Let local name be the string value of imported binding. Let entry be the import entry record. Module. Namespace object. Local name. Local name. Return entry. ECMA International 2024 395. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let specs 1 be the import entries for module of imports list with argument module. Let specs 2 be the import entries for module of import specifier with argument module. Return the list concatenation of specs 1 and specs 2. Import specifier. Imported binding. Let local name be the sole element of bound names of imported binding. Let entry be the import entry record. Module. Local name. Local name. Local name. Return entry. Import specifier. Module export name as imported binding. Let import name be the string value of module export name. Let local name be the string value of imported binding. Let entry be the import entry record. Module. Import name. Local name. Local name. Return entry. 6, 2, 3. Export syntax. Export declaration. Export from clause from.
Oh my god, there's so many files. I'll be back. This sucks. This is gonna take forever.
Plus await. Plus default. Export
Oh man, this sucks.
default. Look ahead. Function. Async. No line terminator here. Function. Class. Assignment expression. Plus in. Yield. Plus await. Export from clause as module export name named exports. Named exports. Exports list. Exports list. Exports list. Export specifier. Exports list. Export specifier. Export specifier. Module export name. 96. ECMA International 2024. Module export name as module export name. 1623. 1 static semantics. Early errors. Export declaration. Export named exports. It is a syntax error if reference bindings of named exports contains any string literals. For each identifier name n in referenced bindings of named exports, it is a syntax error if string value of n is a reserved word or the string value of n is one of implements. Interface. Let. Package. Private. Protected. Public. Or static. 6, 2, 3, 2 static semantics. Exported bindings. The syntax-directed operation exported bindings takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list. Module item list module item. Let names 1 be exported bindings of module item list. Let names 2 be exported bindings of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. 1. Return a new empty list. Export declaration. Export named exports. Return the exported bindings of named exports. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoister. Bled declaration. Export default class declaration. Export default assignment expression. Return the bound names of this export declaration. Note the above rule means that each reference bindings of named exports is treated as an identifier reference. Note exported bindings are the locally bound names that are explicitly associated with the module's exported names. ECMA International 2024 397. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. Let names 1 be the exported bindings of exports list. Let names 2 be the exported bindings of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the first module export name. 6, 2, 3. 3 static semantics. Exported names. The syntax-directed operation exported names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list. Module item list module item. Let names 1 be exported names of module item list. Let names 2 be exported names of module item. Return the list concatenation of names 1 and names 2. Module item. Export declaration. Return the exported names of export declaration. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Return the exported names of export from clause. Export from clause. Return a new empty list. Export from clause. As module export name. Return a list whose sole element is the string value of module export name. Export from clause. Named exports. Return the exported names of named exports. 398. ECMA International 2024. Note exported names are the externally visible names that a module explicitly maps to one of its local name bindings. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return default. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. Let names 1 be the exported names of exports list. Let names 2 be the exported names of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the second module export name. 6, 2, 3, 4 static semantics. Export entries. The syntax-directed operation export entries takes no arguments and returns a list of export entry records. It is defined piecewise over are the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let entries 1 be export entries of module item list. Let entries 2 be export entries of module item. Return the list concatenation of entries 1 and entries 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Let module be the sole element of module requests of from clause. Return export entries for module of export from clause with argument module. ECMA International 2024 399. Export declaration. Export named exports. Return export entries for module of named exports with argument null. Export declaration. Export variable statement. Let entries be a new empty list. Let names be the bound names of variable statement. For each element name of names, do a append the export entry record. Null. Name. To entries. Return entries. Export declaration. Export declaration. Let entries be a new empty list. Let names be the bound names of declaration. For each element name of names, do a append the export entry record. Null. Name. To entries. Return entries. Export declaration. Export default hoistable declaration. Let names be bound names of hoistable declaration. Let local name be the sole element of names. Return a list whose sole element is a new export entry record. Null. Local name. Default. Export declaration. Export default class declaration. Let names be bound names of class declaration. Let local name be the sole element of names. Return a list whose sole element is a new export entry record. Null. Local name. Default. Export declaration. Export default assignment expression. Let entry be the export entry record. Null. Default. Return entry. 6, 2, 3, 5 static semantics. Export entries for module. The syntax-directed operation export entries for module takes argument module, a string or null, and returns a list of export entry records. It is defined piecewise over the following productions. Export from clause. 1, 2. Let entry be the export entry record. Module. All but default. Null. Return entry. 00. ECMA International 2024. Note default is used within this specification as a synthetic name for anonymous default export values. See this note for more details. Export from clause. As module export name. Let export name be the string value of module export name. Let entry be the export entry record. Module. All. Null. Export name. Return entry. Named exports. Return a new empty list. Exports list. Export specifier. Let specs 1 be the export entries for module of exports list with argument module. Let specs 2 be the export entries for module of export specifier with argument module. Return the list concatenation of specs 1 and specs 2. Export specifier. Module export name. Let source name be the string value of module export name. If a module is null, Then, a let local name be source name. B let import name be null. Else, a let local name be null. B let import name be source name. Return a list whose sole element is a new export entry record. Module, import name, local name, source name, export specifier, module export name as module export name. Let source name be the string value of the first module export name. Let export name be the string value of the second module export name. If a module is null, then, a let local name be source name. B let import name be null. Else, a let local name be null. B let import name be source name. Return a list whose sole element is a new export entry record. Module, import name, local name, export name. 6, 2, 3, 6 static semantics. Referenced bindings. The syntax-directed operation reference bindings takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. Let names 1 be the referenced bindings of exports list. Let names 2 be the referenced bindings of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name as module export name. Return the reference bindings of the first module export name. ECMA International 2024 401. Module export name. Identifier name. Return a list whose sole element is the identifier name. Module export name. String literal. Return a list whose sole element is the string literal. 6, 2, 3, 7 runtime semantics. Evaluate.
Okay, I'm ready. I'm gonna lock in and tag 393 files with a comment at the top so I can go through again later and tag all those again with a more specific defined card check. Well, that'll be easier. I'm not going to talk. I'm just going to do this file by file. Starting with file number 1. Oh man, this sucks.
C L A S S capital D E C L A R A T I O N capital E V A L U A T of class declaration. Let class name be the sole element of bound names of class declaration. If class name is default, then let env be the running execution context's lexical environment. B perform. Initialize bound name, default, val ue, env, return empty, export declaration, export default assignment expression. If is anonymous function definition, assignment expression, is true, then let value be. Named evaluation of assignment expression with argument default. Else, let RHS be. Evaluation of assignment expression.
Okay, it might not be that bad. I can probably open like 10 files and then click on them all up here in the tab. No, this still sucks. That doesn't make it any of this any easier. So, here we go. Again. Oh man, this freaking take an hour or two.
Of any construct in the script containing the error. The presence of an early error prevents the evaluation of the construct. An implementation must report early errors in a script as part of parsing that script in parse script. Early errors in a module are reported at the point when the module would be evaluated and the module is never initialized. Early errors in 02, copyright sign, ECMA International 2024, eval code are reported at the time eval is called and prevent evaluation of the eval code. All errors that are not early errors are runtime errors. An implementation must report as an early error any occurrence of a condition that is listed in a static semantics, early errors subclause of this specification. An implementation shall not treat other kinds of errors as early errors even if the compiler can prove that a construct cannot execute without error under any circumstances. An implementation may issue an early warning in such a case, but it should not report the error until the relevant construct is actually executed. An implementation shall report all errors as specified, except for the following. Except as restricted in 17.1, a host or implementation may extend script syntax, module syntax, and regular expression pattern or flag syntax. To permit this, all operations, such as calling eval, using a regular expression literal, or using the function or regexp constructor, that are allowed to throw syntax error are permitted to exhibit host defined behavior instead of throwing syntax error when they encounter a host-defined extension to the script syntax or regular expression pattern or flag syntax. Except as restricted in 17.1, a host or implementation may provide additional types, values, objects, properties, and functions beyond those described in this specification. This may cause constructs, such as looking up a variable in the global scope, to have host-defined behavior instead of throwing an error, such as reference error. 7.1 Forbidden extensions. An implementation must not extend this specification in the following ways. ECMAScript function objects defined using syntactic constructors in strict mode code must not be created with own properties named caller or arguments. Such own properties also must not be created for function objects defined using an arrow function, method definition, generator declaration, generator expression, async generator declaration, async generator expression, class declaration, class expression, async function declaration, async function expression, or async arrow function regardless of whether the definition is contained in strict mode code. Built-in functions, strict functions created using the function constructor, generator functions created using the generator constructor, async functions created using the async function constructor, and functions created using the bind method also must not be created with such own properties. If an implementation extends any function object with a known property named caller, the value of that property, as observed using, must not be a strict function object. If it is an accessor property, the function that is the value of the properties. Neither mapped nor unmapped arguments objects may be created with a known property named caller. The behavior of built-in methods which are specified in ECMA 402, such as those named to locale string, must not be extended except as specified in ECMA 402. The regexp pattern grammars in 2.2, 1 and b 1.2 must not be extended to recognize any of the source characters at Z or raise Z as identity escape, plus Unicode mode, when the Unicode mode grammar parameter is present. The syntactic grammar must not be extended in any manner that allows the token to immediately follow source text that is matched by the binding identifier non-terminal symbol. When processing strict mode code, an implementation must not relax the early error rules of 1.2.9. 3.1. Template escape sequence must not be extended to include legacy octal escape sequence or non-octal decimal escape sequence as defined in 1.2.9. 4. When processing strict mode code, the extensions defined in B 3.1, B 3.2, B 3.3, and B 3.5 must not be supported. When parsing for the module goal symbol, the lexical grammar extensions defined in B 1.1 must not be supported. Import call must not be extended. ECMA International 2024 403. 18 ECMAScript standard built-in objects. There are certain built-in objects available whenever an ECMAScript script or module begins execution. 1. The global object is part of the global environment of the executing program. Others are accessible as initial properties of the global object or indirectly as properties of accessible built-in objects. Unless specified otherwise, a built-in object that is callable as a function is a built-in function object with the characteristics described in 10.3. Unless specified otherwise, the internal slot of a built-in object initially has the value true. Every built-in function object has an internal slot whose value is the realm record of the realm for which the object was initially created. Many built-in objects are functions. They can be invoked with arguments. Some of them furthermore are constructors. They are functions intended for use with the new operator. For each built-in function, the specification describes the arguments required by that function and the properties of that function object. For each built-in constructor, This specification furthermore describes properties of the prototype object of that constructor and properties of specific object instances returned by a new expression that invokes that constructor, unless otherwise specified in the description of a particular function. If a built-in function or constructor is given fewer arguments than the function is specified to require, the function or constructor shall behave exactly as if it had been given sufficient additional arguments, each such argument being the undefined value. Such missing arguments are considered to be not present and may be identified in that manner by specification algorithms. In the description of a particular function, the terms this value and new target have the meanings given in 10.3, unless otherwise specified in the description of a particular function. If a built-in function or constructor described is given more arguments than the function is specified to allow, the extra arguments are evaluated by the calling, then ignored by the function. However, an implementation may define implementation-specific behavior relating to such arguments as long as the behavior is not the throwing of a type error exception that is predicated simply on the presence of an extra argument. Unless otherwise specified, every built-in function and every built-in constructor has the function prototype object, which is the initial value of the expression function prototype, 2023, as the value of its internal slot. Unless otherwise specified, every built-in prototype object has the object prototype object, which is the initial value of the expression object prototype, 2013, as the value of its internal slot, except the object prototype object itself. If this specification defines a built-in constructor's behavior via algorithm steps, then that is its behavior for the purposes of both and. If such an algorithm needs to distinguish the two cases, it checks whether new target is undefined, which indicates an invocation. Built-in function objects that are not identified as constructors do not implement the internal method unless otherwise specified.
I need to set some shortcuts to AutoHotkey to go like left, right between tabs, because
Each built-in function.
I'm not gonna hit Control Shift Tab and then Control Tab to navigate between tabs. That takes way too long to hit. That's not even a shortcut. That's like 2 keys to get a hit. I'm gonna do like F14 and F15. This is a good distraction. I don't know, I'm gonna set up these hotkeys and I can like toggle between these tabs quicker. This sucks.
Note 1: implementations that add additional capabilities to the set of built-in functions are encouraged to do so by adding new functions rather than adding new parameters to existing functions. 04 Copyright sign, ECMA International 2024. Note 2: for example, the function object that is the initial value of the map property of the array prototype object is described under the subclause heading array prototype map. Callback fn, this arg, which shows the two named arguments callback fn in this arg, the latter being optional. Therefore the value of the length property of that function object is 1, unless otherwise specified. The length property of a built-in function object has the attributes false, false, true. Every built-in function object, including constructors, has a name property whose value is a string. Unless otherwise specified, this value is the name that is given to the function in this specification. Functions that are identified as anonymous functions use the empty string as the value of the name property. For functions that are specified as properties of objects, the name value is the property name string used to access the function. Functions that are specified as get or set access functions of built-in properties of get or set, respectively, passed to the prefix parameter when calling create built-in function. The value of the name property is explicitly specified for each built-in functions whose property key is a symbol value. If such an explicitly specified value starts with the prefix get or set in the function for which it is specified as a get or set access a function of a built-in property, the value without the prefix is passed to the name parameter, and the value get or set, respectively, is passed to the prefix parameter when calling create built-in function. Unless otherwise specified, the name property of a built-in function object has the attributes false, false, true. Every other data property described in clauses 19 through 28 and in Annex B 2 has the attributes true, false, true unless otherwise specified. Every accessor property described in clauses 19 through 28 and in Annex B. 2 has the attributes false, true unless otherwise specified. If only a getAccessor function is described, the setAccessor function is the default value, undefined. If only a setAccessor is described, the getAccessor is the default value, undefined. 9. The global object. The global object is created before control enters any execution context. Does not have an internal method. It cannot be used as a constructor with the new operator. Does not have an internal method. It cannot be invoked as a function. Has an internal slot whose value is host-defined. May have host-defined properties in addition to the properties defined in this specification. This may include a property whose value is the global object itself. 9.1 Value properties of the global object. 1 global this. The initial value of the global this property of the global object in a realm record realm is realm. This property has the attributes true, false, true 1 2 infinity. The value of infinity is plus C6 1 6 1. This property has the attributes false, false, false. ECMA International 2024 405 3 nan. The value of nan is nan C6 1 6 1. This property has the attributes false, false. Configurable false 1 4 undefined. The value of undefined is undefined C6 1 1. This property has the attributes false, false, false. 9.2 Function properties of the global object. 2 1 eval x. This function is the %eval %intrinsic object. It performs the following steps when called. Return. Perform eval x. False. False 1 2 1 Perform eval x. Strict caller. Direct. The abstract operation perform eval takes arguments x, an ECMAScript language value, strict caller, a boolean, and direct a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. If direct is false, then strict caller is also false. If x is not a string, return x. Let eval realm be the current realm record. Note. In the case of a direct eval, eval realm is the realm of both the caller of eval and of the eval function itself. Perform. Host ensure can compile strings, eval realm, x, direct. Let in function be false. Let in method be false. Let in derived constructor be false. Let in class field initializer be false. 0. If direct is true, then a let this envrec be get this environment. B if this envrec is a function environment record. Then, I let f be the envrec. 2. Set in function to true. 3. Set in method to the envrec as superbinding. 5. If f is derived, set in derived constructor to true. V let class field initializer name be f. V. If class field initializer name is not empty, set in class field initializer to true. 1. Perform the following substeps in an implementation defined order, possibly until leaving parse. And error detection. A let script be parse text. String to code points. X. Script. B if script is a list of errors. Throw a syntax error exception. C if script contains script body is false. Return undefined. D let body be the script body of script. E if in function is false and body contains new target. Throw a syntax error exception. F if in method is false and body contains super property. Throw a syntax error exception. G if in derived constructor is false and body contains supercall. Throw a syntax error exception. H if in class field initializer is true and contains arguments of body is true. Throw a syntax error exception. 2. If strict caller is true, let strict eval be true. 3. Else, let strict eval be as strict of script. 4. Running context be the running execution context. 06. ECMA International 2024 15. Note. If direct is true, running context will be the execution context that performed the direct eval. If direct is false,
This shortcut, they don't even work. Like if I'm on this tab and I go to the right tab, it goes to the right. But if I go left, it like loops back between these two tabs. So it's just previous and previous. Is there even, yeah, this, I can't go left with the tabs. It just goes back and forth between two, but I can't go to the right. I think, yes, it looks like it doesn't always pick the one to the right. It just kinda, like when it hits the last thing to the right, it kinda just picks whatever it wants to pick next, and then it skips. This doesn't fucking work. It kind of works. I'm just gonna go with it. I'm gonna shut up and go with it. This is good enough.
To LexEnv 6. Set eval contexts private environment to private env 7. Push eval context onto the execution context stack. Eval context is now the running execution context. 8. Let result be completion. Eval declaration instantiation. Body. var env. LexEnv. Private env. Strict eval. 9. If result is a normal completion, then a set result to completion. Evaluation of body. 0. If result is a normal completion and result is empty, then a set result to normal completion. Undefined. 1. Suspend eval context and remove it from the execution context stack. 2. Resume the context that is now on the top of the execution context stack as the running execution context. 3. Return result. 9. 2. 1. To host ensure can compile strings, Corley realm, parameter strings, body string, direct. The host-defined abstract operation host ensure can compile strings takes arguments Corley realm, a realm record, parameter strings, a list of strings, body string, a string, and direct a boolean, and returns either a normal completion containing unused or a throw completion. It allows host environments to block certain ECMAScript functions. We allow developers to interpret and evaluate strings as ECMAScript code. Parameter strings represents the strings that, when using one of the function constructors, will be concatenated together to build the parameters list. Body string represents the function body or the string passed to an eval call. Direct signifies whether the evaluation is a direct eval. The default implementation of host ensure can compile strings is to return normal completion, unused 1 9, 2, 1, 3. Eval declaration instantiation, body, var env, LexEnv, private env, strict. The abstract operation eval declaration instantiation takes arguments body a script body parse node, var env, an environment record, LexEnv, a declarative environment record, private env, a private environment record or null, and strict, a boolean, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let var.
This is fucking ridiculous. Something as simple as selecting the next tab, it should just work. Like, what the fuck is this? I can't even. The fuck? God damn it. I want, like, something to make my life a little bit easier. Just a teeny bit easier. But no. No, nothing. Nothing is easy. It's ridiculous. This is a tab, right? I'm gonna go to the next tab using the official Sublime Text shortcut. This program is written in Python and shit. It's shit. So, like, next tab. Oh, it missed a tab. Let's go to the next tab. Oh, what's it even doing? Is Windows screwing it up? Okay, I'm gonna try this again. Here we go. So I'm on this tab. And I want to go to the next tab. Could this thing just stay in place? Okay, can you see how it's it's skipping over just random. It doesn't fucking work. It's not going tab by tab. It's just going whatever the fucking tab it wants to go by. So I'm gonna have to just click 359 times. I'll have to like hover the mouse, put in that little bit of effort to like click a tab, and then click back on the window, hit enter, paste. Oh, that's a lot more effort than it should be. Anyways, that's where I'm at right now. This is ridiculous. I'm out of things to crack, so I'm whatever.
The last declaration is used. 3. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then if var_env is a global environment record, then a let fn definable be var_env can declare global function fn. B if fn definable is false, throw a type error exception. Append fn to declared function names. Insert D as the first element of functions to initialize. 1. Let declared var names be a new empty list. 2. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier. Then, for each string vn of the bound names of D, do if declared function names does not contain vn, then if var_env is a global environment record, then I let vn definable be var_env can declare global var vn. 2. If a vn definable is false, throw a type error exception. B if declared var names does not contain vn, then I append vn to declared var names. 3. Note, annex B 3 2 3 adds additional steps at this point. 4. Note, no abnormal terminations occur after this algorithm step unless var_env is a global environment record and the global object is a proxy exotic object. 5. Let lex declarations be the lexically scoped declarations of body. 6. For each element D of lex declarations, do a note. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of D, do if this constant declaration of D is true, then perform lexenv create immutable binding. Dn true 2. Else perform lexenv create mutable binding. Dn false. 7. For each parse node f of functions to initialize, do 408. ECMA International 2024. A let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexenv and private env. C if var_env is a global environment record, then I perform var_env create global function binding fn fo true. D else I let binding exists be var_env has binding fn. 2. If binding exists as false, then note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var_env create mutable binding fn true. Perform var_env initialize binding fn fo. 3. Else perform var_env set mutable binding fn fo false. 18. For each string vn of declared var names, do if var_env is a global environment record, then I perform var_env create global var binding vn true. B else I let binding exists be var_env has binding vn. 2. If binding exists as false, then note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var_env create mutable binding vn true. Perform var_env initialize binding vn undefined. 9. Return unused. Note, an alternative version of this algorithm is described in B 3.4.9. 2. 2 is finite number. This function is the is finite intrinsic object. It performs the following steps when called. Let num be to number. If num is not finite, return false. Otherwise, return true. 9. 2. 3 is nan number. This function is the %is nan % intrinsic object. It performs the following steps when called. Let num be to number. If num is nan, return true. Otherwise, return false. 9, 2, 4 parse float. String. This function produces a number value dictated by interpretation of the contents of the string argument as a decimal literal. It is the %parse float % intrinsic object. A reliable way for ECMAScript code to test if a value x is none is an expression of the form. Note, x equals x. The result will be true if and only if x is none. ECMA International 2024 409. It performs the following steps when called. Let input string be to string. Let trimmed string be trim string. Input string start. Let trimmed be string to code points. Trimmed string. Let trimmed prefix be the longest prefix of trimmed that satisfies the syntax of a str decimal literal, which might be trimmed itself. If there is no such prefix, return nan. Let parsed number be parsed text. Trimmed prefix str decimal literal. Assert parsed number as a parse node. Return string numeric value of parsed number. 9, 2, 5 parse int string radix. This function produces an integral number dictated by interpretation of the contents of string according to the specified radix. A leading white space in string is ignored. If radix coerces to 0, such as when it is undefined, it is assumed to be 10 except when the number representation begins with 0x or 0x, in which case it is assumed to be 16. If radix is 16, the number representation may optionally begin with 0x or 0x. It is the %parse int % intrinsic object. It performs the following steps when called. Let input string be to string. Let s be trim string. Input string start. Let sign be 1. If s is not empty and the first code unit of s is the code unit 0 times 002d, hyphen minus, set sign to -1. If s is not empty and the first code unit of s is either the code unit 0 times 002b plus sign, or the code unit 0 times 002d, hyphen minus, set s to the substring of s from index 1. Let r be r to int 32. Radix. Let strip prefix be true. If r0, then if r2 or r36, return nan. B if r16, set strip prefix to false. Else, a set r to 10, 0. If strip prefix is true, then if the length of s is at least 2 and the first two code units of s are either 0x or 0x, then I set s to the substring of s from index 2, 2. Set r to 16. If s contains a code unit that is not a radix r digit, let n be the index within s of the first such code unit. Otherwise, let n be the length of s. 2. Let z be the substring of s from 0 to end. 3. If z is empty, return nan. 4. Let math int be the integer value that is represented by z in radix r notation, using the letters a through z, and a through z for digits with values 10 through 35. However, if r equals 10 and z contains more than 20 significant digits, every significant digit after the 20th of may be replaced by a 0 digit, at the option of the implementation. And if r is not one of 2, 4, 8, 10, 16, or 32, then math int may be an implementation approximated integer representing the integer value denoted by z in radix r notation. 5. If math int equals 0, then a if sign equals -1, return -0, b return +0. 6. Return sign math int. Note this function may interpret only a leading portion of string as a number value. It ignores any code units that cannot be interpreted as part of the notation of a decimal literal, and no indication is given that any such code units were ignored. 10. ECMA International 2024. Note this function may interpret only a leading portion of string as an integer value. It ignores any code units that cannot be interpreted as part of the notation of an integer, and no indication is given that any such code units were ignored. 9. 2. 6 URI handling functions. Uniform resource identifiers, or URIs, are strings that identify resources, for example web pages or files, and transport protocols by which to access them, for example HTTP or FTP, on the internet. The ECMAScript language itself does not provide any support for using URIs except for functions that encode and decode URIs as described in this section. Encode URI and decode URI are intended to work with complete URIs. They assume that any reserved characters are intended to have special meaning, for example, as delimiters, and so are not encoded. Encode URI component and decode URI component are intended to work with the individual components of a URI. They assume that any reserved characters represent text and must be encoded to avoid special meaning when the component is part of a complete URI. 9, 2, 6, 1 decode URI, encoded URI. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI function is replaced with the UTF-16 encoding of the code points that it represents. Escape sequences that could not have been introduced by encode URI are not replaced. It is the %decode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, encoded URI. Let preserve escape set be. At and equals plus $, return. Decode, URI string, preserve escape set. 9, 2, 6, 2 decode URI component. Encoded URI component. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI component F function is replaced with the UTF-16 encoding of the code points that it represents. It is the %decode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, encoded URI component. Let preserve escape set be the empty string. Return. Decode. Component string. Preserve escape set. Note 1. The set of reserved characters is based upon RFC 2396 and does not reflect changes introduced by the more recent RFC 3986. Note 2. Many implementations of ECMAScript provide additional functions and methods that manipulate web pages. These functions are beyond the scope of this standard. ECMA International 2024 411 1926 3 encode URI. URI. This function computes a new version of a UTF-16 encoded 6, 1, 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, URI. Let extra unescape be. At and equals plus $, return. Encode, URI string, extra unescaped. 9, 2, 6, 4 encode URI component. URI component. This function computes a new version of a UTF-16 encoded 6, 1, 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, URI component. Let extra unescape be the empty string. Return. Encode. Component string. Extra unescaped. 9, 2, 6, 5 encode. String. Extra unescaped. The abstract operation encode takes argument string, a string, and extra unescaped, a string, and returns either a normal completion containing a string or a throw completion. It performs URI encoding and escaping, interpreting string as a sequence of UTF-16 encoded code points as described in 6, 1, 4. If a character is identified as unreserved in RFC 2396 or appears in extra unescaped, it is not escaped. It performs the following steps when called. Let len be the length of string. Let r be the empty string. Let always unescaped be the string concatenation of the ASCII word characters and art. Let unescaped set be the string concatenation of always unescaped and extra unescaped. Let 0 repeat. While k, len, let c be the code unit at index k within string. B if unescaped set contains c, then I set k to k plus 1, 2. Set r to the string concatenation of r and c. C else I let cp be code point at string k 2. If cp is true, throw a URI error exception. 3. Set k to k plus cp. I've Let octets be the list of octets resulting by applying the UTF-8 transformation to CP-V for each element octet of octets. Do return R. 2. Let hex be the string representation of octet, formatted as an uppercase hexadecimal number. Set R to the string concatenation of R, percent, and string pad, hex, 2, 0, start, 412, ECMA International 2024. Note, because percent encoding is used to represent individual octets, a single code point may be expressed as multiple consecutive escape sequences, one for each of its 8-bit UTF-8 code units. 1926 60 code string, preserve escape set. The abstract operation decode takes argument string, a string, and preserve escape set, a string, and returns either a normal completion containing a string or a throw completion. It performs URI unescaping and decoding, preserving any escape sequences that correspond to basic Latin characters in preserve escape set. It performs the following steps when called. Let len be the length of string. Let r be the empty string. Let 0 repeat. While k, len abc. Let c be the code unit at index k within string. Let s be e if c is the code unit 0 times 0025, %. Then if k plus 3, len, throw a URI error exception. 2. Let escape be the substring of string from k to k plus 3. 3. Let b be parse hex octet, string, k plus 1. If b is not an integer, throw a URI error exception. V set k to k plus 2. V. Let n be the number of leading 1 bits in b. 7. If n equals 0, then let a char be the code unit whose numeric value is b. If preserve escape set contains a char, set s to escape. Otherwise, set s to a char. 8. Else, if n equals 1 or n, 4. Throw a URI error exception. Let octets be b. Let j be 1. Repeat. While j, n, a set k to k plus 1, b if k plus 3, len. Throw a URI error exception. See if the code unit at index k within string is not the code unit 0 times 0025, %. Throw a URI error exception. D let continuation byte be parse hex octet, string, k plus 1. E if continuation byte is not an integer, throw a URI error exception. F append continuation byte to octets. G set k to k plus 2. H set j to j plus 1. Assert. The length of octets is n. If octets does not contain a valid UTF-8 encoding of a Unicode code point, throw a URI error exception. Let v be the code point obtained by applying the UTF-8 transformation to octets. That is, from a list of octets into a 21-bit value. Set s to UTF-16 encode code point. V. Set R to the string concatenation of R and S. D. E. Return R. Set K to K plus 1. Note RFC 3629 prohibits the decoding of invalid UTF-8 octet sequences. For example, the invalid sequence 0xC00 times 80 must not decode into the code unit 0 times 0000. Implementations of the decode algorithm are required to throw a URI error when encountering such invalid sequences. ECMA International 2024 413 1926 7 parse hex octet, string, position. The abstract operation parse hex octet takes argument string, a string, and position, a non-negative integer, and returns either a non-negative integer or a non-empty list of syntax error objects. It parses a sequence of 2 hexadecimal characters at the specified position in.
Okay, I'm gonna see how many I replaced so far.
When called, let len be the
I hope it's bigger than 50.
string from position to position plus 2. Let parse result be parse text. String to code points. Hex digits. Sep. If parse is not a parse node, return parse result. Let n be the MV of parse result. Assert. N is in the inclusive interval from 0 to 255. Return n. 9.3 Constructor properties of the global object 193.1 Aggregate error C20571193 2 array C2311993 3 array buffer C2514933 4 begint C2 1 2 1 9 3 5 begin 64 array C2 3 2 5 9 3 6 begin 64 array C2 3 2 5.
Okay, I'm actually kind of happy. That's 119 files. That didn't take as long as I thought it would. I have to take a break. I can't do this any longer. This is so boring. I'll be back.
Copyright sign, ECMA International 2024, the 19th of March 2010 error, C2051, the 9th of March 2011 eval error, C20551, the 9th of March 2012 finalization registry, C2621, the 9th of March 2013 float 32 array, C232. 5. The 9th of March 2014 float 64 array C23 2 5. The 9th of March 2015 function C20 2 1. The 9th of March 2016 int 8 array C23 2 5. The 9th of March 2017 int 16 array C23 2 5. The 9th of March 2018 int 32 array C23 2 5. The 9th of March 2019 map C24 1 1. The 9th of March 2020 number C21 1 1. The 9th of March 2021 object C20 1 1. The 9th of March 2022 promise C27 2 3. ECMA International 2024 15. The 19th of March 2023 proxy C28 2 1. The 9th of March 2024 range error C20 5 5 2. The 9th of March 2025 reference error C20 5 5 3. The 9th of March 2026 regexp C22 2 4. The 19th of March 2027 set C24 2 1. The 9th of March 2028 shared array buffer C25 2 3. The 9th of March 2029 string C22 1 1. The 9th of March 1930 symbol C20 4 1. The 9th of March 1931 syntax error C20 5 5 4. The 9th of March 1932 type error C20 5 5 5. The 9th of March 1933 int 8 array C23 2 5. The 9th of March 1934 runt 8 clamped array C23 2 5. The 9th of March 1935 int 16 array C23 2 5 16. Copyright sign, ECMA International 2024, the 19th of March 1936 int 32 array C23 2 5. The 9th of March 1937 URI error C20 5 5 6. The 9th of March 1938 week map C24 3 1. The 9th of March 1939 week ref C26 1 1. The 9th of March 1940 week set C24.4 9.4 other properties of the global object 9 4 1 atomics C25.4 19 4 2 JSON C25.5 19 4 3 math C21.3 19 4 4 reflect C28.1 0 fundamental objects 0.1 objects 0 1 1. The object constructor. The object constructor is %object% is the initial value of the object property of the global object, creates a new, ordinary object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. ECMA International 2024 417 20 1 1 1 object value. This function performs the following steps when called. Capital I, F new target is neither undefined nor the active function object. Then a return. Ordinary create from constructor. New target. %object prototype %. If value is either undefined or null, return ordinary object create. %object prototype %. Return. To object. Value 0, 1, to properties of the object constructor. The object constructor has an internal slot whose value is %function prototype %, has a length property whose value is 1, has the following additional properties: 0, 1, 2, 1 object assign, target, sources. This function copies the values of all of the enumerable own properties from one or more source objects to a target object. It performs the following steps when called: let be, to object, target. If only one argument was passed, return to, for each element next source of sources. Do, if next source is neither undefined nor null, then I let from B, to object, next source. 2. Let keys be from 3. For each element next key of keys. Do, let desk be from next key. If desk is not undefined and desk is true, then a let proper value be. Get, from next key be perform. Set, to next key, proper value, true. Return to, the length property of this function is 2, 0, 1, 2. To object create. O, properties. This function creates a new object with a specified prototype. It performs the following steps when called. If O is not an object and O is not null, throw a type error exception. Let obj be ordinary object create. O, if properties is not undefined, then error return. Object defined properties. Obj, properties 4. Return obj, 0, 1, 2, 3 object defined properties. O, properties. This function adds own properties and/or updates the attributes of existing own properties of an object. It performs the following steps when called. 18. Copyright sign. ECMA International 2024. 1. If O is not an object, throw a type error exception. Return. Object defined properties. O, properties. 0, 1, 2, 3. 1 object defined properties. O, properties. The abstract operation object defined properties takes arguments O, an object, and properties, an ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let props be, to object, properties. Let keys be props. Let descriptors be a new empty list. For each element next key of keys. Do a let prop desk be props. Next key be if prop desk is not undefined and prop desk is true, then I let desk obj be. Get props. Next key 2. Let desk be, to property descriptor, desk obj 3. Append the record, desk, to descriptors. For each element property of descriptors. Do a perform. Define property or throw. O, property 6. Return O, 0, 1, 2. For object defined property. O, P, attributes. The S function adds an own property and/or updates the attributes of an existing own property of an object. It performs the following steps when called. If O is not an object, throw a type error exception. Let key be, to property key, P. Let desk be, to property descriptor, attributes. Perform. Define property or throw. O, key, desk. Return O, 0, 1, 2, 5 object entries. O, this function performs the following steps when called. Let obj be, to object. O, let entry list be, enumerable own properties. Obj, key plus value. Return create array from list, entry list. 0, 1, 2, 6 object freeze. O, this function performs the following steps when called. If O is not an object, return O. Let status be, set integrity level. O, frozen. If status is false, throw a type error exception. Return O, 0, 1, 2, 7 object from entries. Iterable. This function performs the following steps when called. Perform. Require object coercible. Iterable. Let obj be ordinary object create. Object prototype. Assert. Obj is an extensible ordinary object with no own properties. ECMA International 2024 419. 4. Let closure be a new abstract closure with parameters, key, value, that captures obj and performs the following steps when called. A let property key be, to property key be perform. Create data property or throw, obj, property key value, see return undefined. Let adder be create built-in function, closure. 2. Return. Add entries from iterable, obj, iterable, adder. Note the function created for adder is never directly accessible to ECMAScript code. 0, 1, 2, 8. Object get own property descriptor, O, P. This function performs the following steps when called. Let obj be to object, O. Let key be to property key, P. Let desk be obj, key. Return from property descriptor, desk. 0, 1, 2, 9. Object get own property descriptors, O. This function performs the following steps when called. Let obj be to object, O. Let own keys be obj. Let descriptors be ordinary object create, percent object prototype percent. For each element key of own keys, do a let desk be obj, key. B let descriptor be from property descriptor, desk. See if descriptor is not undefined. Perform. Create data property or throw descriptors, key. Descriptor. Return descriptors. 0, 1, 2, 1, 0. Object get own property names, O. This function performs the following steps when called. Return create array from list. Get own property keys, O. String. 0, 1, 2, 1, 1. Object get own property symbols, O. This function performs the following steps when called. Return create array from list. Get own property keys, O. Symbol 2, 0, 1, 2, 1, 1, 1. Get own property keys, O. Type. The abstract operation get own property keys takes arguments O, an ECMAScript language value, and type, string or symbol, and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Let obj be to object, O. Let keys be obj. Let name list be a new empty list. For each element next key of keys, do if next key is a symbol and type is symbol, or if next key is a string and type is string, then I append next key to name list. 5. Return name list 420. ECMA International 2024. 20, 1, 2, 1, 2. Object get prototype of O. This function performs the following steps when called. Let obj be to object, O. Return obj. 0, 1, 2, 1, 3. Object group by items, callback. Callback should be a function that accepts two arguments grouped by calls callback once for. Note, each element in items, in ascending order, and constructs a new object. Each value returned by callback is coerced to a property key. For each such property key, the result object has a property whose key is that property key and whose value is an array containing all the elements for which the callback return value coerced to that key. Callback is called with two arguments, the value of the element and the index of the element. The return value of group by is an object that does not inherit from percent object prototype percent. This function performs the following steps when called. Let groups be group by items, callback property. Let obj be ordinary object create null for each record. G of groups, do a let elements be create array from list. G be perform create data property or throw obj. G return obj. 0, 1, 2, 1, 4. Object has own O, P. This function performs the following steps when called. Let obj be to object, O. Let key be to property key, P. Return has own property obj, key. 0, 1, 2, 1, 5. Object is value 1, value 2. This function performs the following steps when called. Return same value, value 1, value 2. 0, 1, 2, 1, 6. Object is extensible, O. This function performs the following steps when called. If O is not an object, return false. Return is extensible, O. 0, 1, 2, 1, 7. Object is frozen, O. This function performs the following steps when called. If O is not an object, return true. Return test integrity level, O. Frozen. ECMA International 2024 421.
So I got like 200 left, something? I don't know. I'm out of food. So I guess I'll finish this up. I really hope I don't miss a file. I'm to like go back. I do not want to do this. Anyways, whatever. This is taking too long. I want to look up a script or something, but it's gonna take just as long to do that as it would to just finish up doing it by hand. So I'll put the rest of them and do like control find, and I really hope that I didn't miss any, because then I gotta go back through and like figure out whichever one was missed, and that wouldn't be fun.
Two zero one 218 object is sealed. O. This function performs the following steps when called. If O is not an object, return true. Return. Test integrity level. O. Sealed. 0, 1, 2, 19 object keys. O. This function performs the following steps when called. Let obj be. To object. O. Let keylist be. Enumerable own properties. Obj. Key. Return create array from list. Key list. 0, 1, 2, 20 object prevent extensions. O. This function performs the following steps when called. If O is not an object, return O. Let status be. O. If status is false, throw a type error exception. Return O. 0, 1, 2, 1 object prototype. The initial value of object prototype is the object prototype object. This property has the attributes false, false, false. 0, 1, 2, 2 object seal. O. This function performs the following steps when called. If O is not an object, return O. Let status be. Set integrity level. O. Sealed. If status is false, throw a type error exception. Return O. 0, 1, 2, 3 object set prototype of O. Proto. This function performs the following steps when called. Set O2. Require object coercible. O. If proto is not an object and proto is not null, throw a type error exception. If O is not an object, return O. Let status be. O proto. If status is false, throw a type error exception. Return O. 0, 1, 2, 4 object values. O. This function performs the following steps when called. Let obj be. To object. O. Let value list be. Enumerable own properties. Obj. Value. Return create array from list. Value list. 22. ECMA International 2024. 201. 3 properties of the object prototype object. The object prototype object is %object prototype %, has an internal slot whose value is true, has the internal methods defined for ordinary objects, except for the method, which is as defined in 10471. Thus, it is an immutable prototype exotic object, has an internal slot whose value is null. 0, 1, 3, 1 object prototype constructor. The initial value of object prototype constructor is %object %. 0, 1, 3, 2 object prototype his own property, v. This method performs the following steps when called. Let p be. To property key, v. Let o be. To object, this value, return. Has own property, o. P. 0, 1, 3. 3 object prototype is prototype of v. This method performs the following steps when called. If v is not an object, return false. Let o be. To object, this value, repeat. Asset v2. V. B if v is null, return false. See if same value. O. V. Is true, return true. 0, 1, 3, for object prototype property is enumerable. V. This method performs the following steps when called. Let P be. To property key, V. Let O be. To object, this value. Let desk be. O. P. If desk is undefined, return false. Return desk. Note 1. This method does not consider objects in the prototype chain. Note the ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. Note the ordering of steps 1 and 2 preserves the behavior specified by previous editions of this specification for the case where V is not an object and this value is undefined or null. Copyright sign, ECMA International 2024 423. Note 2. The ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. 0, 1, 3, 5 object prototype to locale string, reserved 1, reserved 2. This method performs the following steps when called. Let O be this value. Return. Invoke O to string. The optional parameters to this method are not used but are intended to correspond to the parameter pattern used by ECMA 402 to locale string methods. Implementations that do not include ECMA 402 support must not use those parameter positions for other purposes. Note 2. ECMA 402 intentionally does not provide an alternative to this default implementation. 0, 1, 3, 6 object prototype to string. This method performs the following steps when called. If this value is undefined, return object undefined. If this value is null, return object null. Let O be. To object, this value. Let isArray be. IsArray O. If isArray is true, let boolten tag be array. Else if O has an internal slot, let boolten tag be arguments. Else if O has an internal method, let boolten tag be function. Else if O has an internal slot, let boolten tag be error. Else if O has an internal slot, let boolten tag be boolean. 0. Else if O has an internal slot, let boolten tag be number. 1. Else if O has an internal slot, let boolten tag be string. 2. Else if O has an internal slot, let boolten tag be date. 3. Else if O has an internal slot, let boolten tag be regexp. 4. Else, let boolten tag be object. 5. Let tag be get. Oh, add that to string tag. 6. If tag is not a string, set tag to boolten tag. 7. Return the string concatenation of object, tag, and. Note 1. This method provides a generic to locale string implementation for objects that have no locale sensitive to string behavior. Array, number, date, and %typed array provide their own locale sensitive to locale string methods. Note historically, this method was occasionally used to access the string value of the internal slot that was used in previous editions of this specification as a nominal type tag for various built-in objects. The above definition of toString preserves compatibility for legacy code that uses toString as a test for those specific kinds of built-in objects. It does not provide a reliable type testing mechanism for other kinds of built-in or program-defined objects. In addition, programs can use at toString tag in ways that will invalidate the reliability of such legacy type tests. 24. ECMA International 2024 2013 object prototype value of. This method performs the following steps when called. 1. Return. To object, this value. Normative optional. Legacy 0, 1, 3, 8 object prototype. Prota object prototype. Proto is an accessor property with attributes. False. True. The attributes are defined as follows. 0, 1, 3, 8, 1 get object prototype. Prota, the value of the. Let O be. To object, this value. Return. O, 0, 1, 3, 8, to set object prototype. Prota, the value of the. Let O be. Require object coercible. This value. If proto is not an object and proto is not null, return undefined. If O is not an object, return undefined. Let status be. O proto. If status is false, throw a type error exception. Return undefined. Normative optional. Legacy 0, 1, 3. Mine legacy object prototype accessor methods 0, 1, 3, 9. 1 object prototype. Define getter p getter. This method performs the following steps when called. Let O be. To object this value if is callable. Getter is false. Throw a type error exception. Let desk be property descriptor true. True. Let key be. To property key p perform. Define property or throw O key desk return undefined. ECMA International 2024 425 20 1 3 9 2 object prototype. Define setter p setter. This method performs the following steps when called. Let O be. To object this value if is callable. Setter is false. Throw a type error exception. Let desk be property descriptor true. True. Let key be. To property key p perform. Define property or throw O key desk return undefined. 0 1 3 9 3 object prototype. Lookup getter p. This method performs the following steps when called. Let O be. To object this value let key be. To property key p repeat ls desk be. O key b if desk is not undefined. Then I if is accessor descriptor desk is true. Return desk 2. Return undefined. C set O to O d if O is null. Return undefined. 0 1 3 9 4 object prototype. Lookup setter p. This method performs the following steps when called. Let O be. To object this value let key be. To property key p repeat ls desk be. O key b if desk is not undefined. Then I if is accessor descriptor desk is true. Return desk 2. Return undefined. C set O to O d if O is null. Return undefined. 0 1 4 properties of object instances. Object instances have no special properties beyond those inherited from the object prototype object. 0.2 function objects. 0 2 1 The function constructor. The function constructor is %function is the initial value of the function property of the global object. Creates and initializes a new function object when called as a function rather than as a constructor. Thus the function call function is equivalent to the object creation expression new function with the same arguments. 26. ECMA International 2024. Comma may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified function behavior must include a supercall to the function constructor to create and initialize a subclass instance with the internal slots necessary for built-in function behavior. All ECMAScript syntactic forms for defining function objects create instances of function. There is no syntactic means to create instances of function subclasses except for the built-in generator function, async function, and async generator function subclasses. 0, 2, 1. 1 function, parameter args, body arg. The last argument, if any, specifies the body executable code of a function. Any preceding arguments specify formal parameters. This function performs the following steps when called. Let C be the active function object. If body arg is not present, set body arg to the empty string. Return. Create dynamic function. C. New target. Normal. Parameter args. Body arg. 0, 2, 1, 1. 1 create dynamic function. Constructor. New target. Kind. Parameter args. Body arg. The abstract operation create dynamic function takes arguments constructor, a constructor, new target, a constructor, kind normal, generator, async, or async generator, parameter args, a list of ECMAScript language values, and body arg, an ECMAScript language value, and returns either a normal completion containing an ECMAScript function object or a throw completion constructor as the constructor function that is performing this action. New target is the constructor that new was initially applied to. Parameter args and body arg reflect the argument values that were passed to constructor. It performs the following steps when called. If new target is undefined, set new target to constructor. If kind is normal, Then a let prefix be function, b let exp sim be the grammar symbol function expression, c let body sim be the grammar symbol function body, yield, await, d let parameter sim be the grammar symbol formal parameters, yield, await, e let fallback proto be percent function prototype percent, else if kind is generato r. Then a let prefix be function, b let exp sim be the grammar symbol generator expression, c let body sim be the grammar symbol generator body, d let parameter sim be the grammar symbol formal parameters, plus yield, await, e let fallback proto be percent generator function prototype percent, else if kind is async. Then a let prefix be async function, b let exp sim be the grammar symbol async function expression, c let body sim be the grammar symbol async function body, d let parameter sim be the grammar symbol formal parameters, yield, plus await, e let fallback proto be percent async function prototype percent, else assert. Kind is async generator, b let prefix be async function, c let exp sim be the grammar symbol async generator expression. Note it is permissible but not necessary to have one argument for each formal parameter to be specified. For example, all three of the following expressions produce the same result. New function, a, b, c, return a plus b plus c, new function, a, b, c, return a plus b plus c, new function, a, B, C, return a plus B plus C, ECMA International 2024 427, D let body sim be the grammar symbol async generator body, E let parameter sim be the grammar symbol formal parameters, plus yield, plus await, F let fallback proto be percent async generator function prototype percent, let arg count be the number of elements in parameter args, let parameter strings be a new empty list. For each element arg of parameter args, do append to string arg to parameter strings, let body string be to string body arg 0, let current realm be the current realm record 1, perform host ensure can compile strings current realm parameter strings body string false 2, let p be the empty string 3, if arg count 0, then a set p to parameter strings 0, b let k be 1, c repeat, while k, arg count, I let next arg string be parameter strings, k, 2, set p to the string concatenation of p, a comma, and next arg string, 3, set k to k plus 1, 4, let body parse string be the string concatenation of 0 times 0, 0, 0, line feed, body string, and 0 times 0, 0, 0, line feed, 5. Let source string be the string concatenation of prefix, anonymous, p, 0 times 0, 0, 0, line feed, body parse string, and 6. Let source text be string to code points, source string, 7. Let parameters be parse text, string to code points, p, parameter sim, 8. If parameters is a list of errors, throw a syntax error exception, 9. Let body be parse text, string to code points, body parse string, body sim, 0. If body is a list of errors, throw a syntax error exception, 1. Note, the parameters and body are parsed separately to ensure that each is valid alone. For example, new function, comma does not evaluate to a function, 2. Note, if this step is reached, source text must have the syntax of expasim, although the reverse implication does not hold. The purpose of the next two steps is to enforce any early error rules which apply to expasim directly. 3. Let exp be parse text, source text, expasim. 4. If expa is a list of errors, throw a syntax error exception. 5. Let proto be get prototype from constructor, new target, fallback proto. 6. Let env be current realm. 7. Let private env be null. 8. Let f be ordinary function create, proto, source text, parameters, body, non-lexical this, env, private env. 9. Perform set function name, f, anonymous. 0. If kind is generator, then a let prototype be ordinary object create, percent generator function prototype percent be perform. Define property or throw, f, prototype, property descriptor, prototype, true, false, false. 1. Else if kind is a sync generator, then a let prototype be ordinary object create %async generator function prototype percent be perform define property or throw f prototype property descriptor prototype true false 2. Else if kind is normal, then a perform make constructor f3. Note: functions whose kind is async are not constructible and do not have an internal method or a prototype property. 4. Return F 428 ECMA International 2024. Note: create dynamic function defines a prototype property on any function it creates whose kind is not async to provide for the possibility that the function will be used as a constructor. 202. Two properties of the function constructor. The function constructor is itself a built-in function object, has an internal slot whose value is %function prototype %, has a length property whose value is 1, has the following properties: 0, 2, 2. 1 function prototype. The value of function prototype is the function prototype object. This property has the attributes false, false, false. 0, 2, 3 properties of the function prototype object. The function prototype object is %function prototype is itself a built-in function object, accepts any arguments and returns undefined when invoked, does not have an internal method. It cannot be used as a constructor with the new operator, has an internal slot whose value is %object prototype does not have a prototype property, has a length property whose value is +0, has a name property whose value is the empty string. 0, 2, 3. 1 function prototype apply. This array. This method performs the following steps when called. Let func be this value if is callable. Func is false. Throw a type error exception if array is either undefined or null. Then a perform prepare for tail call be return. Call func this arg. Let arg list be. Create list from array like array perform prepare for tail call return. Call func this arg list. Note: the function prototype object is specified to be a function object to ensure compatibility with ECMAScript code that was created prior to the ECMAScript 2015 specification. Note 1: that this arg value is passed without modification as the this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as the this value. Even though the this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2: if func is either an arrow function or a bound function exotic object, then the this arg will be ignored by the function in step 6. ECMA International 2024 429. 2023. 2 function prototype bind. This args. This method performs the following steps when called. Let target be this value if is callable. Target is false. Throw a type error exception. Let f be. Bound function create. Target this args. Let l be 0. Let target has length be. Has own property. Target length. If target has length is true, then a let target len be. Get target length be. If target len is a number, then I. If target len is plus, then 1. Set l to +2. Else if target len is, then 1. Set LTO 0, 3. Else let target len as int be. To an integer or infinity. Target len assert. Target len as int is finite. Let arg count be the number of elements in args. Set l to max. Target len as int. Arg count 0. Perform set function length f l. Let target name be. Get target name. If target name is not a string, set target name to the empty string. 0. Perform set function name f target name bound 1. Return f 0, 2, 3. 3 function prototype call. This args. This method performs the following steps when called. Let func be this value if is callable. Func is false. Throw a type error exception. Perform prepare for tail call. Return. Call func this args. Note 1: function objects created using function prototype binder exotic objects. They also do not have a prototype property. Note 2. If target is either an arrow function or a bound function exotic object, then this arg passed to this method will not be used by subsequent calls to f. Note 1. This arg value is passed without modification as this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values, and that result is passed as this value. Even though this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2. If func is either an arrow function or a bound function exotic object, then this arg will be ignored by the function in step 4. 0, 2, 3, 4 function prototype constructor. The initial value of function prototype constructor is %function %30, copyright sign, ECMA International 2024, 20235 function prototype to string. This method performs the following steps when called. Let func be this value. If func is an object, func has an internal slot. Func is a sequence of Unicode code points, and host has source text available. Func is true, then a return code points to string. Func. If func is a built-in function object, return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Additionally, if func has an internal slot and func is a string, the portion of the return string that would be matched by native function accessor opt property name must be the value of func. If func is an object and is callable, func is true. Return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Throw a type error exception. Native function. Function native function accessor opt property name. Yield. Await opt. Formal parameters. Yield. Await. Native code. Native function accessor. Get. Set. 0, 2, 3, 6 function prototype. At has instance. V. This method performs the following steps when called. Let f be this value. Return V.
I tried closing one file. Clicking the next file, and it closed one of the files. I don't know which one, so I gotta backtrack.
A different at has instance method on the function. This property is non-writable and non-configurable to prevent tampering that could be used to globally expose the target function of a bound function. The value of the name property of this method is symbol his instance 202 function instances. Every function instance is an ECMAScript function object and has the internal slots listed in table 30. Function objects created using the function prototype bind method 20232 have the internal slots listed in table 31. Function instances have the following properties. ECMA International 2024 431 20241 length. The value of the length property.
I think I found it. I hope I found it. I'm gonna just double click on a whole bunch of folders and hope that I found it, to be sure.
When invoked on a number of arguments other than the number specified by its length property depends on the function. This property has the attributes false, false, true, 0, 2, 4. To name. The value of the name property is a string that is descriptive of the function. The name has no semantic significance but is typically a variable or property name that is used to refer to the function at its point of definition in ECMAScript source text. This property has the attributes false, false, true, anonymous functions. Objects that do not have a contextual name associated with them by the specification use the empty string as the value of the name property. 0, 2, 4, 3 prototype. Function instances that can be used as a constructor have a prototype property. Whenever such a function instance is created, another ordinary object is also created and is the initial value of the function's prototype property. Unless otherwise specified, The value of the prototype property is used to initialize the internal slot of the object created when that function is invoked as a constructor. This property has the attributes true, false, false, 0, 2, 5. Host has source text available. Func. The host-defined abstract operation host has source text available takes argument func, a function object, and returns a boolean. It allows host environments to prevent the source text from being provided for func. An implementation of host has source text available must conform to the following requirements. It must be deterministic with respect to its parameters. Each time it is called with a specific func as its argument, it must return the same result. The default implementation of host has source text available is to return true 0.3 boolean objects 0, 3, 1. The boolean constructor. The boolean constructor is %boolean% is the initial value of the boolean property of the global object, creates and initializes a new boolean object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified Boolean behavior must include a supercall to the Boolean constructor to create and initialize the subclass instance with the internal slot. Function objects created using function prototype bind, or by evaluating a method definition. Note, that is not a generator method or a sync generator method, or an arrow function do not have a prototype property. 32. ECMA International 2024 203 1. 1 boolean value. This function performs the following steps when called. Let b be to boolean value. If new target is undefined, return b. Let o be ordinary create from constructor new target %boolean prototype set o to be return o 0, 3, 2. Properties of the Boolean constructor. The Boolean constructor has an internal slot whose value is %function prototype has the following properties 0, 3, 2, 1. Boolean prototype. The initial value of Boolean prototype is the Boolean prototype object. This property has the attributes false, 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 0, 3, 3. Properties of the Boolean prototype object. The Boolean prototype object is %boolean prototype is an ordinary object, is itself a Boolean object. It has an internal slot with the value false, has an internal slot whose value is %object prototype 0, 3, 3, 1. Boolean prototype constructor. The initial value of Boolean prototype constructor is %boolean% 0, 3, 3, 2. Boolean prototype to string. This method performs the following steps when called. Let b be this Boolean value, this value. If b is true, return true, else return false. 0, 3, 3, 3. Boolean prototype value of. This method performs the following steps when called. 1. Return this Boolean value, this value. 0, 3, 3, 3, 1. This Boolean value, value. The abstract operation this Boolean value takes argument value, an ECMAScript language value, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. If value is a Boolean, return value. If value is an object and value has an internal slot, then ECMA International 2024 433. A let b be value. B assert. B is a Boolean. C return B. Throw a type error exception. 0, 3, 4. Properties of Boolean instances. Boolean instances are ordinary objects that inherit properties from the Boolean prototype object. Boolean instances have an internal slot. The internal slot is the Boolean value represented by this Boolean object. 0.4 symbol objects. 0, 4, 1. The symbol constructor. The symbol constructor is %symbol is the initial value of the symbol property of the global object. Returns a new symbol value when called as a function. Is not intended to be used with the new operator. Is not intended to be subclassed. May be used as the value of an extends clause of a class definition, but a supercall to it will cause an exception. 0, 4, 1. 1 symbol. Description. This function performs the following steps when called. If new target is not undefined, throw a type error exception. If description is undefined, let desc string be undefined. Else, let desc string be to string. Description. Return a new symbol whose is desc string 0, 4. 2 properties of the symbol constructor. The symbol constructor has an internal slot whose value is %function prototype % has the following properties 0, 4, 2. 1 symbol async iterator. The initial value of symbol async iterator is the well-known symbol at async iterator, table 1. This property has the attributes false, 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 0, 4, 2. 2 symbol 4. Key. This function performs the following steps when called. Let string key be. To string key free at element of the global symbol registry list. Do if same value e assert. Global symbol registry does not currently contain an entry for string key. Let new symbol be a new symbol whose is string key. 34. ECMA International 2024. 5. Append the record new symbol to the global symbol registry list. Return new symbol. The global symbol registry is an append-only list that is globally available. It is shared by all realms. Prior to the evaluation of any ECMAScript code, it is initialized as a new empty list. Elements of the global symbol registry are records with the structure defined in Table 60. Table 60, global symbol registry record fields 0, 4, 2. 3 symbol has instance. The initial value of symbol has instance is the well-known symbol at has instance, table 1. This property has the attributes false, 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 0, 4, 2. 4 symbol is concat spreadable. The initial value of symbol is concat spreadable is the well-known symbol at is concat spreadable, table 1. This property has the attributes false, 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 0, 4, 2. 5 symbol iterator. The initial value of symbol iterator is the well-known symbol at iterator, table 1. This property has the attributes false, 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 0, 4, 2. 6 symbol key 4, sim. This function performs the following steps when called. If sim is not a symbol, throw a type error exception. Return key for symbol, sim, 0, 4, 2. 7 symbol match. The initial value of symbol match is the well-known symbol at match, table 1. This property has the attributes false, 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 0, 4, 2. 8 symbol match all. The initial value of symbol match all is the well-known symbol at match all, table 1. This property has the attributes false, 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 field name, value, usage, key, a string key used to globally identify a symbol, a symbol that can be retrieved from any realm, copyright sign, ECMA International 2024 435, 20, 4, 2. 9 symbol prototype. The initial value of symbol prototype is the symbol prototype object. This property has the attributes false, 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 0, 4, 2. 1 0 symbol replace. The initial value of symbol replace is the well-known symbol at replace, table 1. This property has the attributes false, 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 0, 4, 2. 1 1 symbol search. The initial value of symbol search is the well-known symbol at search, table 1. This property has the attributes false, 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 0, 4, 2. 1 2 symbol species. The initial value of symbol species is the well-known symbol at species, tab 1. This property has the attributes false, 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 0, 4, 2. 1 3 symbol split. The initial value of symbol split is the well-known symbol at split, table 1. This property has the attributes false, 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 0, 4, 2. 1 4 symbol to primitive. The initial value of symbol to primitive is the well-known symbol at to primitive, table 1. This property has the attributes false, 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 0, 4, 2. 1 5 symbol to string tag. The initial value of symbol to string tag is the well-known symbol at to string tag, table 1. This property has the attributes false, 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 0, 4, 2. 1 6 symbol unscopables. The initial value of symbol unscopables is the well-known symbol at unscopables, table 1. This property has the attributes false, false, false. 0, 4, 3 properties of the symbol prototype object. The symbol prototype object is %symbol prototype % is an ordinary object, is not a symbol instance and does not have an internal slot, has an internal slot whose value is %object prototype %. 36. ECMA International 2024. 2043. 1 symbol prototype constructor. The initial value of symbol prototype constructor is %symbol %2043. To get symbol prototype description. Symbol prototype description is an accessor property whose set accessor function is undefined. Its getAccessor function performs the following steps when called. Let S be the this value. Let sim be this symbol value. S return sim 0, 4, 3. 3 symbol prototype to string. This method performs the following steps when called. Let sim be this symbol value. This value. Return symbol descriptive string. Sim 0, 4, 3, 3. 1 symbol descriptive string. Sim. The abstract operation symbol descriptive string takes argument sim, a symbol, and returns a string. It performs the following steps when called. Let desc be sim's value. If desc is undefined, set desc to the empty string. Assert desc is a string. Return the string concatenation of symbol desc and 0, 4, 3, 4 symbol prototype value of. This method performs the following steps when called. 1. Return this symbol value. This value 0, 4, 3, 4, 1 this symbol value. Value. The abstract operation this symbol value takes argument value, an ECMAScript language value, and returns either a normal completion containing a symbol or a throw completion. It performs the following steps when called. If value is a symbol, return value. If value is an object and value has an internal slot, then a let S be value. B assert S is a symbol. C return S. Throw a type error exception. 0, 4, 3, 5 symbol prototype. Add to primitive. Hint. This method is called by ECMAScript language operators to convert a symbol object to a primitive value. It performs the following steps when called. Return this symbol value. This value. ECMA International 2024 437. Note the argument is ignored. This property has the attributes false, false, true. The value of the name property of this method is symbol to primitive 0, 4, 3, 6 symbol prototype. Add to string tag. The initial value of the add to string tag property is the string value symbol. This property has the attributes false, false, true 0, 4. 4 properties of symbol instances. Symbol instances are ordinary objects that inherit properties from the symbol prototype object. Symbol instances have an internal slot. The internal slot is the symbol value represented by the symbol object. 0, 4, 5 abstract operations for symbols 2, 0, 4, 5, 1 key for symbol, sim. The abstract operation key for symbol takes argument sim, a symbol, and returns a string or undefined. If sim is in the global symbol registry, C20, 4, 2, 2, the string used to register sim will be returned. It performs the following steps when called. For each element E of the global symbol registry list, do if same value E sim is true, return E. Assert global symbol contain an entry for sim, return undefined. 0.5 error objects. Instances of error objects are thrown as exceptions when runtime.
I accidentally closed another file, so now I have to open up all the folders around it and hope that I find the one that I closed. I really wish the shortcut to pick the next tab did what the shortcut is supposed to do, but it doesn't. That, if it could, that would be nice, but no. There's this little X next to the tab. If I'll hover over, not even next to it, and it goes click, and it's ah, and it fucking clicks it. So I'm gonna find whatever file that just got closed and open it again. So annoying.
Same arguments may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified error behavior must include a supercall to the error constructor to create and initialize subclass instances with an internal slot. 38. ECMA International 2024 2051 1 error. Message. Options. This function performs the following steps when called. If new target is undefined, let new target be t, he active function object. Else let new target be new target. Let O be ordinary create from constructor. New target. %error prototype %. If message is not undefined, then a let message be. To string message be perform. Capital C R E A T E capital N O N capital E N U M E R A B L E capital D A T A capital P R O P E R T O message perform. Install error cause O options return O 0 5 2 properties of the error constructor. The error constructor has an internal slot whose value is %function prototype has the following properties 0 5 2 1 error prototype. The initial value of error prototype is the error prototype object. This property has the attributes false, false, false 0 5 3 properties of the error prototype object. The error prototype object is %error prototype is an ordinary object, is not an error instance and does not have an internal slot. Has an internal slot whose value is %object prototype 0 5 3 1 error prototype constructor. The initial value of error prototype constructor is %error 2 0 5 3 2 error prototype message. The initial value of error prototype message is the empty string 2 0 5 3 3 error prototype name. The initial value of error prototype name is error 0 5 3 4 error prototype to string. This method performs the following steps when called. Let O be this value. If O is not an object, throw a type error exception. Let name be get O name. If name is undefined, set name to error. Otherwise set name to string name. Let message be get O message. If message is undefined, set message to the empty string. Otherwise set message to string MSG. If name is the empty string, return message. ECMA International 2024 439 8. If message is the empty string, return name. Return the string concatenation of name. The code unit 0 times 0038, the code unit 0 times 0020, space, and message 0, 5, 4 properties of error instances. Error instances are ordinary objects that inherit properties from the error prototype object and have an internal slot whose value is undefined. The only specified uses of is to identify error, aggregate error, and native error instances as error objects within object prototype to string 0, 5, 5 native error types used in this standard. A new instance of one of the native error objects below or of the aggregate error object is thrown when a runtime error is detected. All native error objects share the same structure, as described in 2 0, 5, 6, 0, 5, 5, 1 eval error. The eval error constructor is %eval error %. This exception is not currently used within this specification. This object remains for compatibility with previous editions of this specification. 0, 5, 5, 2 range error. The range error constructor is %range error indicates a value that is not in the set or range of allowable values. 0, 5, 5, 3 reference error. The reference error constructor is %reference error indicate that an invalid reference has been detected. 0, 5, 5, 4 syntax error. The syntax error constructor is %syntax error indicates that a parsing error has occurred. 0, 5, 5, 5 type error. The type error constructor is %type error %. Type error is used to indicate an unsuccessful operation when none of the other native error objects are in. Appropriate indication of the failure cause. 0, 5, 5, 6 URI error. The URI error constructor is %URI error %. Indicates that one of the global URI handling functions was used in a way that is incompatible with its definition. 40. Copyright sign. ECMA International 2024. 205. 6 native error object structure. When an ECMAScript implementation detects a runtime error, it throws a new instance of one of the native error objects defined in 205.5. Each of these objects has the structure described below, differing only in the name used as the constructor name instead of native error, in the name property of the prototype object, and in the implementation defined message property of the prototype object. For each error object, references to native error in the definition should be replaced with the appropriate error object name from 205.5.0.5.6. 1. The native error constructors. Each native error constructor creates and initializes a new native error object when called as a function rather than as a constructor. A call of the object as a function is equivalent to calling it as a constructor with the same arguments. Thus, the function call native error is equivalent to the object creation expression new native error with the same arguments, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified native error behavior must include a supercall to the native error constructor to create and initialize subclass instances with an internal slot. 0, 5, 6, 1. 1 native error. Message. Options. Each native error function performs the following steps when called. If new target is undefined, let new target be the active function object, else let new target be new target. Let O be ordinary create from constructor, new target, %native error prototype %error data. If message is not undefined, then a let message be. To string message be perform capital C R E A T E capital N O N capital E N U M E R A B L E capital D A T A capital P R O P E R T O message perform install error cause O options return O. The actual value of the string passed in step 2 is either %eval error prototype %range error prototype %reference error prototype %syntax error prototype %type error prototype or %URI raw prototype corresponding to which native error constructor is being defined. 0, 5, 6. 2 properties of the native error constructors. Each native error constructor has an internal slot whose value is %error has a name property whose value is the string value. Native error has the following properties. 0, 5, 6, 2. 1 native error prototype. The init al value of native error prototype is a native error prototype object. 2, 0, 5, 6, 3. Each native error constructor has a distinct prototype object. This property has the attributes false, false, false. 0, 5, 6. 3 properties of the native error prototype objects. Each native error prototype object. ECMA International 2024 441, is an ordinary object, is not an error instance and does not have an internal slot. Has an internal slot whose value is %error prototype %0, 5, 6, 3. 1 native error prototype constructor. The initial value of the constructor property of the prototype for a given native error constructor is the constructor itself. 0, 5, 6, 3, 2 native error prototype message. The initial value of the message property of the prototype for a given native error constructor is the empty string 2, 0, 5, 6, 3. 3 native error prototype name. The initial value of the name property of the prototype for a given native error constructor is the string value consisting of the name of the constructor the name used instead of native error. 0, 5, 6. 4 properties of native error instances. Native error instances are ordinary objects that inherit properties from their native error prototype object and have an internal slot whose value is undefined. The only specified use of is by object prototype to string 201336 to identify error, aggregate error, or native error instances. 0, 5, 7 aggregate error objects. 0, 5, 7. 1. The aggregate error constructor. The aggregate error constructor is %aggregate error is the initial value of the aggregate error property of the global object, creates and initializes a new aggregate error object when called as a function rather than as a constructor. Thus the function call aggregate error is equivalent to the object creation expression new aggregate error with the same arguments, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified aggregate error behavior must include a supercall to the aggregate error constructor to create and initialize subclass instances with an internal slot. 0, 5, 7, 1. 1 aggregate error. Errors. Message. Options. This function performs the following steps when called. If new target is undefined, let new target be the active function object. Else let new target be new target. Let O be ordinary create from constructor new target %aggregate error prototype %error data. If message is not undefined, then a let message be to string message be perform capital C R E A T E capital N O N capital E N U M E R A B L E capital D A T A capital P R O P E R T O message perform install error cause O options let errors list be iterator to list get iterator errors sync perform define property or throw O errors property descriptor true false true create array from list errors list return no 42 ECMA International 2024 2057 2 properties of the aggregate error constructor. The aggregate error constructor has an internal slot whose value is %error has the following properties 0 5 7 2 1 aggregate error prototype. The initial value of aggregate error prototype is %aggregate error prototype %. This property has the attributes false, 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 0, 5, 7, 3 properties of the aggregate error prototype object. The aggregate error prototype object is %aggregate error prototype is an ordinary object, is not an error instance or an aggregate error instance and does not have an internal slot. Has an internal slot whose value is %error prototype 0, 5, 7, 3. 1 aggregate error prototype constructor. The initial value of aggregate error prototype constructor is %aggregate error 2 0 5 7 3 2 aggregate error prototype message. The initial value of aggregate error prototype message is the empty string 2 0 5 7 3 3 aggregate error prototype name. The initial value of aggregate error prototype name is aggregate error 2 0 5 7 4 properties of aggregate error instances. Aggregate error instances are ordinary objects that inherit properties from their aggregate error prototype object and have an internal slot whose value is undefined. The only specified use of is by object prototype to string 2 0 1 3 6 to identify error, aggregate error, or native error instances 0 5 8 abstract operations for error objects 2 0 5 8 1 install error cause O options. The abstract operation install error cause takes arguments O, an object, and options, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to create a cause property on O when a cause property is present on options. It performs the following steps when called. If options is an object and has property options cause is true, then let cause be get options cause be perform. Capital C R E A T E capital N O N capital E N U M E R A B L E capital D A T A capital P R O P E R T O cause return unused. ECMA International 2024 443 21 numbers and dates. 1.1 number objects. 1 the number constructor. The number constructor is %number is the initial value of the number property of the global object. Creates and initializes a new number object when called as a constructor. Performs a type conversion when called as a function rather than as a constructor. May be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified number behavior must include a supercall to the number constructor to create and initialize the subclass instance with the internal slot. 1 number value. This function performs the following steps when called. If value is present, then let prim be a numeric value. B if prim is a big int, let n be r prim. C otherwise, let n be prim, else let n be +0. If new target is undefined, return n, let o be ordinary. Create from constructor new target %number prototype set o to n, return o. 1 2 properties of the number constructor. The number constructor has an internal slot whose value is %function prototype has the following properties. 1 2 1 number epsilon. The value of number epsilon is the number value for the magnitude of the difference between 1 and the smallest value greater than 1 that is representable as a number value, which is approximately 2204460892503130808472633361816 times 1016. This property has the attributes false, 1 2 number is finite number. This function performs the following steps when called. If number is not a number, return false. If number is not finite, return false. Otherwise, return true. 44. ECMA International 2024 1 2 3 number is integer number. This function performs the following steps when called. Return is integral number 1 2 4 number is nan number. This function performs the following steps when called. If number is not a number, return false. If number is nan, return true. Otherwise, return false. 1 2 5 number is safe integer number. This function performs the following steps when called. 1 if this integral number is true, then if abs r number 253 1 return true. 2 return false. 1 2 6 number max safe integer. The value of number max safe integer is 90071992547409991 253 1. This property has the attributes false 1 2 7 number max value. The value of number max value is the largest positive finite value of the number type, which is approximately 1 79769313486233157 times 10,308. This property has the attributes false. Note this function differs from the global isNaN function 1923 in that it does not convert its argument to a number before determining whether it is nan. Note an integer n is a safe integer if and only if the number value for n is not the number value for any other integer. Note due to rounding behavior necessitated by precision limitations of IEEE 754-2019, the number value for every integer greater than number max safe integer is shared with at least one other integer. Such large magnitude integers are therefore not safe, and are not guaranteed to be exactly representable as number values or even to be distinguishable from each other. For example, Both 9007199254740992 and 9007199254740993 evaluate to the number value 9007199254740992. ECMA International 2024 445 21112. Number min safe integer. The value of number min safe integer is -9,007,199,254, 740,991, 253 1. This property has the attributes false, 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 1, 1, 2. 9 number min value. The value of number min value is the smallest positive value of the number type, which is approximately 5 times 10 324. In the IEEE 754-2019 double precision binary representation, the smallest possible value is a denormalized number. If an implement...
I have like maybe 200. I don't know how that's like... This is a found.
1, 2, 1, 0.
139. There's...
False, false, false. 1, 1.
What was the total? I don't know. There's a lot more files. This take forever.
Float property is %parse float %. 1, 1, 2, 1, 3 number parse int string radix. The initial value of the parse int property is %parse int %. 1, 1, 2, 1 4 number positive infinity. The value of number positive infinity is plus. This property has the attributes false, false, false. 1, 1, 2, 1 5 number prototype. The initial value of number prototype is the number prototype object. This property has the attributes false, false, false. Note, due to rounding behavior necessitated by precision limitations of IEEE 754-2019, the number value for every integer less than number min safe integer is shared with at least one other integer. Such large magnitude integers are therefore not safe, and are not guaranteed to be exactly representable as number values or even to be distinguishable from each other. For example, both -9071992547409992 and -9071992547409993 evaluate to the number value -9071992547409992. 46. Copyright sign, ECMA International 2024. 211. 3 properties of the number prototype object. The number prototype object is %number prototype is an ordinary object, is itself a number object. It has an internal slot with the value +0, has an internal slot whose value is %object prototype unless explicitly stated otherwise. The methods of the number prototype object defined below are not generic, and this value passed to them must be either a number value or an object that has an internal slot that has been initialized to a number value. The phrase "this number value" within the specification of a method refers to the result returned by calling the abstract operation "this number value" with this value of the method invocation passed as the argument. 1, 1, 3. 1 number prototype constructor. The initial value of number prototype constructor is %number %2 1, 1, 3, 2 number prototype to exponential fraction digits. This method returns a string containing this number value represented in decimal exponential notation with 1 digit before the significance decimal point and fraction digits after the significance decimal point. If fraction digits is undefined, it includes as many significant digits as necessary to uniquely specify the number, just like int a string, except that in this case the number is always output in exponential notation. It performs the following steps when called. Let x be this number value, this value. Let f be to an integer or infinity, fraction digits. Assert, if fraction digits is undefined, then f is 0. If x is not finite, return number to string x 10 if f 0 or f 100. Throw a range error exception. Set x to r x, let s be the empty string. If x 0, then a set s to dart, b set x to x. If x equals 0, then a let n be the string value consisting of f plus 1 occurrences of the code unit 0 times 0030, digit 0, b let e 0, 0. Else, if fraction digits is not undefined, then I let e and n be integers such that 10fn, 10f plus 1 and for which n10e, f, x is as close to 0 as possible. If there are two such sets of e and n, pick the e and n for which n10e, f is larger, b else, I let e, n, and ff be integers such that ff0, 10ffn, 10ff plus 1, n10e, ff, is x, and ff is as small as possible. Note that the decimal representation of n has ff plus 1 digits. N is not divisible by 10, and the least significant digit of n is not necessarily uniquely determined by these criteria. 2. Set f to ff. C let m be the string value consisting of the digits of the decimal representation of n, in order, with no leading zeros. 1. If f0, then a let be the first code unit of m, b let b be the other f code units of m. C set m to the string concatenation of a and b. 2. If e equals 0, then ECMA International 2024 447, a let cb plus b let db 0. 3. Else, if e 0, then I let cb plus b else I assert e 0. 2. Let cb dart. 3. Set e to e, c let d be the string value consisting of the digits of the decimal representation of e, in order, with no leading zeros. 4. Set m to the string concatenation of m, e, c, and e. 5. Return the string concatenation of s and m. Note for implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of step 10bi be used as a guideline. I let e, n, and f be integers such that f0, 10fn, 10f plus 1, n10e, f, is x, and f is as small as possible. If there are multiple possibilities for n, choose the value of n for which n, 10e, f, is closest in value to x. If there are two such possible
100. So
number values. For example, ECMA International 2024 449.
I need some water. It's so dry. Okay, what is up with this stupid streaming crap?
Of the digits of the decimal representation of e, in order, with no leading zeros. V. Return the string concatenation of s, m, the code unit 0 times 0065, Latin small letter e, c, and e. 1. If e equals p1, return the string concatenation of s and m. 2. If e 0, then a set m to the string concatenation of the first e plus 1 code units of m, the code unit 0 times 002 e, full stop, and the remaining p, e plus 1, code units of m. 3. Else, a set m to the string concatenation of the code unit 0 times 0030, digit 0, the code unit 0 times 002 e, full stop, e plus 1.
Like, what is up with the software? Like, for real. Like, for real.
Concatenation of s and m. 1, 1, 3, 6 number prototype to string. Radix. This method performs the following steps when called. Let x be this number value, this value. If radix is undefined, let radix mv be 10. Else, let radix.
Like, what even is this? Like, what even is this?
Exception. Return number to string x.
How is it even running if this is true? How is it even running if because it's still running right here in 11,000? That's like lower than it looks like crap. 16, even 16 looks like crap, but like, and it looks like crap. 100, even 16 looks like crap, but like, I don't think changing the variable difference, but I don't think changing the variable difference make any difference because these people are incapable. This makes people are incapable It's ridiculous. So making a program dumb. It's ridiculous. So dumb.
A supercall to the big int constructor will cause an exception. 1, 2, 1, 1 big int value. This function performs the following steps when called. If new target is not undefined, throw a type error exception. Let prim be to primitive value number. If prim is a number, return number to big int.
I think it's just the software, and so dumb. So dumb.
Returns either a normal completion containing a big int or a throw completion. It performs the following step.
I'll just like ignore that it says this up here, and I'll just like ignore that it's lagging out, and pretend see what happens. I guess not lagging out. YouTube's like what happens. I guess shadow banning me or something too. So whatever. Fuck that. YouTube's like shadow banning me or something too. So whatever. Fuck that. Just keep swimming. Swimming. Oh, this is so dumb though. Fucking swimming. Dumb as fuck. Oh, this is so dumb though. Fucking
steps when
dumb as fuck.
Set bits 2 to int x bits. Set magent 2 to big int bigint. Let mod br bigint modulo 2 bits. If mod 2 bits 1, return z mod 2 bits. Otherwise, return z mod 1 2 2 big int zoomed bits.
I think I'll drop the bitrate to like 500 or something. See if it does anything. Doesn't look like shit. Looks like shit anyways with all this compression and stuff.
Attributes. False. 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 1, 2, 3 properties of the BigInt prototype object. The BigInt prototype object is %BigInt prototype % is an ordinary object. Is not a BigInt object. It does not have an internal slot. Has an internal slot whose value is %object prototype %. The phrase this BigInt value within the specification of a method refers to the result returned by calling the abstract operation this BigInt value with this value of the method invocation passed as the argument. 1, 2, 3. 1 BigInt prototype constructor. The initial value of BigInt prototype constructor is %BigInt %2 1, 2, 3. 2 BigInt prototype to locale string, reserved 1, reserved 2, an ECMAScript implementation that includes the ECMA 402 internationalization API must implement this method as specified in the ECMA 402 specification. If an ECMAScript implementation does not include the ECMA 402 API, the following specification of this method is used. This method produces a string value that represents this BigInt value formatted according to the conventions of the host environment's current locale. This method is implementation defined, and it is permissible, but not encouraged, for it to return the same thing as to string. The meanings of the optional parameters to this method are defined in the ECMA 402 specification. Implementations that do not include ECMA 402 support must not use those parameter positions for anything else. 1, 2, 3. 3 BigInt prototype to string, radix. This method performs the following steps when called. Let x be this BigInt value, this value. If radix is undefined, let radix mv be 10, else let radix mv be to an integer or infinity, radix. If radix mv is not in the inclusive interval from 2 to 36, throw a range error exception. Return BigInt to string x, radix mv. This method is not generic. It throws a type error exception if this value is not a BigInt or a BigInt object. Therefore, it cannot be transferred to other kinds of objects for use as a method. 1, 2, 3, 4 BigInt prototype value of 192994046. This property has the attributes false, false, false. Copyright sign ECMA International 2024 453 2131 3 math ln2. The number value for the natural logarithm of 2, which is approximately 0.69314718055999453. This property has the attributes false, 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 1, 3, 1. Format log 10e, the number value for the base 10 logarithm of e, the base of the natural logarithms. This value is approximately, 43429448190325518. This property has the attributes false, 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 1, 3, 1. 5 math log 2 e, the number value for the base 2 logarithm of e, the base of the natural logarithms. This value is approximately 1, 442695040888964. This property has the attributes false, 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 1, 3, 1. 6 math pi, the number value 4,
π,
the ratio of the circumference of a circle to its diameter, which is approximately 3, 14159265358979932. This property has the attributes false, 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 1, 3, 1. 7 math sqrt 1, 2, the number value for the square root of 12, which is approximately 0.707106781186546. This property has the attributes false, 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 1, 3, 1. 8 math sqrt 2, the number value for the square root of 2, which is approximately 1, 41421356237309151. This property has the attributes false, 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 1, 3, 1. 9 math add to string tag. The initial value of the add to string tag property is the string value math. This property has the attributes false, false, true. Note, the value of math log 10e is approximately the reciprocal of the value of math ln 10. Note, the value of math log 2e is approximately the reciprocal of the value of math ln 2. Capital N. Oat, the value of math sqrt 1, 2 is approximately the reciprocal of the value of math sqrt 2. 54. Copyright sign, ECMA International 2024. 2, 3, 2 function properties of the math object. The behavior of the functions ACOS, ACOSH, ASIN, ASIN, ATIN, ATIN, ATIN2, CBRT, COS, Note, COSH, EXP, X1, HIPPERT, log, log 1p, log 2, log 10, POW, random, SIN, SHINE, SQRT, TAN, and TANH is not precisely specified here except to require specific results for certain argument values that represent boundary cases of interest. For other argument values, these functions are intended to compute approximations to the results of familiar mathematical functions, but some latitude is allowed in the choice of approximation algorithm. Return an implementation approximated number value representing the result of the inverse sine of r, n, 1, 3, 2, 5 mathesin, x. This function returns the inverse hyperbolic sine of x. It performs the following steps when called. Let n be to num bear x. If n is not finite or n is either plus 0 or minus 0, return n. Return an implementation approximated number value representing the result of the inverse hyperbolic sine of r, n, 1, 3, 2, 6 mathatin, x. This function returns the inverse tangent of x. The result is expressed in radians and is in the inclusive interval from
π2,
to.
π2,
It performs the following steps when called. Let n be to number x. If n is one of nan, plus 0 or minus 0, return n. If n is plus, return an implementation approximated number value representing
π2,
capital I. If n is, return an implementation approximated number value representing
π2,
return an implementation approximated number value representing the result of the inverse tangent of r, n, 1, 3, 2, 7 mathatin, x. This function returns the inverse hyperbolic tangent of x. It performs the following steps when called. Let n be to number x. If n is one of nan, plus 0 or minus 0, return n. If n, 1 or n, minus 1, return nan. If n is 1, return plus. If n is minus 1, return an implementation approximated number value representing the result of the inverse hyperbolic tangent of r, n. 56. ECMA International 2024. 2, 3, 2, 8 mathatin 2, y, x. This function returns the inverse tangent of the quotient yx of the arguments y and x, where the signs of y and x are used to determine the quadrant of the result. Note that it is intentional and traditional for the two-argument inverse tangent.
P.
Capital A, assert. Ni is finite and is neither plus 0 nor minus 0. If ni plus 0, then A if n x is plus, return plus 0. B if n x is, return an implementation approximated number value representing.
P.
C if n x is either plus 0 or minus 0, return an implementation approximated number value representing.
P2.
0. Capital I if ni minus 0. T hen A if n x is plus, return minus 0. B if n x is, return an implementation approximated number value representing.
P.
C if n x is either plus 0 or minus 0, return an implementation approximated number value representing.
P2.
1. Capital A, assert. Nx is finite and is neither plus 0 nor minus 0. 2. Let R be the inverse tangent of abs. R. Ni. R. Nx. 3. If nx minus 0, then A if ni plus 0. Set R2.
P.
B else. Set R2.
P sin.
4. Else A if ni minus 0. Set R2 R5. Return an implementation approximated number value representing R1, 3, 2, 9 math CBRT, x. This function returns the cube root of x. It performs the following steps when called. Let n be to number x. If n is not finite or n is either plus 0 or minus 0, return n. Return an implementation approximated number value representing the result of the cube root of r. N. ECMA International 2024 457 21 3 2 1 0 Math Seal x. This function returns the smallest, closest to integral number value that is not less than x if x is already an integral number. The result is x. It performs the following steps when called. Let n be to number x. If n is not finite or n is either plus 0 or minus 0, return n. If n minus 0 and n minus 1, return minus 0. If n is an integral number, return n. Return the smallest, closest to integral number value that is not less than n. 1, 3, 2, 1 1 Math CLZ 32 x. This function performs the following steps when called. Let n be to 32 x. Let p be the number of leading 0 bits in the unsigned 32-bit binary representation of n. Return p 1, 3, 2, 1 2 Math cos x. This function returns the cosine of x. The argument is expressed in radians. It performs the following steps when called. Let n be to number x. If n is not finite, return n. If n is either plus 0 or minus 0, return 1. Return an implementation approximated number value representing the result of the cosine of r. n 1, 3, 2, 1 3 Math cosh x. This function returns the hyperbolic cosine of x. It performs the following steps when called. Let n be to number x. If n is nan, return nan. If n is either plus or, return plus. If n is either plus 0 or minus 0, return 1. Return an implementation approximated number value representing the result of the hyperbolic cosine of r. n 458. ECMA International 2024. Note, the value of Math Seal x is the same as the value of Mathfloor x. Note if n is either plus 0 or minus 0, this method returns 32. If the most significant bit of the 32-bit binary encoding of n is 1, this method returns plus 0. The value of mathcosh x is the same as the value of note mathy xp x plus mathy xp x 2 2 1 3 2 1 4 mathy xp x. This function returns the exponential function of x, e raised to the power of x, where e is the base of the natural logarithms. It performs the following steps when called. Let n be to number x. If n is either nan or plus, return n. If n is either plus 0 or minus 0, return 1. If n is, return plus 0. Return an implementation approximated number value representing the result of the exponential function of r. n 1, 3, 2, 1 5 Math x 1 x. This function returns the result of subtracting 1 from the exponential function of x, e raised to the power of x, where e is the base of the natural logarithms. The result is computed in a way that is accurate even when the value of x is close to 0. It performs the following steps when called. Let n be to number x if n is one of nan, plus 0, minus 0, or plus, return n if n is, return minus 1. Return an implementation approximated number value representing the result of subtracting 1 from the exponential function of r, n, 1, 3, 2, 1, 6 mathfloor, x. This function returns the greatest, closest to plus, integral number value that is not greater than x if x is already an integral number. The result is x. It performs the following steps when called. Let n be to number x if n is not finite or n is either plus 0 or minus 0, return n if n, 1 and n, plus 0, return plus 0. If n is an integral number, return n, return the greatest, closest to plus, integral number value that is not greater than n, 1, 3, 2, 1, 7 math round, x. This function performs the following steps when called. Let n be to number x if n is nan, return nan if n is 1 of plus 0, minus 0, plus, or return n. Let n32 be the result of converting n to i.e. E7542019 binary 32 format using round ties to even mode. Let n64 be the result of converting n32 to i.e. E7542019 binary 64 format. Return the ECMAScript number value corresponding to n64. Note, the value of mathfloor, x, is the same as the value of mathseal, x. ECMA International 2024 459 21 3 2 18 math hippert, args, given 0 or more arguments. This function returns the square root of the sum of squares of its arguments. It performs the following steps when called. Let coerce be a new empty list. For each element arg of args, do a let n be to number arg be append n to coerced. For each element number of coerced, do if number is either plus or, return plus. Let only 0 be true. For each element number of coerced, do if number is nan, return nan. Be if number is neither plus 0 nor minus 0. Set only 0 to false. If only 0 is true, return plus 0. Return an implementation approximated number value representing the square root of the sum of squares of the mathematical values of the elements of coerced. The length property of this function is 2, 1, 3, 2, 1, 9 math iml, x, y. This function performs the following steps when called. Let a be r, to 32, x. Let b be r, to 32, y. Let product be a b, modulo 232. If product 231, return product 232. Otherwise return product 1, 3, 2, 20 mathlog, x. This function returns the natural logarithm of x. It performs the following steps when called. Let n be to number x if n is either nan or plus, return n. If n is 1, return plus 0. If n is either plus 0 or minus 0, return if n, minus 0, return nan. Return an implementation approximated number value representing the result of the natural logarithm of r, n, 1, 3, 2, 2, 1 mathlog 1p, x. This function returns the natural logarithm of 1 plus x. The result is computed in a way that is accurate even when the value of x is close to 0. It performs the following steps when called. Note, implementations should take care to avoid the loss of precision from overflows and underflows that are prone to occur in naive implementations when this function is called with 2 or more arguments. 60. Copyright sign, ECMA International 2024. 1. Let n be to number x if n is 1 of nan, plus 0, minus 0, or plus, return n. If n is minus 1, return if n, minus 1, return nan. Return an implementation approximated number value representing the result of the natural logarithm of 1 plus r, n, 1, 3, 2, 2, 2 mathlog 10, x. This function returns the base 10 logarithm of x. It performs the following steps when called. Let n be to number x if n is either nan or plus, return n. If n is 1, return plus 0. If n is either plus 0 or minus 0, return if n, minus 0, return nan. Return an implementation approximated number value representing the result of the base 10 logarithm of r, n, 1, 3, 2, Note 23 math log 2 x. This function returns the base 2 logarithm of x. It performs the following steps when called. Let n be the number x if n is either nan or plus. Return n if n is 1. Return plus 0 if n is either plus 0 or minus 0. Return if n minus 0. Return nan. Return an implementation approximated number value representing the result of the base 2 logarithm of r n 1 3 2 2 4 math max args given 0 or more arguments. This function calls to number on each of the arguments and returns the largest of the resulting values. It performs the following steps when called. Let curs be a new empty list. For each element arg of args, do let n be the number arg be append n to coerced. Let highest be for each element number of coerced. Do if number is nan. Return nan. Be if number is plus 0 and highest is minus 0. Set highest to plus 0. See if number highest. Set highest to number. Return highest. The length property of this function is 2. ECMA International 2024 461. Note the comparison of values to determine the largest value is done using the is less than algorithm, except that plus 0 is considered to be larger than minus 0. 2 1 3 2 2 5 math min args given 0 or more arguments. This function calls to number on each of the arguments and returns the smallest of the resulting values. It performs the following steps when called. Let curs be a new empty list. For each element arg of args, do let n be the number arg be append n to coerced. Let lowest be plus. For each element number of coerced, do if number is nan. Return nan. Be if number is minus 0 and lowest is plus 0. Set lowest to minus 0. See if number lowest. Set lowest to number. Return lowest. The length property of this function is 2 1 3 2 to 6 math pow base exponent. This function performs the following steps when called. Set base 2 to number base. Set exponent 2 to number exponent. Return number exponentiate base exponent 1 3 2 2 7 math random. This function returns a number value with positive sign, greater than or equal to plus 0 but strictly less than 1, chosen randomly or pseudo-randomly with approximately uniform distribution over that range, using an implementation defined algorithm or strategy. Each math random function created for distinct realms must produce a distinct sequence of values from successive calls. 1 3 2 2 8 math round x. This function returns the number value that is closest to x and is integral. If two integral numbers are equally close to x, then the result is the number value that is closer to plus. If x is already integral, the result is x. It performs the following steps when called. Let n be the number x if n is not finite or n is an integral number. Return n if n 0.5 and n plus 0. Return plus 0 if n minus 0 and n minus 0.5, return minus 0. Return the integral number closest to n, preferring the number closer to plus in the case of a tie. Note 1 math round 3.5 returns 4, but math round minus 3.5 returns minus 3. 462. ECMA International 2024. Note the comparison of values to determine the largest value is done using the is less than algorithm, except that plus 0 is considered to be larger than minus 0. Note 2 the value of math round x is not always the same as the value of mathfloor x plus 0.5. When x is minus 0 or x is less than plus 0 but greater than or equal to minus 0.5, math round x returns minus 0, but mathfloor x plus 0.5 returns plus 0. Math round x may also differ from the value of mathfloor x plus 0.5 because of internal rounding when computing x plus 0.5. 1 3 2 2 9 math sign x. This function returns the sign of x, indicating whether x is positive, negative, or 0. It performs the following steps when called. Let n be the number x if n is one of nan plus 0 or minus 0. Return n if n minus 0. Return minus 1. Return 1 1 3 2 3 0 maths in x. This function returns the sign of x. The argument is expressed in radians. It performs the following steps when called. Let n be the number x if n is one of nan plus 0 or minus 0. Return n if n is either plus or. Return nan. Return an implementation approximated number value representing the result of the sign of r. n 1 3 2 3 1 mathshine x. This function returns the hyperbolic sign of x. It performs the following steps when called. Let n be the number x if n is not finite or n is either plus 0 or minus 0. Return n. Return an I. Implementation approximated number value representing the result of the hyperbolic sign of r. n 1 3 2 3 2 math sqrt x. This function returns the square root of x. It performs the following steps when called. Let n be the number x if n is one of nan plus 0 minus 0 or plus. Return n if n minus 0. Return nan. Return an implementation approximated number value representing the result of the square root of r. n. The value of mathshine x is the same as the value of note mathy xp x. Mathy xp x 2. ECMA International 2024 463 21 3 2 3 3 math tan x. This function returns the tangent of x. The argument is expressed in radians. It performs the following steps when called. Let n be the number x if n is one of nan plus 0 or minus 0. Return n if n is either plus or. Return nan. Return an implementation approximated number value representing the result of the tangent of r. n 1 3 2 3 4 math tan h x. This function returns the hyperbolic tangent of x. It performs the following steps when called. Let n be the number x if n is one of nan plus 0 or minus 0. Return n if n is plus. Return 1 if n is. Return minus 1. Return an implementation approximated number value representing the result of the hyperbolic tangent of r. n 1 3 2 3 5 math trunk x. This function returns the integral part of the number x, removing any fractional digits. If x is already integral, the result is x. It performs the following steps when called. Let n be the number x if n is not finite or n is either plus 0.
I think I tagged all of the files in use. There's a couple directories that are in folders with stuff but not part of the build or whatever.
One overview of date objects and definition.
I can't really move them out because they're part of a different build or whatever. So I'm just gonna leave them and not tag them to like a separate thing in the project.
This is nan. The result will be nan.
So now I can do Control F, see how many that are whatever placed or tagged. And now I gotta go through all these files and actually put a real check in place because now they're all tagged. So I can do
an accounting of every day is comprising exactly 86,400 seconds, each of which
Control Shift F, paste,
finite integral number representing an instant.
and then this is every single file I have to actually check. So there's only 316.
Thousand. That is 86,400,000 d for some integer d. Represents the instant at the start of the UTC day that the value of math tan h.
Okay, so that means there's 392 total files, whatever, and only 316 are directly to this part of the program. There's other small programs and other directories tied in, but these are the ones that are part of the outmost JavaScript engine, whatever.
Time values do.
So now I gotta go through these 316 put a define guard at the top of them, but now I can search for all the headers, C files, JavaScript, or HTML, and then paste them all at the top. I think I could possibly do a mass find and replace because they're all tagged, and that should work because I'll have the same exact. I pasted it. It should be the same.
992 to 900.
So I'm gonna like drop the bitrate on the stream, see if that fixes anything, and I'll try to do this, or I'll just end it if the stream doesn't make it. The only time the stream seems to lag is like if there's like 8 people watching, it goes spikes, or like if anybody's watching, it starts to crash. And when no one's watching, it's like, oh, it's fine. I don't know, it seems suspect, but the software, all of it's just so shitty, so it's not really too suspect because it's just a bunch of shit. It's a bunch of crappy garbage streaming software and streaming service garbage. So I will drop the bitrate and then get some pop and water and continue on this journey that should be over in like 8 days, 7 days. 7 days, I think. Today's 8, I don't know, whatever. I moved the whiteboard. And then I'll be able to actually get into actually meeting the JavaScript standards and crap. So I'm gonna drop the bitrate. I still have to run it and save it back up. I'll see if it looks like it'll build first. Ooh, it might crash. Maybe it's okay. I'll just save it back up. Something could have gotten messed up if it whatever, technically, whatever.
$100,000 equals ms per minute, minutes per hour. Ms per day equals 86,400,000 equals ms per hour, hours per day. 1, 4, 1, 3 day, t. The abstract operation day takes argument t, a finite time value, and returns an integral number. It returns the day number of the day in which t falls. It performs the following steps when called. 1. Return floor r tms per day. 1, 4, 1. 4 time within day t. The abstract operation time within day takes argument t, a finite time value, and returns an integral number in the interval from +0, inclusive, to ms per day, exclusive. It returns the number of milliseconds since the start of the day in which t falls. It performs the following steps when called. Return r t modulo r ms per day. ECMA International 2024 465 21.
This computer is so laggy. 2 gigahertz is so slow.
Y, an integral number, and returns 365.
I have to like open something and then go back and open again because like it doesn't like register the click.
It performs the following steps when called. Let RIBR. Why, if.
Or it does and like it like opens another folder because it jumps ahead and like to double click picks something like inside of the folder I open, or like grabs it sometime and pastes it or moves it into another folder, and it's like crap. You know, this computer is really slow.
Day from year takes argument y, an integral number, and returns an integral number. It returns the day number of the first day of year where it performs the following steps when called. Let RIBR. Why, note, in the following steps, num years 1, num years 4, num years 100 and num years 400 represent the number of years divisible by 1, 4, 100, and 400, respectively, that occur between the epoch and the
Now I can run it.
wires before the epoch. Let num years 1 be Rye 1970. Let num years 4 be floor Rye 1969. 4. Let num years 100 be floor Rye 1901. 100. Let num years
This takes like 2 minutes to build. Oh, this computer is so laggy.
4. Num years 100 plus num years 400. 1. 4.
So I'll run this, drop the bitrate into like 500 or some like really slow number.
Number and returns a time value.
And then I'll either end the stream or I'll try to like do some of the finding replacing and get the headers and stuff in place. So where's I don't know. I'll drop the bitrate and run this, be back.
It returns the year in which t falls. It performs the following steps when called. Return the largest integral number y, closest to plus, such that time from year, y, t, 1, 4, 1, 9 day within year, t. The abstract operation day within year takes argument t.
Never mind, the bitrate looks perfectly fine. All of a sudden, that's cool. That's crap.
The following steps when called. 1. Return day, t, day from year from time, t, 1, 4, 1, 1, 0 in leap year, t. The abstract operation in leap year takes argument t, a finite time value, and returns plus 0 or 1. It returns 1 if t is within a leap year and plus 0 otherwise. It performs the following steps when called. 1. If days in year from time, t, is 366, return 1, else return plus 0, 66. ECMA International 2024. 2 1, 4, 1, 1 1 month from time, t. The abstract operation month from time takes argument t, a finite time value, and returns an integral number in the inclusive interval from plus 0 to 11. It returns a number identifying the month in which t falls. A month value of plus 0 specifies January. 1 specifies February. 2 specifies March. 3 specifies April. 4 specifies May. 5 specifies June. 6 specifies July. 7 specifies August. 8 specifies September. 9 specifies October. 10 specifies November. And 11 specifies December. Note that month from time, plus 0, equals plus 0, corresponding to Thursday, the 1st of January, 1970. It performs the following steps when called. Let in leap year be in leap year, t. Let day within year be day within year, t. If day within year, 31, return plus 0. If day within year, 59 plus in leap year, return 1. If day within year, 90 plus in leap year, return 2. If day within year, 120 plus in leap year, return 3. If day within year, 151 plus in leap year, return 4. If day within year, 181 plus in leap year, return 5. If day within year, 212 plus in leap year, return 6. 0. If day within year, 243 plus in leap year, return 7. 1. If day within year, 273 plus in leap year, return 8. 2. If day within year, 304 plus in leap year, return 9. 3. If day within year, 334 plus in leap year, return 10. 4. Assert, day within year, 365 plus in leap year. 5. Return 11. 1, 4, 1, 1 2 date from time, t. The abstract operation date from time takes argument t, a finite time value, and returns an integral number in the inclusive interval from 1 to 31. It returns the day of the month in which t falls. It performs the following steps when called. Let in leap year be in leap year, t. Let day within year be day within year, t. Let month be month from time, t. If a month is plus 0, return day within year plus 1. If a month is 1, return day within year 30. If a month is 2, return day within year 58. In leap year, if a month is 3, return day within year 89. In leap year, if a month is 4, return day within year 119. In leap year, if a month is 5, return day within year 150. In leap year 0, if a month is 6, return day within year 180. In leap year 1, if a month is 7, return day within year 211. In leap year 2, if a month is 8, return day within year 242. In leap year 3, if a month is 9, return day within year 272. In leap year 4, if a month is 10, return day within year 303. In leap year 5, assert, month is 11. 6, return day within year 333. In leap year 1, 4, 1, 1 3 weekday, T, the abstract operation weekday takes argument T, a finite time value, and returns an integral number in the inclusive interval from +0 to 6. It returns a number identifying the day of the week in which T falls. A weekday value of +0 specifies Sunday. 1 specifies Monday. 2 specifies Tuesday. 3 specifies Wednesday. 4 specifies Thursday. 5 specifies Friday. And 6 specifies Saturday. Note that weekday +0 equals 4, corresponding to Thursday, the 1st of January, 1970. It performs the following steps when called. Return R, day, T +4, modulo 7, ECMA International 2024 467 21 4 1 1 4 hour from time, T, the abstract operation hour from time takes argument T, a finite time value, and returns an integral number in the inclusive interval from +0 to 23. It returns the hour of the day in which T falls. It performs the following steps when called. Return floor R, TMS per hour, modulo hours per day 21 4 1 1 5 min from time, T, the abstract operation min from time takes argument T, a finite time value, and returns an integral number in the inclusive interval from +0 to 59. It returns the minute of the hour in which T falls. It performs the following steps when called. Return floor R, TMS per minute, modulo minutes per hour 21 4 1 1 6 sec from time, T, the abstract operation sec from time takes argument T, a finite time value, and returns an integral number in the inclusive interval from +0 to 59. It returns the second of the minute in which T falls. It performs the following steps when called. Return floor R, TMS per second, modulo seconds per minute 21 4 1 1 7 ms from time, T, the abstract operation ms from time takes argument T, a finite time value, and returns an integral number in the inclusive interval from +0 to 999. It returns the millisecond of the second in which T falls. It performs the following steps when called. Return R, T, modulo R, ms per second 1 4 1 1 8 get UTC epoch nanoseconds, year, month, day, hour, minute, second, millisecond, microsecond, nanosecond. The abstract operation get UTC epoch nanoseconds takes arguments year, an integer, month, an integer in the inclusive interval from 1 to 12, day, an integer in the inclusive interval from 1 to 31, hour, an integer in the inclusive interval from 0 to 23, minute, an integer in the inclusive interval from 0 to 59, second, an integer in the inclusive interval from 0 to 59, millisecond, an integer in the inclusive interval from 0 to 999, microsecond, an integer in the inclusive interval from 0 to 999, a nanosecond, an integer in the inclusive interval from 0 to 999, and returns a big int. The returned value represents a number of nanoseconds since the epoch that corresponds to the given ISO 8601 calendar date and wall clock time in UTC. It performs the following steps when called. Let date be make day, year, month 1, day. Let time be make time, hour, minute, second. Let Ms. be make date.
Okay, I'm gonna run this, whatever.
MS 106 plus micro.
I almost clicked rebuild. That would have been bad. Would have been a 2-minute longer wait. Run. Please just work.
Entirely of code you.
There's some places I think I read a C file, and if I add a comment at the top, it might screw up whatever thing that was parsing a C file. But I think that's part of a different project in this project, so it might not affect this. I'll have to deal with that later. So everything's tagged. I think if this looks okay, any second now, whatever it's done. Some water. So dry.
I D E N T I F I or offset time zones, represented by strings for which as time zone offset string returns true. A primary time zone identifier is the preferred identifier for an available named time.
Copy. Copy. My throat. Where's oh, it's over here.
Each available named time zone identifier is associated with exactly one available named time zone. Each available named time zone is associated with exactly one primary time zone identifier and 0 or more non-primary.
Paste.
Implementations must support an available named time zone with the identifier UTC, which must be the primary time.
Then visually compare the last build to this build.
.402 Internationalization API specification are called time zone aware. Time zone aware implementations must support available named time zones corresponding to the zone and link.
It looks different. I think it's just the address is larger that the program started at and is using. I really hope that's the only difference. Because the rest of the program looks the same.
M E D capital T I M E capital Z O N E capital I D E N T I F I as specified in the ECMA 402 specification. Implementations that do not support the entire IANA time zone database are still recommended to use IANA time zone database names as identifiers to represent time zones. 1, 4, 1, 2, 0, capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C.
I think everything is working.
O, N, time zone identifier, year.
And I already saved a backup and
The implementation defined abstract operation, capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C, H, capital N, A, N, O, S, E, C, O, N, takes arguments time zone identifier, a string, year, an integer, month, an integer.
everybody go to YouTube. There's only like 50 people maybe they'll see this. But type in Death by Rami. And then stream her new song, whatever. Get her to like 1 million. And well, if you don't, whatever, karma's gonna be making its rounds, so you should probably go stream our music and get her 2 billion. So I'm like gonna leave the stream running for like 10 minutes or whatever, so the stream actually sends, because it doesn't always send. Where's this freaking mouse?
Time in the named time zone identified by time zone identifier, when the input represents a local time occurring.
So I'm not gonna be back, I'm just letting it run, and then I'll end the stream. So again, go stream this music video, get it to like 1 million or whatever, or I don't know, karma's gonna be making rounds anyways. Peace.
Light saving time begins or the time zone offset is increased due to a time zone rule change. The returned list will be empty. Otherwise, the returned list will have one element. The default implementation of capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C, H, capital N, A, N, O, S, E, C, O, N, to be used for ECMAScript implementations that do not include local political rules for any time zones. Performs the following steps when called. Assert time zone identifier as UTC. Let epoch nanoseconds be get UTC epoch nanoseconds, year, month, day, hour, minute, second, millisecond, microsecond, nanosecond. Return epoch nanoseconds. ECMA International 2024 469. Note it is required for time zone aware implementations and recommended for all others to use the time zone information of the IANA time zone database https://www.iana.org/time-zones/:30 AM on the 5th of November 2017 in America, New York is repeated twice, so capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C, H, capital N, A, N, O, S, E, C, O, N, America, New York, 2017, 11, 5, 1, 30, 0, 0, 0, 0, would return a list of length 2 in which the first element represents 5:30 UTC, corresponding with 1:30 US Eastern Daylight Time at UTC offset 4 o'clock, and the second element represents 6:30 UTC, corresponding with 1:30 US Eastern Standard Time at UTC offset 5 o'clock. 30 AM on the 12th of March, 2017, in America, New York does not exist. So, capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C, H, capital N, A, N, O, S, E, C, O, N, America, New York, 2017, 3, 12, 2, 30, 0, 0, 0, 0, would return an empty list. 1, 4, 1, 2, 1, capital G, E, T, capital N, A, M, E, D, capital T.
Okay, I lied. I'm back. You gotta go to Ivy Levon 2.
F, S, E, T, cap.
Type in biscuit. Because that's it's like the best music video ever. You gotta play her music too.
D, capital.
I don't know if she's making an album, but she's has a new music video or something. But anyways, you gotta play her music too. Or whatever I said earlier. Alright, peace. Or not.
O takes arguments time, zone identifier, a string, and epoch nanoseconds, a big int, and returns an integer. The returned integer represents the offset from UTC of the named time zone identified by time zone identifier at the instant corresponding with epoch nanoseconds relative to the epoch, both in nanoseconds. The default implementation of capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital O, F, F, S, E, T, capital N, A, N, O, S, E, C, O, to be used for ECMAScript implementer, shines that do not include local political rules for any time zones, performs the following steps when called. Assert time zone identifier as UTC. Return 0. Note time zone offset values may be positive or negative. 1, 4, 1. 2 time zone identifier record. A time zone identifier record is a record used to describe an available named time zone identifier and its corresponding primary time zone identifier. Time zone identifier records have the fields listed in Table 61. Table 61. Time zone identifier record fields. Note if is a primary time zone identifier. Then is field name, value, meaning, identifier, a string, an available named time zone identifier that is supported by the implementation. Primary identifier, a string, the primary time zone identifier that resolves to 470. Copyright sign, ECMA International 2024, 214123, capital A, V, A, I, L, A, B, L, E, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital I, D, E, N, T, I, F, I. The implementation defined abstract operation, capital A, V, A, I, L, A, B, L, E, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital I, D, E, N, T, I, F, I, takes no arguments and returns a list of time zone identifier records. Its result describes all available named time zone identifiers in this implementation, as well as the primary time zone identifier corresponding to each available named time zone identifier. The list is ordered according to the field of each time zone identifier record. Time zone aware implementations, including all implementations that implement the ECMA 402 internationalization API, must implement the available named time zone identifiers abstract operation as specified in the ECMA 402 specification. For implementations that are not time zone aware, capital A, V, A, I, L, A, B, L, E, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital I, D, E, N, T, I, F, I, performs the following steps when called. If the implementation does not include local political rules for any time zones, then return the time zone identifier record. UTC. UTC. Let identifiers be the list of unique available named time zone identifiers. Sort identifiers into the same order as if an array of the same values had been sorted using array prototype sort % with undefined as compare f and let result be a new empty list. For each element identifier of identifiers, do a let primary be identifier, b if identifier is a non-primary time zone identifier in this implementation and identifier is not UTC, Then, I set primary to the primary time zone identifier associated with identifier 2. Note: an implementation may need to resolve identifier iteratively to obtain the primary time zone identifier. See, let record be the time zone identifier record. Identifier. Primary. Append record to result. Assert. Result contains a time zone identifier record R such that R is UTC and R is UTC. Return result 1, 4, 1. 2 system time zone identifier. The implementation defined abstract operation system time zone identifier takes no arguments and returns a string. It returns a string representing the host environment's current time zone, which is either a string representing a UTC offset for which its time zone offset string returns true, or a primary time zone identifier. It performs the following steps when called. If the implementation only supports the UTC time zone, return UTC. Let system time zone string be the string representing the host environment's current time zone, either a primary time zone identifier or an offset time zone identifier. Return system time zone string. Note: to ensure the level of functionality that implementations commonly provide in the methods of the date object, it is recommended that system time zone identifier return a time zone name corresponding to the host environment's time zone setting, if such a thing exists. Capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital E, P, O, C, H, capital N, A, N, O, S, E, C, O, N, and capital G, E, T, capital N, A, M, E, D, capital T, I, M, E, capital Z, O, N, E, capital O, F, F, S, E, T, capital N, A, N, O, S, E, C, O, must reflect the local political rules for standard time and daylight saving time in that time zone, if such rules exist. For example, if the host environment is a browser on a system where the user has chosen US Eastern Time as their time zone, system time zone identifier returns American New York, ECMA International 2024 471 21 4 1 25 local time. T. The abstract operation local time takes argument T, a finite time value, and returns an integral number. It converts T from UTC to local time. The local political rules for standard time and daylight saving time in effect at T should be ed to determine the result in the way specified in this section. It performs the following steps when called. Let system time zone identifier be system time zone identifier if is time zone